security
do this,
of
we
the
perform a
packet
process
by
called
applying
mounting.
tunneling. There are
Mounting is
still
the act of
some
making a file
problems,
system
and this is
available
where
to the
encryption
users of the
comes
system.
into play. Suppose
The
that you
opposite
encrypt
process is
your
called
letters
unmounting,
in a way
which
that
is
only
disconnecting a
people
previously
working
mounted
in your
file system.
company can understand. In this case,
Unix
even if
systems
the
mount
postman
file
opens the
systems
envelope,
at mount
he
points,
cannot
which are
obtain the
simply
information
directories
because
somewhere
he will
within
see
the overall directory structure
non-understandable
of the
data.
system.
He will not
So if I
understand
plug in a flash
the
drive on a
encrypted
Linux
information.
machine, for example,
So, what we
that
have
flash
to do is
drive
very
may be
simple,
mounted
right?
at
We must
/media
encrypt the
/my
original
drive.
packet before putting it
I can
into
mount a
another
large
packet.
number
So,
of
let
different
me
file
back
systems
one
this
step
way
on
at
that
the same
direction.
time.
And for this
And
scenario,
I can make all of the
encrypt the
different
yellow
file
packet
systems
before
appear to
putting
be
it
part
in
of
the
one
red packet.
directory structure.
And then we put
On the
this
other hand,
encrypted
Windows
packet
systems
into
use
the red
drive
packet.
letters,
And
where the
finally,
letter C
this
is
packet
reserved
is
for the
sent
system
to
partition,
Andrew
the one on
over
which
the
Windows is
internet
installed,
safely. And there we
and
go.
A and B are
It's
reserved
that
for
simple,
floppy
guys.
drives.
We encrypted the original
Windows
packet
supports a
and put
maximum
it
of 26
in another
file
packet.
systems to be mounted
Thus,
at once,
we
simply
maximize
because
the
that's the number
security
of
of the
letters that
packet.
are available
Okay?
to
The
assign
term of
drives,
tunneling
to
comes
assign
from here,
partitions.
because packet is safe
So in
as
summary,
if it was
file
moving in
systems
your own
organize
private
data,
tunnel.
store
I hope
metadata,
that I
provide
made
an
this
abstraction
concept
of the underlying
understandable
storage
to you.
medium,
And
and
at this
arbitrate
moment,
access to the
the
storage
watcher
space.
needs to get the
We
original
create
packet.
file
And
systems
to
through a
be able to
process
do
known as
this, the
formatting.
router first eliminates
We can
the
make file
outside
systems
packet,
more
right?
robust
And
against
then
data loss
we
during
use
a
the
power
decrypt,
failure
the encrypted
through the use
packet,
of journaling.
so that it can obtain the original
Internally,
packet.
file
And
systems use
after
various
the watcher
different
gets the
mechanisms for
original
laying
packet,
data out
it
on
looks
disk.
inside the packet
But
and
no matter how
learns
they work
its
internally,
destination,
we
and
can make
sends
them
the packet
available to a
to
running
its
system
destination.
by
And
mounting
there
it.
we go. As a result, with the help of the WAN,
In
by
this
using
lecture, I'm
VPN,
going to discuss
we can
features
securely
of the
send
Central
company-related
Processing Unit, or
information
CPU,
from one
that are
LAN to
useful for
another.
supporting
But
multiple
never forget that
applications
there is no
sharing
such thing
computer
as
systems
100%
simultaneously.
security. This
In
means
particular, I'll
there may be
introduce
always a
multi-programming and
security
discuss the hardware
vulnerability for
requirements to
every
support
system.
multi-programming.
However, currently,
I'll discuss
WAN
CPU
networks
privilege
built by
modes,
using VPN
x86
technology are
protection
quite
rings,
satisfactory
mode
in terms
switches,
of both
and
budget
briefly
and
introduce
security.
interrupts.
Okay? I believe
The first
everything
concept
is
to
good so
introduce
far,
is
but some
multi-programming.
of you curious
And
can think
multi-programming
about
is simply
equation.
the idea that we
You
can run
probably
multiple
think like
processes or
I
multiple
constantly use
instances of
the
potentially
internet in
several
daily life.
programs
I
at the
send
same
mail
time.
to my friends. I
And we
use
can do this
e-commerce
by having the
websites, and I
CPU
do
switch
all of
quickly
these
among
over the
different processes,
So, since
enabling
the
all of
internet
them
is
to
a
make
public
forward
network, are
progress
all these
per unit of
operations
human
insecure?
perceivable time.
The answer is both yes
The
and no.
CPU will
Let me
switch
explain.
quickly enough to provide the
Assume that
illusion
you
that
want
all
to
the
make an
processes are
operation
running at the
on
same time,
Amazon.com.
even if
Now
we
let's
only
say
have one
you had to
processor
enter
core.
some information about your
In the
credit
vast
card
majority of
while
modern computing
purchasing a
systems, with
product.
the exception of
Since
some
this
special
information
purpose
will be
systems,
sent as a
are
packet over the
multi-programming
internet
systems.
to one of the servers on
Some of
Amazon.com,
the
they
old
absolutely
computer
don't want
systems of
anyone from
today
the
were
outside
batch
to see the
systems that only
information
ran
about our
one
credit card.
application at a
As a
time.
solution to this, an end-to-end
Now, in order
encryption
to
method
support
is used
multi-programming,
between our
we have to have
computer
certain
and the destination
features
server.
of our
And
computer
since
hardware.
the packet is encrypted,
First of these
nobody
is an
from the
interrupt
outside
mechanism
can
for
see the
enabling
information
preemption of running
about our
processes
credit card
whenever some kind
except
of
the
event
server of
occurs. We have to have a
Amazon.com.
way
This
of
is the main
stopping a
logic
process,
behind the
handling an
end-to-end
event, and
encryption.
then restarting the
Only the
process.
endpoints can
We need to
decrypt
have
the
a
packet
clock so that
and
we know
obtain
how long a
the
process
original
has been
data.
running,
Okay?
and we need to
However,
have
this
CPU
kind of
protection
encryption
levels
was
to
not
restrict
used in the
access to
past.
certain
And
instructions
this
to prevent
situation made it
processes
easy
from
for
hijacking
hackers.
the system
Imagine
or just
that
trying to
if
bypass the
information
operating
about
system
your credit
altogether.
card was
We
tried
also
to
need to
obtain
restrict
by a
access to
hacker
memory
in
or
pure
to
text.
prevent reading
This
and
is
writing
terrible,
to memory
right?
that
But
the particular
thanks to
process does
end-to-end
not own,
encryption,
belongs to
we
somebody else.
eliminate this problem.
Two
And
CPU
finally,
protection
I'm
levels
going
are
to ask you
sufficient
a
for
question,
protected mode
and
and
then
privileged
I'm
mode.
going to finish the lesson. Now,
These
you
modes
know
are
what
also
WAN
called the
is,
supervisor
right?
mode
In
or
summary,
kernel
WAN
mode and
represents
user
the
mode.
networks we create
In kernel
by
mode,
combining different
all
LANs.
instructions
In
on the
this case,
CPU are
my
enabled,
question is, what is
and
the
the kernel
largest
can
wide area
access all
network
memory
in the
on the
world?
system.
The answer
In user
comes to
mode,
your
the
mind
CPU
rapidly,
disables
isn't
all
it?
the privileged
The internet
instructions
itself
and
is the
restricts
largest
most
wide
direct
area
memory
network
operations.
in the world.
Thus, a user
However,
program
I
must
want
make a
to remind
system
remind you
calls to
again,
the operating
please
system
note
to
that
request
the
memory or
company's
perform
value
other resource
created with
allocation
VTM
tasks.
is different
In this
from
way,
the
the user
While
processes
one of
are
these vans is
effectively
completely
sandboxed
special to the
both from
company,
the system
the
and from
internet
each other.
is owned by everyone in the
On
world.
Intel-based
And,
systems,
yeah,
x86 and
That's all
x86
I would
64
like to say
systems,
about WAN.
there are
See
actually
you guys
4
soon.
modes available. These are implemented by what are known as x86 protection rings,
We
which
have
consist
learned
of
a lot
four
of
privilege
information
levels numbered
about
0 through
network
3.
devices until now.
Ring
And in
0
this
has the
lesson,
greatest
we
number
will
of
look at a few
privileges.
more cases by
Code
using these
executing in
devices.
ring 0
Let's say
can
we
execute
have two
any instruction
offices
the
belongs
CPU
to the same
provides
company.
and can
And
access all
suppose that
memory.
there are 100
Ring
meters
3 has the
between these
fewest
offices.
privileges.
If you
All
are
the
aware,
instructions are
this
restricted
distance is very
to a
short.
set of instructions
In
that
this
are
case,
relatively
what I
safe.
am wondering
In
is,
practice,
whether
most
or not
operating
we
systems
can
actually
connect
only
switch
use
1 and
ring
switch
0
2
and 3.
directly to each other.
OS2
create
and
a
Zen
lab.
are the notable
And the
exceptions
answer is,
that
we
make
can
use of
definitely
ring
do
1.
this. Because, as you know that,
Newer
we use
systems
switches to create
with
labs.
virtualization
Therefore, we
extensions,
can create a
either
lab
the
by
Intel
connecting these
VTX
switches to
extensions
each other,
or the
even
AMD
if they are not in the
extensions,
same environment.
add an extra
But
privilege
please note
level
that
below ring
distance
0.
is very
This
short
is
between
colloquially
these
sometimes
offices.
referred to
If
as ring
this
-1,
were not too short,
and
it is
this
impossible to
mode
connect
enables
these switches
instructions that
and
allow
create
multiple
a lab.
operating systems to share the
Meanwhile,
same
these
processor.
types of labs
These
can be
instructions help
called campus
system
area
support
network or briefly
hosting
CAN.
multiple virtual
Since
machines
these
at the
types
same
of
time.
networks are generally used on
And
university
regardless of the number of
campuses.
modes
Okay?
available,
On the other
whenever
hand,
we wish to
you know
change
that we
modes
can
for
also
whatever
connect
reason,
these two
we have to perform
offices
something
by
called a
using
mode
WAN
switch. And
between
that
CAN.
occurs whenever the
please note
CPU
that
switches
WAN
into
and
user
LAN
mode
are different
kernel
kinds of
mode,
network
or
types. This is
hypervisor,
important.
or
And
whenever
you can
an
see the packet
x86
stand
CPU
with tunneling
changes
in
which
the animation.
protection ring is presently effective.
There we go.
Mode
Yeah.
switches have the potential
I
to be
believe
slow
so far
operations
everything
compared
is
to other
good.
machine
But
instructions,
I want to ask
depending
you
upon the
a question.
hardware.
Which
A
one do you
notable
think
example
is
is
more
the first
secure?
generation of
Bandwidth
Intel
VPN
Core 2
or
series
LAN
processors,
created by
in
connecting
which the mode
switches
switches
directly?
into and out of
Please think
hypervisor
about it
mode
for a short
are
time
quite slow.
and try to answer it.
One situation in which a mode switch might occur is when something called an interrupt happens. And
The
an
answer is so
interrupt
simple,
is simply a
isn't it?
situation
A LAN
in which the
is
currently
always more
executing
secure
code is
than a WAN,
interrupted
because
so that an event
communication
can
with
be
a
handled
LAN
by
the
the
packet
operating
never
system.
passes over the internet.
Interrupts can fall
The
into two
packet always
categories.
moves
You can have
on our
involuntary
own
interrupts,
On
which
the
are
other
external
hand,
to running
even if the
processors.
packet is protected
These
with a WAN,
consist of things
the
such as
packet
I/O
still
interrupts,
passes over the
generated every
internet.
time you press
And
a
as you
key
know, there
or
is never
perform
such a
any
thing
other
as
I/O task.
100% security,
Clock
even if the
interrupts,
packet is
which are
protected
timer
with
mechanisms
tunneling
scheduled
and
to
encryption.
go off at a
So,
particular
to
time.
summarize, both
And
of these
page
methods
faults,
are
which have to do
secure,
with the virtual
but
memory
LAN
subsystem.
is more secure. This is
Interrupts can
obvious.
also be voluntary,
However,
in other words,
there is a
created
condition
by
that a
a
WAN
process that's
is
running.
almost as secure as
System
a LAN,
calls and
and we
exceptions
call
such
private
as
WANs
site fault
for
or
this
divide
type of
by zero
WANs. Likewise,
actions
you
can
have heard
result
about
in interrupts
this
as
WAN
well.
type before. I mean,
And the
this is
CPU
different
provides
from
hardware
bandwidth
mechanisms
VPN
for
because
detecting
the
when
line
an
between
interrupt is
offices
occurring
is
and
dedicated
handling
for the company. You request
So in
this
summary,
line from the
multi-programming
ISP
systems
and
allow
give a
multiple
special menu
applications to
for
run
this line.
simultaneously.
Thus, the ISP
Implementing
gives you a
multi-programming
private line
ports
that
requires
only
support
your
from
company
the
can
hardware.
use.
In
We
particular,
call the
when
WAN
CPU
created in
privileges
this
are
way
due to clock
is
and
private
some kind
WAN.
of interrupt
Okay?
handling
And
mechanism.
please remember that
CPUs
you are using
used in
public internet
multi-programming systems
networks
need to
with
have at least
bandwidth
two privilege
VPN.
levels.
And that's
The
why
Intel
we also
x86
call
systems
bandwidth
support
VPN
4 or 5
as
nodes
public
depending
WAN.
on the
This is
processor.
very crucial.
Node
In
switches
addition,
can be
even
expensive
the
in
private WAN
terms of
sounds great
performance,
at
so
the
we
first
don't want to
glance,
do more than
it can
necessary.
be quite costly.
And
For
interrupts
this
enable
reason,
hardware
it
events
makes
to be
sense for an
delivered to
average company
applications,
to
and they
prefer
allow
public WAN
applications to yield
instead
control
of
of the
private
system
WAN.
while
You
waiting
know,
for events
public
or
WAN
waiting for
provides us
services.
security that we definitely cannot underestimate, right?
Lecture, I'm going to
Wonderful.
discuss kernel architectures.
Now, I want
I'll
you
begin
to
by
pay
introducing
attention
the
to one
functions of
point.
the kernel,
Some of you may have
explain
already noticed
separation
this,
between
but
mechanism
it
and
will be
policy,
good to mention
talk
in
about
any
some
case.
seminal
We
early
use
kernels in
switch
the history
devices
of
to
computing,
create a LAN,
and then
while we
introduce
use
differences
routers to
between
create
monolithic
a WAN.
kernels and
This is
micro.
very vital. I want to repeat this again.
A kernel
We use
provides two
switches
functions.
to
The same
create
two
a LAN,
functions as in the
while
operating
we
system.
use
It
routers
provides
to create
abstraction
a
and
WAN.
arbitration.
This means
The
we
kernel
cannot
provides
create a
abstraction
WAN
in the
by
sense
using
that
switch
it
devices.
provides a mechanism for
a
programs to access
fundamentally
hardware,
represents connection
a
of
way to
different
schedule
LANs. With the help of
multiple
WAN,
programs
different
on the
LANs
system,
can act as if they are
and
in the same
provides some
environment.
method for
And you know
inter-process
that
communication,
if you want to
IPC,
connect different
a
LANs,
way made for
We
programs to
definitely
send messages
need
to
a
each
router
other,
for this
or send
task.
messages to
You
hardware
got the point.
devices, or out to the network.
And now, I want to talk a little bit
Kernels
about the
also
router.
provide
Until
abstraction
now,
mechanisms.
I have
They
always
ensure that a
explained the
single
router
process
as
or
an
running
internet-related
program
device.
can't take over the
However,
entire system.
it isn't. The main
Of course,
task
any
of the
kind of
router
security
is to
requirements,
connect
such as access
different
privileges
networks.
that might
That's
take
it.
place on
You
the
should
system.
realize that
And
these
they minimize
networks
the risk
may
of
be in
tunnel system
different parts of
crash
the world,
from a buggy
or
application
maybe
or
in the
device
same
driver.
office. It really doesn't matter.
It's
And
important
in
to
this slide,
distinguish
you can
between
see that
mechanism
two
and
different
policy
plants in
when
the same
discussing the
office
internal
are
components of an
connected to
operating
each
system.
other thanks to the router
The
device.
mechanism, put
Suppose that
simply,
one of these
is the
networks
software
is
methods
related
that
to the
enable
marketing unit
operations
of
to
the
be
company,
carried out.
and the other
An
related
example
to
of
the
a
software
mechanism
unit.
would
And
be
as
code
you
that,
know, if we
implemented
want
inside a
different
device
networks
driver,
to communicate
sends a
with each
message
other,
to a
we
device
should
that
use a
causes
router.
that device to
In
blink a
the
light,
animation,
enable
we
a
can see
camera,
that
or
LAN
perform
1
some
and
other
LAN 2
hardware operation.
communicate through the router.
Policy, on the
There
other
we go.
hand, is a set of software methods that enforce permissions, access rules, or other limits against an application.
And here, I
So,
want to give
policy,
you
for
additional
example,
information
would be
about the router.
something that
I
said
want you
only
to focus
users
on the
met
cables
certain
of the router.
criteria to
If you
send
are
a message
aware,
out to a
each
hardware
cable
device
is
to
connected
blink a
to a
light
different
or
network.
enable a
I mean,
camera,
one of
perform
the
some other
cables
hardware
is
function.
connected to LAN 1, one of
Generally
the
accepted
cables
principle
is
of good
connected to
design,
LAN 2,
the
and one
mechanism
of the
and policy
cables
should be
is
separated
connected
as
to
much
the
as possible.
This is the case for the router.
An early
Like
kernel separated
different
mechanism
networks,
and policy quite
for this
well
reason,
was
each
the
cable
Regis
connected
Central
to a
RC4000 monitor
represents a
that
different
had
networks
Peregrine
are
Hansen
needed
or
in the same
the Regis
office.
Central developed
You may want different
Denmark.
nodes in the office to be
The
in
central
different
component
networks.
of the system
This
was a
might be
small
absurd
nucleus
for an
is
office with 4 computers.
called monitor,
Imagine
which
an
allowed
office
programs
with
to
50
send
computers
messages to each other
divided
and
these
allowed
computers
programs to send
into
and receive
units
buffers,
increases
which
hierarchy
were
and order.
essentially
Never
types
forget
of messages for hardware
As you can
to
see,
and from
the
different
basic
hardware
principles
devices.
are the same
In particular,
everywhere.
at that
These
card
basic
reader,
principles
tape
you can
reader,
enable devices
and
with
a
different parts of the
printing
world to
style output
communicate, and
device.
we can enable devices in
Other
the same
kernels
office
with
to
different
communicate.
scheduling
Both of
mechanisms
them
and other
represent
capabilities
the
could
same
be run
task.
under
I
monitor.
think
In
you
those
understand
days,
the
not
concept very
clear that
well.
multi-programming
That's all
was really a
I want to
desirable
say
feature
in
of
this
computing.
lesson. See you guys
Thus,
soon.
someone could write a multi-programming capable kernel and actually run that as a subkernel under the
In
monitoring
one of
system.
our previous lessons, I
Importantly,
told you
this was also
we
the first
purchased
system
this
that
cable
allowed
that came to
subkernels
our home
and systems
from
level
ISP.
software
Mention
language,
what exactly
in this
ISP
case,
is.
Pascal.
And in this lesson, we are going to
The
discuss
system
what is the
performance was
ISP
actually
and
quite awful.
why it is so
Frank
important.
Hansen stated that the
Internet service
operating system
provider, or
itself
briefly
was so
ISP,
slow at
is
performing its
responsible
IPC
for the
tasks
transmission of
that
packets from
there were
one
a number
location
of issues
to another.
with the system
If you remember, we
completing
have
the
looked
tasks
at
on time.
there are a lot of
However, the
routers
system
in the
was
heart
stable
of
and
the
reliable,
I'm talking about this
making it
structure.
successful in
And
computer
We
science
can think
history,
of the ISP
even if it
as
was
the
not a
mechanism
successful
that
product
controls
commercially.
all these routers in this structure. For
On the other
example,
hand, the
there are
opposite
actually
extreme
many
would
routers
be the
in
Unix
this
kernel.
global ISP.
This was developed at Bell
Similarly,
Labs by
there
a
are
team
many
headed by
routers
Ken
in
Thompson
this
and
regional
Dennis
ISP.
Ritchie,
But
also
to
starting in the
simplify
late
the concept,
1960s.
I didn't visually
The
show.
difference between the
routers
Unix kernel
within
and
the
the
ISPs.
RC4000
However,
monitor
I want
was
you
that
to
the Unix
imagine
kernel's
that
design
routers
implemented performance.
distributed around the world are
Thus, instead
controlled
of having
by
a
these ISPs.
very
It's
small
very
kernel that
Think of
simply
it
provided
as
an
if each
IPC
ISP
mechanism and some
controls
basic
specific routers,
resource
and
collision
packets are sent
avoidance,
from one location
this
to
kernel
another
actually
location
provided
over
all the
these
device
routers.
drivers,
We
all the
previously talked
scheduling,
about
all the
how
memory
the packet
management,
travels from one
including
point to
support for
another via
multi-programming,
routers.
directly
Understanding
inside
this
the kernel.
situation is the first condition
This kernel
to
was an early
understand the
example
ISP.
of what would later be
What I am
called
trying
a
to say
monolithic
is,
kernel.
certain
A
ISPs
monolithic
are
kernel is a
responsible
kernel
for
that
certain
contains the
routers.
entire operating
I want you
system
to
in
imagine
kernel
that
space,
every ISP
runs
you see
all
in
of
this
the operating
picture
system
is
code in
responsible
privilege
for
mode,
certain
or
routers.
ring 0
Okay?
on an x86
But I am
system,
removing them from the
and
visual for the
divides
simplicity
the different
of the
functions
concept.
of the operating system
In
into
addition,
subsystems of the
ISP
kernel.
model you see here
All
is
of
a
these
simplified
subsystems,
model.
however,
But
are
even
run
if the
in the
model
same
is
memory
simple,
space.
it is enough to understand
This has
the
the
most
advantage of
important
higher
parts of the
performance,
concept.
but the
Let's start
disadvantage
with
is
basic
that the
definition
kernel
of the
becomes
ISP.
less modular and more
ISPs
difficult to maintain,
represent
and the
companies that
components
serve
are not
us
separated
so that
very
we
well.
can connect to the
So a crash in one
Of
component
course,
could
the
impact the
entire
entire system.
or disturbance. You cannot
Opposite
connect to
of
the
this, the
internet without an
RC4000 style
ISP.
kernel
Think
is
of
what we
ISP
now call a
as a
microkernel.
structure that
A
allows you
microkernel
to
basically
connect to the
contains the bare minimum
and
code
ISP
is
is not a
necessary
single
in
structure.
order to
There are
implement
hundreds of
basic
thousands of
addressing
ISPs in the
interprocess
world, and
communications.
all speeds come together From the
This
structure you
basic
see
amount of
in
code
the
runs in
visual,
kernel
there
space.
is few ISP in the
Everything
visual,
else
I know that,
runs in
but
user
I can say
space.
that there are
often with
hundreds
lower
of thousands of
privileges.
ISPs in real
As a
life.
general rule
The
of
most
thumb,
common ISP type in
microkernels
the
contain
world
less than
is local
10,000
ISP,
lines of code.
and now I want to start with it.
Microkernel-based
The first
operating
step of
systems tend
connecting
to be
to the
quite
internet
modular
is to
because
communicate
they
with
divide
the
the
local
operating
ISP.
system
And
functions
local ISPs
between
are
the kernel
generally
and
responsible for small
servers
area
running
communication.
user
For
space.
example, the communications
However,
of two
because
different
many
plants
of the
in the
core
same
functions of
neighborhood,
the operating
or
system
communication
or
of
user
plants
space
located in
components have
neighborhoods
to
close
communicate
to
with
each
each
other.
other via the kernel
Let's say we live in
before
the
it
USA,
does
and
something.
these two homes are located
Thus,
in the
most
same
kernels are in
neighborhood.
use hybrids of
Want to
these two
communicate with
designs.
this computer,
I'm going to introduce
provide
Murphy's Law of
directly
reality,
over this
sort of an extension
This is
of Murphy's
You
Law
can
of
see this
community
in
familiar.
the animation.
And my definition of Murphy's Law of reality is simply that reality is the hazy space between the extremes of competing academic theories, in which everything is wrong in some way,
In
at least
general,
according to the theory.
the local ISP is responsible for
This
the
idea of a
communication of
hybrid
small
kernel
areas
architecture is
the packet
controversial.
and also pass
Some
through
people like to
routers
use this
before
terminology
reaching
at all.
its destination. You can
Many
think of
people
this local
prefer to
ISP
keep the
as the
binary
ISP that
classification
only
of
connects
monolithic
LAN
kernel and
within
microkernel.
a neighborhood.
However,
Of course,
if we
the
look
local
at modern
ISP
kernels,
can connect different
typically
neighborhoods, but
monolithic
in this
versions
scenario,
of kernels
let's
are
take
broken
example.
into modules that
Therefore,
can be
one
loaded
router
on
can be
specific
enough to
runtime.
connect them.
This
You
helps
got
to
the point.
increase maintainability of the kernel.
And
And true microkernels
an
today would have
example of a
unacceptable
small local
performance.
ISP office.
Thus,
And we
microkernel-based
call these
systems
offices
typically
point of
have some of
presence,
the features
or
of
briefly,
monolithic kernels,
POP.
such as more
In
device
fact,
drivers and other
routers
code that
distributed
runs
over
inside
the
the
internet
kernel's
are
memory
included
space.
in these POPs. And
Some
in this
examples
POP, in
of
other
different
words,
types
this
of kernels
office,
for
routers
monolithic
are on
kernels,
the left
in
side.
addition to the System
In
5
addition,
Unix kernel,
you
which
have
is
probably
descendant from
noticed
the
that
original Unix.
there are other
We
devices
have Linux
than
kernel,
routers.
BSD,
Because
MS-DOS, and
sometimes we
Windows
must
9
put
X
different
kernels.
configurations with
Windows
different devices.
NT,
Hence,
XP, Vista,
it
and
must
7,
have
if you
routers,
don't prefer to use the
switches,
hybrid
servers,
terminology,
and so on.
would also
But the
qualify
device
as
we use
monolithic
to connect
kernels.
different networks
And
to
the
each
Mac
other
OS
is
10
the
kernel
router.
falls into the
For
same
this
category.
reason, we will only focus on
In terms of
routers.
microkernels,
And
the
in our previous
RC4000 monitor
lessons,
kernel would have
routers
been the
on the
earliest.
internet
However, there have been
were
plenty
actually
others,
represented
including
POPs,
Mach,
spread over the
L4,
world.
the
And
MIT
in order to
exokernel
explain this
project,
better, I want
and
to talk
the
on a
idea,
different
at least,
image.
behind the
But
Windows
in
NT
this
kernel,
image,
which
I
was
want to
based
think
upon microkernel
different
design.
sources
The
and
same is
offices
true
connected
of
to
the
local
Mac OS X
ISP2
kernel,
and local
since that was
ISP3.
originally based
I
on the
mean,
Mach
we won't
microkernel.
talk about these
However,
ones.
those have
You
been
got the
heavily
point.
modified and now have many
There we
properties
go.
of monolithic
As you can
kernels
see,
also.
a home and a small
So in
office
summary,
top
the kernel
over
is the
local
minimum
ISP2.
layer of software
So,
inside
this
the operating
POP
system
is
that
the
provides
first
the
point to
basic
be able to
foundations for
connect to the
abstracting away
internet
details of the
for this
hardware
home
and
and this
arbitrating
office.
between
This should
multiple
be clear.
applications.
For
When they're used, we call the
You
result
might
a
think that
microkernel. On the other hand, have all their major OS
in this
components
way,
contained within
LANs in different
running
neighborhoods
everything
can
inside kernel
communicate
space
over
for
local ISP2
performance.
effectively. And
Two
from
early
here,
influential
we can
kernels
draw
were
the
the
following
RC4000 monitor,
some
an
local
example of a
ISPs can
microkernel,
have more than
and
one
the
POP.
original Unix
However,
kernel, which was an
some local
example of a
ISPs
monolithic
can
kernel.
only have one POP.
In practice,
This depends
however,
on the size
most
of the
modern
local
operating
ISP.
system kernels
For
are
example,
hybrids of the two
If a
designs
local ISP
and have
connects four
features
different
of both kernel
neighborhoods,
types.
it may have four different POPs. But if a local ISP connects only one neighborhood,
Via
it
command
has only one POP.
In
You
part
catch
1 of
that.
this lecture,
And
I'm
if you
going
want
to
to do more
discuss
detailed
command line
studies on this
operation,
topic, you will see
introduce
many
paths in the
resources
file
on the
system,
internet which
discuss
run
the
right.
file system
You should
hierarchy,
be aware that
talk
these
about the
items
contents of the
actually
root
represent
directory,
the water
give an
within the
overview of
POP.
several
There are
top-level
many POPs
directories,
distributed all over
briefly
the world,
discuss
and
configuration
routers
files,
are in
and
these
introduce the
POPs.
concept of
It's
man
that simple.
pages.
At this moment, I
In
want to
Linux, the
imagine
command
that there
line
are
is the
hundreds
older
of
type
thousands
of
of local
interface or
ISPs
user
in the world,
interface to the
and
system.
these local
It is a
ISPs
text mode
connect to regional
interface that
ISPs
predates the
that are
development
larger than
of
them.
graphical
This
user
means that
interfaces or
different
GUIs.
local ISPs
The
communicate
command line
over
uses
regional
keyboard
ISPs.
exclusively.
For example,
In
local
general, there is no
ISP2
use of mouse,
communicates with local
and it
ISP3
works by
over the
having to
regional
type in a
ISP1.
command,
As a
followed by
matter of
any
fact,
arguments to
you
that
can
command,
think of
and then
local
pressing
ISPs
enter.
connect
command
neighborhoods
runs, you
and
can
regional
if there are any
ASPs
results to be
connect
displayed, the
cities
result
in a
of the
country.
command is
It's
displayed
that simple.
below
I want to
the
repeat this
command.
again. You can think of local ASPs
At all times,
connect
the command
neighborhoods
shall
or small areas
虽然奥
process
密克
and
戎
regional
肺炎
ASPs
传播率
connect
小，传播
cities
速度
in
快
a
is in
country.
但是它的
something
传
called a
播方
working
式
directory.
Meanwhile,
与之
That
前
working
there's
的
one
directory is
regional
the
ASP
location
in
on
the
the file
simplified
system
model view.
in which
今
any
天
But
来
file
in real
讨
life,
论
creates
a
by
country
default will be
can
placed.
have many regional
And
ASPs.
you can
And
open
all
files by
local
default
ASPs
without
and
having to
regional
give
ASPs
any kind of path
combine
information.
in order to create
You can figure out what the
of a
current
country.
working directory
In
is
summary,
by using the
the first step is
PWD
connected to the
special working
internet
directories
is
command.
local ASP.
You
And
can
this
change
line
directories
represents
using
the
the
line we
command
purchased
cd.
from the local ASP.
此外，
Running
针
through
对奥密
cd
克
Every
戎肺炎
home
中
or
的高风
office
险
will take you
must
to your home
purchase such a
directory.
line from the relevant
You can
ISP.
list the
及
contents
时
of
监
the
测全
directory
局基
with
础
the LFS.
Examine your home routers
It's typical
carefully.
that someone
Now,
who's
yeah,
using
yeah,
Linux
yeah,
for
yeah,
some
Coming from
time
your ISP.
will
及时记
compulsively issue the ls command.
Now,
Every
let's
time the
suppose
cd
that
command
this
is used,
computer and
so
this
that you can
computer
maintain some
want
kind
to
of
communicate
awareness
with
about
each
how
other.
the file
By
system
the way,
is structured.
these two homes are located in
Paths
the
in
USA,
the file
but
system
they are
can
in
be given
different
in one of
cities.
two ways.
As a result,
They can be
they are
given as
connected to
absolute
different
paths,
local ASPs.
meaning
This
that
is
they have
obvious.
a leading
So, in this
slash,
situation,
such
how
as
will this
slash
local ASP
专家表示，
communicate with
大
this
家
local
平时
ASP?
也要做
slash
好
hot
各自
slash
健康
con
监
In
测。
fact,
如果
this
出
is
现
where
发烧、干
the
咳、
regional
咽
ASP
喉
one
痛、
comes
流
into play.
are
要及时
relative
In
就
to
general,
医。
the
whatever
regional
the
如果
current
ASP
要
working
做
is
好
directory
engaged
the
in the
shell
communication
is
of devices in the
Thus,
same countries
in
and in
relative
different
path
cities.
myfile.c
Look carefully at
is
the
going to
animation.
refer to a
Local
file
ASP
named
is communicated
myfile.c
over the regional ASP.
located
It's
in the current
obvious,
working
right?
directory.
And
专
there.
家提醒，
Tests
目前
slash
国内外
final
多地爆发
slash
局部
p
疫情，
underscore
大
all
家
At
不要
this
惊慌
moment,
，is going to
some
refer
of
to
you
a
may be
file
wondering
that is in
why
the
there is
final
no direction from
subdirectory
local ASP
另
to
外，有
test
多数
local
领导的居
ASP 3.
民
This
对
is
感
not
染
the
病毒
expected
开始
current working
But
directory.
just think about it. If we connect
There are
local
also
ASPs to
special
it,
relative
the
path
hierarchy is
components
broken.
that can be
I
used.
专家介绍，
You see
此
very
次
few
全
local
中国
ASPs
地区的
in
single
this
dot
scenario. But
references
in
the
real
current
life,
working
there
directory.
can be many local ASPs,
Two periods
even in the
or
same
two dots
city. And if we
references
connect
the
them all
parent
together, complexity will
Thus,
definitely
path
occur.
dot
And we
dot
don't want to
slash
increase
foo
the
slash
complexity
dot
of this
slash
system.
bar
It is already
means
quite
go up
complex.
one directory for
So
the
that's
current
why
working
we use
directory,
a central
then go down to
hierarchical
its
ISP
subdirectory
structure
foo
as you see in the
and access a
video.
file called
With the minimum number of
bar.
connections between ISPs,
Notice
we
that the
ensure
single
that
dot
all
known
ISPs
as part of the
communicate with
directory
each other.
path
Each
generally
ISP.
has no effect because
So
it
far,
refers to
we have talked
the
about
current
local
directory.
ISP and regional ISP. Also,
Now,
computers that
all
communicate with
directories
each
on a
other
Unix
were
system
always in the
are
USA.
organized
But
according
what
to
if
file
computers
system
in different
hierarchy,
countries
and
want
there
to
is a
communicate with each
specification
other?
available
And this
for
is
the
where
file system
the global
hierarchy,
ISP
which
comes
different
into play.
distributions
You may think that
follow
the global ISP
different
connects
levels,
devices in
and the
different
standards
countries
get
in
interpreted
general.
a bit between
As you
these
know,
types of
there is an ocean
distributions.
between the USA
In
and
case,
China.
however, the
So,
root
if a
directory of
device
the
in the
file
USA
system
and
is
a
located
device
at
in
a path
China wants to
consisting of a
communicate,
single forward
it must
slash.
be a global
You
ISP
can change
that
the root
provides this
directory by
connection.
running
We
cd
cannot
and
connect
then
these
as
two
the argument
devices
of cd,
with only
just
local
a single
ISPs
forward
and regional
slash.
ISPs. And as you
In
can
this
see in the
screenshot,
image,
you can see
there are multiple global ISPs.
I've run
And these global
cd
ISPs are the
slash
part of the
and
hierarchy.
then run
And by
ls
using
to
them,
look at the
these two
contents of the root
computers can
directory.
communicate with each other.
There are a number of
Let's
top
assume
level
that
directories
this
that are
computer
fairly
wants to
standard
communicate with this
inside
computer.
the root
In
directory
this case,
on a
the
normal
package
Linux
will
system.
first go to the local
These
ISP
include
server
slash
here,
bin,
and
which
then
is where the
go to the
minimum set
regional ISP
programs
one.
needed to work with
And
the system
the
is
packet has
located.
two options at this
Slash
moment.
dev,
This
which
path
contains
or this path.
entries
In other words,
corresponding to
global
hardware
ISP
devices
one
on the
or
system.
global ISP 3.
Slash etsy,
I hope you
which
understand that.
contains the system
Its
level
selection is
configuration
determined
files.
by the routers in
Slash
the regional
box,
ISP
which
one.
contains
Each
optional
router
software
makes
typically
a
added by
choice,
the system
and as a
administrator.
result of these
Slash
choices,
USR,
the router's
office
path
mount
is
slash
determined.
user,
Let's say
which contains
the packet will be
software
forwarded
that
to the
shares
global
with
ISP
the
one,
Linux
and there
distribution.
by
Slash
the way,
var,
packet
which contains
that
rapidly
will pass through
changing
regional
files such
ISP
as
one
log
may
files.
go to the global ISP
Slash
3
disk, which contains system libraries used by other programs, slash media,
Let's say
into
that
which automatic mounting systems will
run
mount
level ASP1
drives
to level
and
ASP2. And there we go.
/MNT, often read /mount,
The packet
which
can
is
be
the system
sent
administrator
locally
manually mount
or direct
moving
regional
devices or
to
network
or
shares.
globally speaking.
/root,
Either way,
not to be confused with the root directory,
destination
is actually the home
Sometimes
directory
users
for the super user or root
can follow
user.
different paths. And I want to show
/sbin
you some of
contains
these
super
paths.
user
For
binaries
example,
or programs that are intended to be run only by the system administrator.
regionally
And /temp
locally
are
speaking,
temporary files are typically stored.
or from globally
As
speaking,
mentioned a moment ago,
direct regionally
system-wide configuration files generally go
and
in
destination,
/exe.
or
Two
from
important
globally
examples of files
globally
/exe
regionally locally
/etc, which set the
and
default run
destination again.
or whether
All
the
of them
system is going to
are
use
suitable
text mode graphical text.
You should also have noticed the
/exe
situation here.
/fstab
If the
contains
destination of a
file
packet
system
was this hard,
indicating to the kernel
which
where
destination
and
directly
find different
over
file
local
systems need to be
SB6
known
without
to
going over regional SB2.
configuration files in general
Local
are Linux
SB can be edited with global SB without
monitoring
regional
command line
SB.
system
This
is
is very
called
important.
the VI text
As
editor.
you know,
VI is one text editor
represents small
that is
companies.
generally expected to
And
be
in
present
some
in
cases,
any Unix.
these small companies may want a direct connection
Need
to
help
the global
with
SB
command or
to
some
provide a
configuration
fast
file.
experience to its
There is
customers.
a built-in multi-service
Actually,
called
there
man
are two ways
pages or
to
man
this kind of connection in general.
Man pages allow you to get help with
Connects
particular
directly with the
commands
global
and
SB.
other features of the system.
Location can
Simply
be
by
very
typing
suitable
man
for this
equals
purpose.
space and then the command or
Whether
feature
global
in which
SB
the
can already have an default
To
structure
navigate
of
through
this
the man
location.
page, you can use
However,
the
little global
and then
SB
use
doesn't have an infrastructure in this location. A lot of extra
the next
money
part of the
must be
lesson
paid for this
file
connection
permissions
by
and
local
other
SB company
basic
to the global SB company. You catch the idea. And for this packet on the global SB feature, let's say
I will
it
continue
is
discussing
regional
the basics of utilizing a Linux system.
or global SB tree.
In particular, I'll talk about file ownership,
Packets
file
will go
permissions,
to the local SB system
listing
or
running processes, finding
As you can
libraries
see,
used by
local
a
SB7 is
determining the
connected
absolute
directly
path
to the
of the
destination
program,
map. Therefore,
discuss the role
local
of the super
SB7
user
knows that
in the system.
where it will send the packet.
First, we'll start with file ownership and
Finally,
permissions.
有人上钩后
Each
会
file
搜寻他们
on
的
a
直
Linux
播
system
下载直播
is
软
going to
件。
have an owner,
其实下载的直播
a
软
group,
件
as a
是一款
result,
无
and
法
I
预测
have
access
的，
learned
能够提
how
取
to
对方手
use
机
the
上的对话数
information
information
called
program
and
communicate over the
by running the ls command with a dash lowercase l argument.
routers and ISP with
It
each
is
other.
possible to
And
change
for access,
which
we are
user
going
on
to
the
cover
system is
two
the
more
提取到了
scenarios
通讯录。
related
第
to
二
the
步就是
ISP
引入
content.
了有识别
See
播
guys
表。
in a moment.
The change group chgrp command allows you to change which group a
Let's
file
see our nostalgia. This is our
and
home.
permissions for a file can be
The
changed
newly
with the
established
chmod
website
or
为了
called
预防诈骗骗徒事件
abcx.com.
会从色情
The
网站
owners
上
of the
下载
website
一些黄
have
色图
limited
像
financial
或聊天
funds
窗
for
口
this
推送
reason.
给对方，
They
让
have
对
all
方
the
误以为是
masters
在
of
讨
the
论。
three levels of
So,
access.
to be able to reach abcx.com,
Access controls are set with bitwise order of permission groups.
This is
The
how
value of 1
对
is
方
used
用
for
语料
execute
刺
permission.
激将他的
Meaning
画
the
面
file
录
can
下
be
来，
treated like a program
录
and
下了对
executed
方的我聊
directly.
画面。第三步就是
The
威胁
value of
对
2
方索要
is
钱
used
财，
for write
索要
permissions,
钱财
meaning
也
if
是分
someone
步
could
进
And
行。
change
after the
首
server
先
of
是
the
与对方谈判，要么
abcx.com
给钱，
and
要
the
么
value
公
of
开
request
我要
4
视频，
is
逼
read
对
exchange
方同
being
意。
able to
对
read
方
the
做反
content
就
of
表
the
示
file.
你
creates
尽
a
管我
response
可以
message.
继续挑战。
Individual file permissions are supported for three
Information about
classes
the web
of
page
user.
we want to enter.
Owner of the file,
Images, videos,
members of the
HTML
groups
file,
with which the
and
file is
everything
associated,
related to the web page.
and
Meanwhile,
so-called world
if you don't know what
permissions.
an HTML
All
file
users
is, you can think of it as
他
the
们会根据
skeleton
对
of the
方
web
的经
page
济
in
状
a
况和心
C++
理状况，
can be done
以
with
此
And
以
after
便威
generating
胁对
the
方，
response
直
message,
至障
the
碍。
and
server
by
must
example,
send it
the
to us.
file can be
However,
set to be
最
you
后
can't
一步，
prefer
他
by
们
the
会通过
response
专业的
message
确诊公
to
司
be
将购买的
writable
前
only
夕
by
by
its owner.
那在本
by
版
the
中，
request
对方
message.
提供
Please
的
pay
是
attention
与
to
方
this.
方面细
Oh,
节
that
的
is
755,
他们会
There
根
is
据
no
对
way
方
to
的
know
经
the
济状
exact
况、
part
心
of a
理状
message
态，以
beforehand.
各种借
a
口
file
want
can be
to
set to be
have
read,
any different
detected, and
purposes
readable
inside.
only by the
I
owner
mean,
of the group.
but for a
By
message
running the
is
same
always
他们
CHMOD
会通过
common
专业的
on
确
the
诊
way.
公司向
Never
客户
forget.
采集。 那在本案
In the
中，
first
As
example,
soon as we receive the
755
response message,
means
the
permission
website
7,
appears
which is
in
4
our
plus
web
2
browser.
plus 1,
For example,
meaning read
now you want
plus
to
write
enter a
plus
website.
execute.
You first send a request message
The
to the
owner
server of
sets the
website,
first number
and
of
the web
permission.
server receiving your request
First
message
5,
sends
second
you
number
a
of
response
set
message
permission to
which
convert.
contains all information about the web page
Press
you
1
want to
to
execute.
execute makes
And
5.
when this message
And the
comes to
same
you,
for
your web browser
1
runs all information from this response message and displays the related web page in your web browser.
The 4
And
means
the
read
surprising
only
thing
for
is,
the owner.
every time you want to
Second
enter
4
a
means
website,
read only for
this
the group.
process happens again.
And 0 means
However,
no
when
access
this
whatsoever
process takes
by
place
people
in
who
your
are not
site,
authorized.
you don't realize that there are complex operations in the background.
Permissions on a directory
And now,
are slightly
let's
different.
try to enter
If a
google.com
directory is
instead of
executed,
abcx.com
the
and see
contents
what
of the
happens.
directory
You
change
know,
reverse,
Google is quite different from
allowing access to readable
abcx.com.
files and
Since it's
subdirectories
designed
in the directory itself.
unlike
Read
abcx.com,
permissions on a directory are necessary
distributed all around the world.
to be
And
listed.
with this distributed
For
service
someone to
structure,
obtain a directory
Google
listing
provides
without
a much
us,
more
they
efficient
must
and
have
fast service
read
to
permissions
its
and
customers.
execute
And let's say
for
one of
that
these
directory.
servers is not far from our
Files can be deleted
Therefore,
on a
when
Linux
you
system
want to
with the
enter
rm
google.com
or
or
short
when you want to get any service
Entire
from
directories can be
Google,
replicated using
this
rm
server, which is
dash
closed.
rf and then supplying the directory name
Process
to
will
delete.
be much faster.
This can be an extremely dangerous command
Why
if
big
run
companies put
incorrectly.
many servers
For
in different
example, running
locations around the world?
rm-rf slash as the root
That
user
in the
will
fastest
delete every
and
single
most
file
efficient
on the
way.
system and
And
it will not ask for
server
it.
structure
This will leave the
is a great
system in a
solution
destroyed
for
state.
such a design. I believe
There is
we have
also
done
no
it.
undelete
So
function
when
in
we want
most
to
Unix
request a
processes.
service from Google,
Once the rm
our
command
request
is
message
used,
will
the
go to
file
this
is
server
gone.
close to us.
And unless
You
that
know
file
that
has been
how
backed
the
up,
packet
it
reaches
is
the
not
related
easily
server
recoverable.
with the help of ISPs. And you know that
When working
working
with
happens
a Linux
after
system,
this
it's often useful to see what programs or what processes are running on the
This is
system.
the service we look at.
There are two commands that can be utilized in
Communicating
order
with
to find this
customers
information.
sometimes
The
not
first of these
satisfactory
is
for
the
Google.
PS command, which stands for
Wants to
process.
please distribute in general.
PS space
Fortunately,
AS
Google
will
has
allow
a
you
good
to see
solution
all
for
processes
this kind of
currently running
issue
on the system.
called
To
hearing.
find out
But
which user
what
runs
exactly
each
is hearing?
process, run
Let's see.
PS space
Hearing
AS.
is the technique which Google
Command
establishes a
is a
direct
useful command
with an
for getting
ISP
current
to
information
provide
about
trusted
the system,
access to its
including
server.
running processes,
If you can see on the
amount of
animation,
available
Google
memory,
connects
and amount of
directly
CPU
to Google Play. Thus,
This
when you
command
want to get a
displays
service from
processes
Google,
that are using
you will
voice
be able to
CPU
communicate
and
directly with Google
updates
servers
itself
without
every
using
second.
ISP
This
infrastructure.
command will
In this
exit
way,
by hitting
Google
Q.
can communicate with the customers much more
See what
effectively.
dynamic libraries are used by a
This model
binary
is
program,
everything
not
is good.
scripts.
But what about
An actual
security?
compiled binary
Since the number of
application,
public hubs
one can
that
use
packets
the
pass
LDP.
through decreases
So
thanks
if
to
one were to
hearing.
run the LDP
Security
command,
increases so much. And
slash
the
user
packet
slash
goes
data
directly
events
to Google
for
via
systems
local
that
layer.
have
In other words,
installed.
packet does not use
One
public
would find
ISP
out which dynamic
infrastructure.
libraries were
Communicate
used in order
with
for that application to run.
Remember that security is very important
It's also
for
possible
large
to find
companies.
out the
And
absolute
it's
path
obvious
of
that
an installed
this
program
great
to
connection
see where it actually
the
resides in
possibility
the
to be
process.
obtained for the packet
This is
from
done
the
with
outside.
which command.
One,
For example, typing
the
which
last fundamentally
should
I want to
display
give
slash
you an
user
example.
slash bin
As
slash
you know,
events
YouTube is
on
owned
what
by
its
Google.
distribution.
So,
Provided
when
the
you
source
want
that
to watch
appears
a
as
video
well.
on YouTube, you are actually using
Finally,
Google's
there is
distributed
one
servers
administrative
around the
user
world.
on the
And
Linux
we are
system
all aware
called
that
super user.
YouTube works very efficiently.
As the account
When
name
you
of
want
the
to
group,
watch a video on
it
YouTube,
has
you can
privileges
watch it very
to
well.
read,
You
write,
won't be
or delete
interrupted
any
whatsoever.
content.
The
To
main
change
reason
system
for
settings
this
and
is
install software,
distributed server structure
and
and the
perform
viewing
other administrative
infrastructure
tasks
of
that are
Google.
normally
On the
permitted
other
by
hand,
third-party
you may
users.
sometimes see freezes
On
and
some
interruptions
Linux distributions,
while watching videos on Udemy.
and on Mac
Because
OS X,
Udemy's
the root
infrastructure
user
is
is
not as
disabled
strong
by
as
default.
Google in general.
However,
Of course,
many other
Udemy
distributions
also uses
including
the
Red Hat
distributed server
Enterprise
structure, but
Linux,
this
CentOS,
number
Arch,
is probably not as many as
user
Google. This is
accounts
obvious.
In整个装置的动力部分呢，
on
这是
systems
Udemy
受力
where
最大的
doesn't use
一组
Python.
是
And you
100
know that
Or
is a very efficient technology,
like to disable
especially
root scale.
it increases
The
student
pseudo
inequality.
allows authorized regular users to run a command
I can say that
as
Udemy did a
So, for
significantly
example,
good job
you
overall
can find the
because
listing of roots in the directory
users
by
of
typing
at the
sudo
same time
ls.
is a really challenging engineering problem.
Switch the super user temporarily on the
Here
system.
is a very effective
Sudo
strategy
su
by
dash
giant
entering the
companies
user's
like Google, Amazon, and so on.
the user temporarily become the
And
root
finally,
user, even if
I
the root
want to
code
give
is
you
disabled.
some general information about IoT.
Enable
As you know,
su
global
dash
IoTs are
has one
responsible
effect
for the international communication. I can say that.
Instead of
Also, definitely not as many as the regional
discuss
IoTs.
interrupts
There are
and
a few
device
global
input
IoTs
output.
in the world. And you can guess that the
Hardware
technology
devices
for
on a
that
computer
technology
produce
only a single
events.
global ISP in the world.
Need some way of being able to handle those events within the operating system and deliver them to
Like
applications.
load balancing and efficiency,
And hardware
there are
devices are going to
also
produce
some
events
financial reasons
at
for it.
times and in patterns that we don't know about in advance. For example, we don't know which key the user is going to press on the keyboard
honor a
until
lot
the
of
user actually
All of
presses
that,
the keys.
right? If you have
Cat
a lot
walks
of money,
across the keyboard,
establishing
we're going to see if we see
company
different
is
patterns
a
of
good
pressing,
choice. It
from
will
which we can
probably
expect
make you
to
smile
see
with time.
the human user.
By the way, we also call
Similarly, we
Internet
have
Network
incoming network
Network
packets for running a server application or even just a workstation.
Familiarity to
And the
Internet
messages coming in from the network.
can be useful
We
for
don't
you.
know the order timing
In
of those
addition,
messages.
there are structures
We also don't
called
know when the mouse is going to be
exchange points
or when any
known
other
for the Internet platform to work separately and for
So
global
how
ISPs
can we get the
to
information
communicate
generated
with
by
each
these
other more
events
efficiently?
and make it available to our application?
ISP or IX.
Well, we have two options. First option is we can poll each device and ask each device to get any new information and retrieve that information.
to the Internet.
同样的也非
You
常
can
适合
work
现在的这样一
with
个
visual
现在的
现在的细节呢，就是到处活动。
These ISPs
And
have
have the operating
a
system
for your location.
stop whatever it's doing and pick up that information.
只要是能让这个发电站
Starting
转
gradually
它就可以
and
源源
make
不断
your
的
choice
电力。
according
所以这里
to
呢，也建议大家可以
Involves
自己手
iOS
产生
periodically polling
如果以
each
后有
device
机
for
会的话，
information.
ISP
So every so often, the CPU is going to send a message
呢，也
to each
分享
hardware
过
device in the system
来给这个
and
发
say,
电
hey,
站
you have
这
any
个
data
方
for
式
it?
via local
大
ISP.
家如果有
And
兴趣的
most
话
of the time, the device is going to send back, no,
把这个
you
发
don't
电
really
机
have
如
any
果
data
充
for
能
you.
在前面装上风
Other
电，
times,
新
the
的观众呢
device
应该
will
先
send
发
back
现
some
后
data.
面装上
What
了
I
一
am
个风
trying
向
to
标，
say
风
is
向标呢
if
就是
you
让
want
这
to
个
get
风力
your
发电
ISP
装置
service
实时
extremely
给
simple
客户
with a
提供。
certain
风向
company,
标呢，它不
but
可以
this
同时
company
这个风扇的
doesn't
功
serve
能，
your
而且
location,
它可以
First
根
problem
据
is
自己的
that
人
most of the
提供为
time,
这个风扇装上最大的
the
功效。
devices are
时
not
间上
being
我
able
只
to
为了
data
给大家这个
the
实现效果
ISP
最大，
company
直接上了两个100瓦左右的这个信号和一个1000瓦左右
Second
的
issue
数
with
据功能。
viewers is
大
high
家看到这
latency.
个装置
but
提示
for
发电
companies,
这样的一个地方，
this is
That
very
procedure
unfair.
is not going to get
不知道
transmitted
大
to
家
the
觉得这
computer
个装置怎么样？
until the next
如果
time
你喜欢这个视频的话，希望
on
你可
their
以留言
location
说
asking
and
keys to compress.
benefit from it.
或者你有任何的想法或者是建议的话，也可以在评论区里面说，我们可以一块
I
来
have
交流
good
一下想法。
responsiveness,
视频最后呢，
but
感
the
谢
CPU
观
is
众
not going to get any
更多支持
useful
关
work
注。
We
done.
talked about the ISP.
On the other hand, if we set that
You
time
got
limit
a lot
we
of
want the
people.
CPU to get some work
If you
done,
want,
there's going to
we
be a
can
noticeable
only
lag
speak
between the
about
time
the
that
ISP
key
on the
and the time
However,
character appears on the
that's
screen.
all I have to say.
Since the device must wait for a polling interval because it can translate input, we're going to have a high latency situation. And again, shortening that polling interval to try to reduce the latency simply wastes a whole lot of CPU time checking devices that have no input. So a better mechanism is to use a system called interrupts. And with interrupts, hardware devices actually signal the operating system whenever events occur. Or more precisely, they signal the CPU, and then it's up to the operating system to receive and handle that signal. What the operating system will do is it will preempt any running process. In other words, it will switch.
This course will help someone with no technical knowledge understand how the internet works.
Basically,
Ian Frost teaches this course with tons of visuals, just like he has taught thousands of people on Udemy.
The internet
this allows us a more responsive system than we could ever achieve through polling,
国家大调效
without having to waste a whole bunch of time asking idle devices
every
to
word What happens
However,
if
this
the
does
edge
require a more
drag you
complex
into a webpage? If
and
your
that
answer to all
implementation
these
complexity
questions
is the end of
you are
hardware level.
definitely looking at the right course. In this course,
Specifically,
I assume
within the
you don't know
CPU,
anything.
you need to have a
And
mechanism
slowly
for
explain
checking
what the
and
internet
responding to
is.
interrupts.
You don't need any prior
And
knowledge.
this mechanism is
Follow this
implemented
course.
as part of the
This
CPU's
course
fetch
tells you
execute cycle.
everything from scratch.
In the process
with
of
many
fetch
abstractions.
execute, the
These
CPU will
abstractions
fetch an instruction from
allow you
memory,
to understand the
increment the
subject
program
without
counter,
knowing details. I
execute that
say
instruction.
everyone who uses
But
this
instead of simply going
No,
back to
you
the
need
next
to say
step, the CPU actually has to have additional hardware to check to see if the interrupt event is negative.
It needs to know
If
that.
there is an interrupt event,
It just
then the
means
CPU has to be
all
switched to
over the
kernel
world,
mode
and
that's
in this
running in
course,
user mode,
we will
so
go
the
on a
privilege
journey
level needs to
together.
be escalated.
We will look at
The
all
save
these
program
concepts
counter
in a very
will be
visual
shown
way.
at the stack.
You will see
And
exactly
look
how
at
the
the
interrupt
program
works
counter in a
with your
fixed memory
eyes.
location.
In addition,
And that
at the end
fixed
of the
memory
course,
location
there are
is
some
called
questions
the interrupt
related to
vector
this
table,
course,
or
and by
IVT.
answering them, we can benefit
Reload
from
the
this
program
course
counter from the
at the
IVT,
maximum
and
level.
then the
Okay?
CPU goes and
Regardless of your
executes
age or
that new
profession,
instruction
this course
the
is
next
for
time the fetch
everyone.
execute
You
cycle
will
resumes.
absolutely understand
The
what
CPU
the
actually
internet
moves from
is
executing
when you
program
finish this
code
course.
to executing code
Let's dive into it.
interrupt handler for the particular event. If no interrupt is pending at the end of an execute, then we simply go back to the next instruction.
Now, we are going to talk about a
The
scenario.
interrupt vector table
Let's say you are the
consists
system
of an array
administrator of a small
of
company,
addresses
and
of
your boss
handlers.
wants you to enable
Each
all these
element in
computers
this array
to communicate
essentially
with each
gives the
other.
program
And PC1 should
for
be
the
able to
handler
communicate with
for a
PC7,
particular
or
interrupt. This
PC5
handler is going to
should
be in a
able to
subsystem of the
communicate with
kernel from
PC4,
monolithic
and
kernel,
so on. You got
where
the
this
point.
handler
But
might
the
be
question
called
is,
to an
how to
execute
build
server
such a task?
or a
And
microkernel.
this is where the
In
switch
any
device
case, however,
comes into play.
first
The
handler
switch
by
is the
convention,
device we use
element
for
0 of the
computers in
array,
the same
is always
environment
the handler
to
for the
communicate
clock.
with each other. When I
Then,
say in the same
handlers for
environment,
different
what I mean
devices
is that
are in the
I'm
array
talking
after
about
the clock handler.
computers in the same office,
So
house,
the interrupt
or
vector
in very
is
close
always
distance to each other.
mapped into
And
the user part
This
of memory.
scenario
It's
is a
always
good example
available at
for
all
such a
times,
situation.
so
There's
that
an
the kernel
office,
can go and
and
look
in
up
this
interrupt
office,
information
we have
whenever
7
is
computers
necessary.
that communication of them is required.
An interrupt is
Wonderful.
processed
We have a
by
switch
branching the
to
program
accomplish
counter
the
to the interrupt
communication of
handler,
computers. This is good.
executing interrupt
However,
handling code,
The question is,
and then
can
at the
these
end
7
of the interrupt
computers
handling code,
communicate with each
there'll be
other
an
right
instruction
now?
to return
And the
from the
answer is
interrupt.
big.
In the
No,
Intel assembly language,
because
this
first
is
of
the
all,
IRET
these
instruction,
7 computers
which
need
loads
to
the process
interact
program
with the switch
counter back
somehow.
from memory
But
and pops the
how
stack
can we do
to
that?
get the original
I know
program
that you
counter
have
back,
some ideas,
and
and you
goes
are
ahead
probably
and
guessing
changes
right.
the CPU
We
back to
must
user
use
mode, so
cables
it removes
to
the
connect
privilege
computers
escalation.
to the switch. As you can see,
The
we
interrupt
are
handling
connecting all the
mechanism
computers
is
to the
thus
switch
able
with
to
the help
handle
of cables.
events from
We
hardware
generally use
devices
copper cables
without
for
having
this
to
task,
pull each
and the type
device
of these copper
individually. I'll
cables
be
can
discussing
generally
interrupt
be
controllers.
Cat5 cable
In
or
particular,
Cat6
I'll
cable in
introduce
small
the old
environments.
and new
By the way,
mechanisms for
Cat6
delivering
cables are
interrupts
faster than
from
Cat5
hardware
cables,
devices
and
to the
Cat
CPU.
represents category.
These methods
Okay?
include the original
On the other
programmable
hand,
interrupt
in addition
controllers
to copper
and the
cables,
new
some
advanced
switches
programmable
support
interrupt
fiber
controller
optic
with
cables
message
as
signal
well. And
interrupts.
it is important to note that fiber optic
Interrupt
cables
controllers provide
are
an interface for
generally
hardware
much
to
faster
signal the CPU
compared to
whenever a
copper
device
cables
needs attention.
in data transmission.
It's
This
important
is
to
very
note that
important.
this signal
And
only
for
includes
switch
a message
devices,
that essentially
there is
says,
a
"Hey,
crucial
I'm a
point to
device,
be
I need
aware of.
attention."
Please
The
note that.
CPU
If
historically
there's a
then
switch in
actually
the
does have to
environment,
go and pull the
and if
device
you want to
and get
connect
any data the
computers to
device
that
may
switch,
have.
we must definitely use a cable that
The
is
older
generally a
mechanism
copper cable
performing this
or
operation
fiber optic
is called a
cable.
programmable
What I am
interrupt
trying to
controller,
say
or
is,
PIC,
with wireless
that
technology,
actually require
you cannot
dedicated
connect
lines to be added
computers
to the
to a
motherboard.
switch. Switches
The
all work
ISA,
with
or
cables.
Industry Standard
This is very
Architecture
vital, guys.
bus,
If you want to use
which
the
dates
switch
back
device,
all the way to
you
the
have to
first
use
PC
cable
back in
to connect your
1987,
devices to the
and
switch.
older versions
It's
of
that
PCI, or
However,
Peripheral
if you
Component
want to
Interconnect
connect
bus,
computers in the same
utilized
environment
this
to each other
mechanism.
by using all the wireless
The new
technology,
mechanism
you
for
can
the
use an
advanced
access point
programmable
device
interrupt controller
instead of a
is
switch
used on
device.
PCI Express
you can use
devices
both a switch
and
device
some
or
newer
an access
PCI
point device
devices.
in order to connect all unstable
The old
computers.
controller,
Both of them
programmable
separately
interrupt controller,
acceptable for this
actually
purpose.
consisted
The
of
only
two
difference between
programmable
these
interrupt
devices
controller
at
chips
this point
that
use
were attached
wireless
to each other.
technology while
With one of the
switches use
chips being attached to the
cables. Okay?
CPU.
There are 7
So-called
computers in this
master chip
environment,
was the one
and
attached
we
to
can
the
connect
CPU,
these 7
and
computers
pin
by
2
using
of
switches
that
and cables,
master chip
just like you see in
is
the
attached
picture.
to a slave chip.
Or, in the same way, we can use an
Each
access point
pin
device
on each of the
instead of
two
a switch
chips
device.
allows
If we use
for
an access
16
point
interrupt
device,
numbers to
access
be
point
created.
uses wireless
Interrupts
technology
0 through
instead of
7
cables,
are
while
correspond to
communicating
the
with
pins
device.
of the
In
master
summary,
chip,
both the
and
switch device or
interrupts
an
8
access
through
point device
15
enable these
correspond
7
to the
computers
pins
to
of the
communicate
slave
with
chip.
lobbies. But
Now, it
one
should be
uses
noted
cable
that
and the
since
other
pin
one
2 of the
uses
master chip
wireless technology.
handles the slave chip,
Anyway, what I
that
just want you to
the
know
master
right now
programmable
is
interrupt
we
controller
generally use copper
only
cables
supports
in order to
an
connect
effective 7
computers to the
interrupts.
switch in the
So there are
environment
only
such as a
15
hub or
usable
office.
interrupt hardware
By the way,
lines,
I want to
for
focus on the
devices.
switch device
and
instead of
these
the
are
access
numbered
point
0
device
through
in this
15,
course.
but we have to skip the number 2.
And at this moment, all
Now,
these
historically,
computers
pin
can
number
communicate
0,
with each other,
which corresponds
because
in software
they
terms
connected
to what
to
we
the
call
switch
interrupt
by
request
using
line,
cables.
or
And this
IRQ
means that
0,
they
was
created
connected to the
a
timer.
network. In other words, the
Interrupt
reason that
request line
these
1
computers
was
can
connected to
communicate
the
with each
keyboard.
other is all of
Different
them
ISA and
are in the
PCI
same
devices
network,
could
and
then
we
use
call
the
this
remainder of
special
the master
network
chip
as
by
local
connecting
area
to
network,
IRQ lines
or
3 through
briefly
7.
LAN. A
On the
local
slave
area
chip,
network
pin
is a
0,
collection
which
of
corresponds
devices
to IRQ 8,
connected together in
was
non-physical
connected to the
location,
real-time
such
clock.
as a building,
Pin 4,
office, or hub.
corresponding to
As I
IRQ
just
12,
said, if we
was
want to
connected
create
to
a LAN,
PS2
this
mouse.
location must be a restricted
Pin
location
5,
in
or
terms of
IRQ
area,
13,
and
connected
we
to the
cannot
math
create a
processor,
LAN between
which was a
computers
separate
located in
component
United
from the main
States and
CPU in
computers
earlier
located
PCs.
in Russia. On the other
And
hand,
then pin 6
this
and 7,
area is
corresponding to
very
IRQ
suitable
lines
in
14
order
and
to
15,
create a LAN.
connected to the
Therefore,
IDE
these
controllers.
computers
These were
can
used for
communicate
disk
with each other
and
because
eventually for
all of
optical
them
devices.
are on the same LAN with the
This
help
left
of the
pins
switch.
1
So,
through
we
3
can deduce that
on the slave
if you want to
controller,
create a
or
LAN,
IRQs 9
we
through
need
11,
a switch device.
available
By
for
using a
hardware
switch
devices.
device, we can create a local
These
area
interrupt
network.
lines on the
And if
motherboard
we
were
consider
actually
millions
circuit
of
traces.
local area
These were
networks all
conductive
over the
paths
world, we
etched
can
into
easily
the
understand
motherboard
how important
that
a
allowed
switch device is.
interrupts
You
to
might
be
think that
received
all
from
the houses in
devices.
the world are actually a
There
local
were
area
15
network.
lines
You
available
have a LAN
of the
in your
16
house,
to be
or
used by
your
devices,
neighbor's
with
home
lines 0
also
and
has a
1
LAN,
reserved
or
for the
there's
timer
also a LAN
PS2
in the
keyboard,
office where you work.
respectively.
Okay?
Actually,
You
even
catch
before
the
the PS2 reservation,
And
the
now,
original AT
let's take a
keyboard.
closer look at the communication of computers.
ISA and
and
PCI
what
add-in
these lines
devices
actually
actually had to
represent.
share
Let's
interrupt
say
request lines.
PC1 wants to send
And
a
this
message
sharing could
to
lead
the
to hardware
PC6.
conflicts
By
that
the
could
way,
lock up the
the
system.
messages generated
It was
by
thus up to the
computers
system
has a few
owner
special
to
names.
manage the
Some
sharing
people
by
call them
setting
as
little
packets,
jumpers
and
on
some
the
people
add-in
call
cards
them
so
as
that the
frames.
cards were using
Both of
different
them is
IRQ
okay, but in
lines.
this course, I prefer to
There
use
were also
packets
performance
instead
issues
of
when
frames.
IRQ lines were
Okay,
shared, because
PC1,
the operating
you
system
send a
actually had to
packet
poll
to the
each
PC.
device sharing an
As you see
IRQ
in the
to
vision,
determine which
packet
device it was
first
that
goes
raised
to
the
the
interrupt.
switch,
Polling
and
is still
then the
necessary
switch
in order to
looks
receive
at
any
the
kind of
inside
data
of
from
the
the
packet
device,
and
regardless
learns the
of whether it was
destination
sharing an
of
interrupt
the
line or
packet.
not.
And finally, the switch sends the
On
packet
modern
to its
systems, a
destination.
completely different
And
interrupt
if
mechanism
PC1
is used,
can send a packet to
and
the
this
PC6,
mechanism
this means that
has a set
PC1
of
and
memory
PC6
registers on
can
what's called
communicate with each
advanced
other.
programmable
The
interrupt.
logic is basically this.
And this
If
set
a
of memory
computer can
registers
send
is
a
connected
packet
to a single
to
shared
another
bus.
computer,
Each
this
device
refers
on the
to
system
these
can
two
use
computers
to
are on the same
raise an
network,
interrupt message
they can
by
communicate
writing
with
that
each other.
message into one of
This
the memory
information
registers.
is so
These are
crucial,
called
guys.
message signal interrupts
However,
using the
maybe
MSI
by
and
looking at
MSIX
only this
specifications.
switch image, what the switch
Essentially,
device
each
actually
device
is
here had a
may not
timer,
be fully
RTC,
visualized in your mind.
USB host
For this
controller,
reason,
SATA
we will
controller,
now examine this
attached
slide
to the
for you
bus,
to understand
and
the event better.
indicates its
This is
interest
the real
in
version
raising
of a
an
switch
interrupt
device.
to
And
the
as you
APIC
can
by
see,
sending a
there are
message
many
over that
ports
bus.
on a switch
Now,
device. This is
this
important.
message does
Also,
not
the
contain any
number of
data.
ports
It's only a
varies
request
from
for attention.
one switch device to
The
another switch
CPU
device.
has to be
different
involved in
switches
the
have different numbers
operation
of
of
ports.
sending sending or
Some
receiving
switches have
information.
tampons, while
Then
some
CPU
switches
actually
have
has to
more than
contact the
20.
device, in other words, pull
And
it
of
directly.
course, this generally
There is a way
makes
around
plan
this called
increase
direct
in
memory
price.
access or
Okay.
DMA
By
transfers,
the way,
which are used
these
extensively on
ports
PCI
have
Express
a special
devices.
name and
The
they are
register
called
on
LAN
the
ports.
APIC stores
probably
the
makes sense
request
to you
for
because,
attention
as you know,
until such
we
time as
create
the
LAN
operating system
by using
handles
switch
the interrupt
devices.
request,
For
and
this
then that
reason,
message
I
is
think
cleared from the
it is
APIC.
so reasonable to call
This
these
is the
ports
only
LAN
interrupt
ports
mechanism
because
that's
by
available
connecting
for
these
PCI
computers
Express buses.
to these
There
ports,
are no
we
hardware
can
interrupt
create a
lines.
LAN. And
However,
in addition
a
to
number
this,
of motherboards
there are LAN
still
ports on the back
have
of our
interrupt lines,
computers
physical interrupt
or
lines,
on the side
and
of our
have
laptops,
physical
just like
pins,
these LAN ports.
so that they can
You
support
can see the
legacy
related
devices.
visuals
A
on the
number
right
of
side.
specialty legacy devices still in use that need to be supported. Message signaled interrupts do solve a number of problems with interrupt request sharing. The original specification allows
And
each
to
device
establish a
to use
connection
any one of
between
32
computers and
IRQ
the
lines.
switch, we connect
The
the LAN port on the
MSIX
computer
specification
and the LAN
will
port
allow
on the
each
switch
device to
with
use
the help
up
of
to
a cable.
2048
So, let's
virtual
do this.
lines.
Let's start with
Virtual
this
interrupt
port
request
and
buffers,
PC1.
essentially.
Then,
And this
let's
allows
connect
for
this port
less
and
contention
PC2.
and
After
reduces
that,
the
let's
need to
connect
share
this
interrupt
port
request
and
numbers
PC3.
by
And
device.
finally, I want to
Thus
make a
reduces the
connection
amount of time
between
necessary
this port
for the
and
CPU to
PC4.
determine which device
Wonderful.
needs attention.
And
So
currently,
main thing
these
to take away
computers
from
can
this is
communicate
the
with each other.
interrupt
But
controller
how exactly
and the
does this
interrupt request
communication
mechanism
happen from a
only
switch
allows the
perspective?
device to raise
Let's
a
take a
signal
look
that
at
says
this.
it wants attention.
Let's say
It's up to the
PC1 wants to
CPU
communicate with
or on certain
PC4.
buses
So,
the device
it will
and
send a
the
packet
memory
to the
controller
PC4.
to get the
This
information
packet
out of that
will go to
device
this
and
port
into
of the
memory.
switch first, and
You
there we
interrupt
go.
handling at the hardware level,
Afterward,
and then
that
move
port
on to
will
features
give the
provided by
packet
the
to the
CPU,
hardware inside
and
the
finally
switch.
features of the operating
Then,
system for
the
handling
switch will look
interrupts.
inside this packet and
At
learn
the hardware
its
level,
destination.
devices are
After
connected
that,
either
the
via
switch gives
traces
this
on the
packet
motherboard
this
or
port
via
that is connected
a
to
shared
PC4.
messaging bus
And
to
finally,
the advanced
the
programmable
switch sends
interrupt
the packet
controller.
to the PC4.
The CPU checks for
Wonderful.
hardware interrupt signals from this
And to
controller
summarize,
after
currently,
each user
we have
mode
connected
instruction
these
is
four
processed.
computers to each
So
other.
after each
thanks to the
instruction is
switch.
executed,
This means
running
we have
some
created a
particular
local
program
area
on the
network,
system,
and these
the
computers,
CPU actually
and
checks to
easily
see if there are
communicate
any
with each other
interrupts that need to be
since they're on
processed.
the same LAN.
If an
I
interrupt
hope
signal is
everything is
present,
quite good software.
then a
And
kernel
the
routine
switch
is called by the
device is visualized
CPU in
better
order
in
to
our
handle
light,
this
thanks
interrupt.
to this slide.
The interrupt
There's a
dispatch
little
routine
Let
is
me
not
explain.
implemented directly
You
in
are
hardware.
aware,
It
our
is actually a
computers
compact,
work in the
fast
same
routine
network,
that can be
and
implemented in
we
the
have
kernel,
only talked about
often coded in
communication
assembly
between those
language. It has
devices.
to be that
We have never
fast.
talked about
The
how these
specific
computers
interrupt
can
handler
connect
is
to the
always a
internet,
kernel
right?
routine,
So the question
or
is,
in the
can
case of a
these
microkernel,
computers
an external
communicate
server
with the
routine.
internet
And
just
this
by having
specific
this switch
handler
device?
depends upon the
And
type of interrupt
this,
received.
my friends,
These are
will
typically
be the
coded in
question
C.
that we are looking for an answer
So
in
once
the
again,
next lesson.
fetch execute
See you
cycle,
guys soon.
we check for an
Bye.
interrupt pending after each instruction is executed. If there is an interrupt pending,
In our
we
previous
escalate
lesson, we
privilege
briefly
to kernel
talked
mode,
about how to connect
push the
computers
program
in
counter
an
onto the
office.
stack, in
And
other
how do
words,
we
save
create
it so
an
we
app?
can resume
And
from
I
that
said
point
that we
in
can
whatever
create a
program
LAN
is interrupting,
with the help of a switch
and then
device.
go and
But the
handle the
problem is,
interrupt. We
currently
do
these
this by
computers
loading the
can
program
only
counter, the new
communicate
program
among
counter,
themselves.
that is,
They cannot
from a
communicate
fixed
with
memory
the
location
because the
provided
only
to us
task
by
of
the
the
interrupt
switch
vector
is
table.
to create a LAN and
The
enable
interrupt
the
vector
communication
table
of
gives us
devices
the address
in the
of
same
all the
LAN.
different interrupt
Great.
handlers.
And by the
We
way,
need a separate
I would
handler
like to
for
remove
each type of
this LAN
interrupt.
statement from the video
Clock requires
because
different
we
logic
can
from
understand
keyboard,
that
for
there
example.
is a LAN here.
Other devices,
we
such
can
as,
look
say,
more
a
comfortable.
webcam attached
One.
to your computer,
And the main
needs
question is,
different logic
how
in
do we
order to
connect
process
these
messages from it.
computers to
So
the
we
internet?
have
And
different
this is
interrupt
where
handlers
the
for each
router
of these
device
devices.
comes into play. Let me
The
explain.
table
The
simply
main
stores
task
the
of the
addresses
router
of
is
each
to
handler.
enable
And
computers
in our
connect to
monolithic
the
kernel case,
Without
the
a router,
handlers
it
are
is
actually part
impossible
of the
for us
kernel
to
and are
connect to the
mapped
internet.
into
And in
kernel
order
memory
to provide
space.
this connection, in order
The
to
interrupt
provide a
vector
connection
table
to the
consists
internet,
of
first
a
of all,
list
we must
of each
connect
of
this
these
switch to
addresses
this
of
router.
kernel
And
handlers,
this
and
cable is a copper cable,
conceptually
just
is
like
mapped
other cables.
into both
This
kernel
is good,
memory
but
and
currently,
user memory,
what we
so
have
that
to
it
do
can be
isn't over.
accessed
We
quickly.
still
And
can't
historically,
connect to
they
the
started
internet
at
in this
address 0.
situation because
However,
we need a
mappings
connection
are different
between
depending understanding of
router
architecture.
and the internet as well. And as you
On
know,
Intel-based
special cable
systems,
comes
we
to
have
our
something
homes
called the
or
interrupt
offices,
descriptor table.
this cable is
And
given
the
us
IDT
by internet
provides
service
special
provider.
instructions
And
and
thanks to
data
this
structures that are actually
cable,
managed by the CPU
have
itself,
never heard of
so the
internet
interrupt
service
handling can be
provider?
as fast
Don't
as
worry,
possible.
we will talk
And
about it
protection
in
rings can be
detail.
changed
But for now,
automatically.
All you need to know
The
is
IDT is simply
the
a
internet
reserved
service
block of
provider
RAM
is giving us
used by the
this cable for a
CPU
certain amount
to
of
jump
money
quickly
so that
to a
we
specific
can
interrupt
connect to the
handler.
internet easily. Okay?
This
So,
IDT is
currently,
mapped into
We
kernel
have
space,
everything necessary
which was
to connect to the
originally
internet
beginning at address
by
0.
using these
But
computers.
this mapping is actually
Hence,
flexible with
let's see
modern
the basic
CPUs and
tasks
can
of
be
the
mapped
switch
into
and
other
route
parts of the
one
memory
by one
space.
on the
The
animation.
first 32
These seven
entries of the
computers in
IDT
the
are
office
actually not
can
used for
communicate with
interrupts
each other
per se,
thanks to the
but
switch.
they're
For
actually used for
example, let's
CPU
say
fault
PC1
handlers.
wants to
And then
communicate
the
with
interrupt
PC5.
vector table
For
part
this purpose,
of the data
PC1
structure
will send a
begins
packet
after the
to the
CPU fault
PC5.
handler.
So, as you know, the packet firstly goes
When
to
we
the
actually
switch,
go to
and
handle
afterwards,
interrupts,
the
the
switch
handling
learns
occurs
the
in the
destination
kernel.
of the packet.
And this is
And
done
finally,
with two
the
levels
switch
of
sends the
interrupt
packet
handling.
to its
The fast
destination.
interrupt
There we
handler
go.
and the
This is
slow
how
interrupt
two
handler.
computers in the same
The
lab
fast interrupt
communicate
handler
with
is
each
a
other.
piece of
And
code
please,
that's invoked
always
directly
remember,
from
the
the
switch
interrupt
device
vector table
is
whenever
enough
an
for us
interrupt
in order
occurs.
for
This is a
communication
piece
of
of code
devices
that the
in the
CPU
same
is
lab.
going to jump
On the other
to
hand,
when the
a
interrupt
router
occurs.
has no role in the
Fast
communication of
handlers execute
different
in real
devices
time, and they're
in the
called
same
fast
lab,
interrupt
like
handlers because
PC1
they
and
need to be
PC5.
fast.
This is
The
very vital.
execution of
Okay?
one of these interrupt
I hope
handlers needs to be
I will
short.
explain the event.
If
And
any large-scale
guys,
data transfer needs to
what if
occur, say we need to get a
PC1
lot of data
wants
from
to
the device
communicate
all
with
at
the
once,
internet? In other words,
this
what
operation
will
is handled
happen
by having
if
the fast
PC1
interrupt handler
wants to send a packet
enqueue something
to the
called a
internet?
task into the
Let's
operating
see.
system's task queue.
First of all, you should
Whenever all
remember
the
this
fast interrupt
information.
handlers for all the
If a
different interrupts are
computer
done
can
executing,
send packets
the
to the
CPU will
internet,
go and
this
check the
means that
task queue
this
and
computer
execute any
communicates with the
tasks
internet.
that are present there.
Frankly speaking, I
Part of
believe that
interrupt
you
handling
exactly
that goes into the
understand
task
the
queue
logic of
is
this
slow
event
interrupt
anymore.
handling.
If we
It's
can
called
send
this because
packets
it's not
from
executed
one point to
immediately,
another
and it
point,
can be interrupted
these
by
two
other
points
devices.
can communicate. It's that simple. But
So
the
what
question
happens if
is,
an interrupt
how
request
does
is
PC1
received
send
while we're
packets
still
to the
processing an
internet?
interrupt from a previous
To
request?
be able to do this
Well, there's no
first,
problem if we're in the slow
PC1
interrupt
must
handler,
send its packet to the
because
switch
this
just
processing
like
is
before,
done in
because
such a
there is
way
no
that we
other
can
way
stop
for
this
PC1
processing and
to
handle
be
the
able to
interrupt if
reach
necessary.
the router, right?
What happens
I mean,
if
if
we are
PC1
still running a
wants to
fast
send a
interrupt handler?
packet to the internet, this packet
Well,
must
new
reach the
interrupt
router
handler
no matter
couldn't
what.
be executed
Because the
before the
router
first interrupt
is a
handler is
door
finished, and this can cause
accessing
some major
this
problems,
is obvious.
especially if
Hence,
we get a new
if
interrupt
PC1
from a
wants
device
to
that's sharing the same
with the
interrupt
router,
line as the one
it must
handling.
send its packet to the switch
So
first.
what we do
After
is we
that,
make
the
fast
switch
interrupt
looks at
handling
the size of
economic.
the packet
That is, we
and
make it
understands that the
uninterruptible.
packet wants to go to the
On a
internet.
single core
So,
system, this is
it
as
sends the
simple as
packet
disabling
to the
interrupts
And
as
there we
long
go.
as we're running a fast interrupt handler.
And then
On
the
multi-core
router
systems, there are actually special
looks
machine
at the
instructions
inside of the
to
packet
facilitate
and understands that
atomic
the packet
operations that
wants
are
to go to the
pegged to
internet.
one CPU
And
core.
afterward, it sends the packet
These
to
atomic
the
interrupt
internet.
handling
over this
operations will run to
And there
completion
we go.
without interruption
By
by
the way,
any
if you are
other
aware,
interrupt
we have
or
plugged
any other
this
request
cable
on the system.
that we purchased from the
Thus,
ISP.
the longer an
into this
interrupt
one.
handler
This is
takes to
obvious.
run,
I
the
believe that
longer the system will
currently
be
you can
unresponsive
easily
to
imagine in an
interrupts.
intuitive manner how the cables
So what
connect
happens if a
right
fast interrupt
like
handler is
this or
coded in
like
such a
this
way that it
are
takes too
plugged
long?
into the ports. I mean, there are some
Other
ports
devices
on the
might
router,
be requesting attention
you need
at the
to
same
put the
time
cables
as
into
long
that
running
port.
interrupt
It's that
handler is executing.
I will not show this visually
Worse, the
because
same
detailed
device that generated the
information
original
about the
interrupt
ports
might now
isn't
have more
important
data
for you
delivered to the
at this
OS
moment.
before
You
all the
just must
previous data is
understand
completely
the
received.
logic behind the
This could
router.
cause
Okay?
hardware failures,
And
buffer
as a result,
overflows,
PC1
dropped data,
sent its
dropped
packet
messages,
to the
all kinds of
internet.
issues
In
at
other
the hardware
words,
level.
PC1 and the internet
However, inside
communicate.
the operating system,
And the
this
device
could
that
lead
helps
to
us
something called an
connect
interrupt
to the
storm,
internet
which is
is
really
the
bad.
router. Wonderful.
An interrupt storm
I
occurs
believe
whenever
that
another
you
interrupt is
understand
always
most
waiting to be
basic
processed
of the switch
whenever a fast
and the
interrupt
router.
handler
And
finishes
I
its
hope
execution.
the animations
That
will
could
be
occur either
useful
because the fast
for me
interrupt
to
handler
understand.
is too long
However,
and needs to
I
be
want to
split
ask
into
you
a fast and a
two
slow
questions.
engine.
My
This can
first
also
question
occur
can you
if the
visualize the
hardware
internet?
has certain bugs
in your
that cause
mind?
it to raise spurious
And
interrupts.
the second question is, what exactly
If the operating
does the
system is
internet
perpetually handling
and
interrupts,
these
it
will be
never runs any
expressions that we
application.
are going to discuss in
Thus,
the next
it
lesson.
never appears to respond to any user inputs. The result of this situation is something called a live log. The system is still running, it's still
Before
processing
discussing the
signals.
meaning of connecting to
However,
the
it's
internet
not doing any
from a
useful work.
computer perspective,
Thus, to the
I
user,
think
the
it
system
is
appears to
helpful
be
to know
frozen.
what the
When
internet
an interrupt
exactly
storm
stands for.
occurs and the slide
Because
block
if you are really
situation
starting
results,
from
the
scratch,
typical way out of
I assume that
this problem
you are really
involves
new to
judicious
this.
use of the
you may
power
not
button.
know exactly what
So,
the internet
The
is.
interrupt
For
handling
this
is
reason,
an
I
important
want to
concept
visualize
in
the
order to support
internet for
multi-programming
better
systems.
understanding.
And interrupt
Thus,
handling
in
when
this
the interrupt
lesson,
messages
we are
come
going to
through
see
from
how a
hardware
packet
is
moves
divided into
on
two
the
types of handler,
By
so
the way,
that we
keep in
don't
mind
get
that
the interrupt
this
storm.
model you see
The
is a
fast interrupt
simplified
handler
model
executes
designed
atomically
to make the
without being
concept
interrupted by
easy to
anything else.
understand.
But
So,
it must be
this
fast.
structure
Must
in real
enter
life
that interrupt
is
handler,
much more
do
complex
some
than
very
you
short
see
operations, and
individual.
immediately
But
exit that handler.
with this simplified
If any
model,
long-running
you will
operations
understand
need
the
to
logic
occur
of
as
the
a
event
result
very
of
well.
a device
I
interrupt
promise.
request,
And
we need to
I
handle
believe
those operations
that's all you
inside the
need
slow
right now.
interrupt handler.
As you can see, there are many routers on the internet,
And how the
right?
system and its
And
processes
there's a
view
special
random
reason
access
for this.
memory.
So, at this moment, I would
In
like
order to
give
run
you
any
another
process
piece
or
of
instance of a
information
program
about
on a
a
computer
router.
system,
A router
we need to
is a
provide
device
two critical
required for a
resources:
computer,
access to the
electronic
CPU and access to random access
You
memory,
know this
or
definition.
RAM,
On
for
the other
storing and
hand,
manipulating
we can
data.
think of the router as the
RAM is
device
a type
used
of dedicated
to
hardware
communicate
memory
with your
that is
computer
attached to the
in
motherboard.
another part of the world.
It is
Or
separate
you
from
can think
persistent
of the
storage
router
or hard
as
disk
the
space.
device we use to
RAM is
communicate
also
with your
volatile,
computer
which
in
means
a
that it
different
loses
LAN.
its contents
I mean,
whenever power
if
is
you are
interrupted
aware,
to the RAM
there's a
module,
LAN here, right?
including whenever the
And
computer is
there
turned
is
off.
another LAN here. This is obvious.
At a
Then
low
here,
level,
we can
computer
plug the
hardware
following
presents
concept.
memory to the operating system as one
The
large block of
internet actually
space.
can stand for
This space is divided
to
into
another
bytes, and each
computer
byte in memory has a
located
unique
in a
address
very
that can be used to
I
access it.
You can think of the
A
internet
32-bit
as the
architecture
structure
provides
that
enough of these
connects
byte addresses
all the LANs
to utilize
all
up
over
to
the
4
world.
gigabytes
I
of
want to
RAM.
repeat this again.
Above
You
that
can
amount,
think of
there
the
is not
internet
enough
as a
space in
structure
32-bit
that
number to
connects
store the
all the
address
LANs
of any memory
all over the
locations
world.
in excess
And
of 4
as you know,
gigabytes.
there are
Thus, a
millions of
64-bit
LANs
architecture is
connected
required
to
for
the
systems
internet,
with more
except
than
these
4
LANs.
gigabytes of RAM.
Wonderful. I hope
Each
that
process
everything is
or
good
running
so
instance
far.
of a program
There's a
on a
thing that
system
we need
uses a
to
different
consider.
view of memory.
So, I want to ask
Process
you
memory
a
is
question.
divided into several
Why are
pieces:
there so many
stack,
routers here?
the heap,
Let me explain
global
it in a
variables,
simple
and the
manner.
text segment.
First, you should know that
The stack is used to store automatic variables or variables that are local to functions in the C programming language.
However, routers
Space on the heap is manually allocated and deallocated by the program
There are
when writing
tons of
C code
routers
using the
and
functions
other
malloc
different
and free.
devices in this structure.
Free
distributed
space for
to
extra
devices.
data is located between the stack
Focusing
and
on
the heap.
only
And the
routers
stack and the
is
heap
enough for us in
more.
order to understand the
Global
concept
variables are
behind the
provided with their own section of memory,
And
which is
The
allocated
first question
between the
that
heap and
comes to
text
your
segment.
mind is probably
The text
why
segment is used
routers
to
are
store
so
program
important
code.
to the internet.
This segment of memory
As
is
a matter of
read-only
fact,
and
The
cannot be
answer to
changed.
this question is hidden in the cortex of
As
the
I
router.
mentioned in the previous
The
slide,
device we use to
automatic
enable
variables
different
are placed
LANs
onto the stack.
communicate with each other
This placement
is
is
the router,
performed by
right?
the compiler when
And
the program
thanks
is
to the
built.
internet, we can connect
Placement of
all
data
the
onto
LANs
the
in the
heap
world
is
to
historically
each other.
performed by the programmer,
For this reason,
although many
it
of
makes
these
perfect
operations are
sense
now
to use
automated in
many
modern
routers
dynamic languages.
connect millions of local
In the
area
C and C++
networks together.
languages, the programmer
These
must
LANs
explicitly
are
request and
just two of
release
the millions
or
of local
allocate and
area networks
deallocate
all
heap
over the
space.
world. In
In
summary,
C, these
the
operations are
internet
performed
must
using the
connect
malloc and
millions
free
of local
functions,
area
while
networks.
the new and
It is
delete
obvious
operators are
that
used in C++.
it needs routers. I hope
In
you
Java,
get
the
this.
programmer must
And once
explicitly
you
allocate
understand
space
the
on the heap
importance
using the
of
new
the
heap.
router for the internet,
However,
you
the Java
probably think
runtime
of another
automatically
question.
determines
And the
which
second
heap
question that
allocations are no
probably
longer in
comes to
use
your mind
and
is
frees those
why
locations
there are
automatically.
so many
This
routers
process is called
instead of
garbage collection.
just one router. And
Python
this is
provides
more
both
critical
automatic
question
allocation
than the
and
first
garbage
question.
collection.
And
Whenever a
let's
data
answer
structure
it on the
requires
way.
heap space, the
But
Python
before
interpreter
answering
allocates
this
it
question,
automatically.
there is something
Once a
in
data
this
structure
picture
is no
that
longer in use by
should
the
catch your
program,
attention.
the garbage collector
Please look carefully at
deallocates
the
it without
picture
programmer
and try to
intervention.
find this difference.
Use of heap memory and processes presents a challenge to the operating system because these allocations and deallocations are not known in advance. The compiler is able to track and report the amount of stack space needed, since the number of local variables in a function never changes
As you
in a
can
language
see,
like C.
these LANs on the visual
However, the number
have
of
one
heap
device
allocations may
instead of
vary
a
from
switch
program
and
execution
a
to
router.
program execution,
So,
making
there's
it
no
impossible
switch
to know
in the
exactly how
environment.
much space should
How
be
can
allocated
there
to
be
any
a lab?
events.
Or, if there is no
Worse,
route
heap
within the
memory
environment,
allocations tend to be
how
small
can it
and
be
frequent.
connected
So
to
the
the
process of
internet?
allocating memory
And this
from
is
this
where
section
the
needs to
home
be
router
fast.
comes into play.
This speed
The
and
home
dynamic
router is a global
availability
device
needs to be
consisting
maintained
of
while
a
the
lot
operating system
and
shares the
switch
computer's
combination.
RAM among multiple
Hence,
processes at the
these
same
devices
time.
in the LAS are a
In
mix
addition to
of
sharing
switch
memory
and
among
route.
processes, the kernel
This
has
means
memory
that if we have
requirements of
a
its
home
own.
router, we don't
Aside
have
from
an
the kernel
additional
code
switch
and its own
and route.
automatic variables,
This
the
device
kernel
is
is
enough
filled
for
with
small
data structures that
environments
dynamically
like
grow
a
and shrink
home
during the
or
course of
small
system
office.
operation.
This is important.
These data
I
structures
want
are
to repeat
numerous
this
and
again.
include process
A home
control
router
blocks,
is enough
the
for us
ready list,
in small
scheduling
environments.
queues, device
Or,
access tables,
if there are
and many
very
other
few
types of
devices
structure.
in the environment.
Unlike some processes,
I
however,
showed you a
all
home
memory
router
allocation and
because most of
deallocation in the kernel
have
is
these
performed
devices
by
in
the
your
kernel
home, and
programmers.
you connect
In the
to the
Linux
internet
kernel,
by
programmers
using
can
home
use
routers.
one of a number
For
of
this reason,
functions,
I want to
including
tell you
kmalloc,
what these devices
kzalloc,
are in order to
VMI,
avoid confusion.
K-free, and
However,
B-free.
please note that if there
The
are
first
too many
issue that must be
devices in
solved
the
by the
environment,
kernel is sharing
the home
memory
router
between
will be
itself and the
insufficient.
user space
You may
process.
need additional
This
switch
sharing is
and
accomplished
route.
first by dividing the memory into two regions,
And now,
kernel
let's
memory
go
and
back
user
to
memory.
our question.
The kernel
Why there are
consists
so
data
many
structures,
routers
program
instead
code,
of
global
just a
variables,
single
and
router?
automatic variables and
Imagine
functions,
that there is a
isolating
single
these
router
items from
in
the
the
running
middle of the node
process.
instead of thousands of
Process
routers
memory is placed in a
distributed
separate
all
region
over
from the
the
kernel,
world.
but the
In
kernel
this
is
case,
always
millions
available
of
in there.
electronic devices around
This
the world
mapping is necessary
would
to
have to be
maintain
connected
performance
to
whenever
the
an
same
interrupt
router. This
occurs.
is obvious.
The
This
process
means
makes a
that
system call
this
to the
single
kernel,
router
or the process
needs
experiences a
millions
fault
of
that must be
ports,
handled by the
isn't
kernel.
it? And it is impossible to design
So,
such a device.
how do we go about running
But
multiple
this
processes
is not
at
the
the
only
same
problem.
time?
In addition
Well, the
to it,
first way we
if
can
there was
consider,
only
which is
one
used in
router,
some types of
the
embedded
entire
systems,
lot of the old
is to
devices
divide
in
the
the
memory
node
into fixed
would be
size
of
chunks
that
called
router.
partitions.
And this is
A
another
memory
problem
partition is a
because
single region of
computer
RAM that
science
is provided
we
to a
don't
single
want to use all
process.
the load on a
Both the
single
program
point.
code
We
and
even
data
call this
associated with
problem
each process
single
must fit
point of
within this
failure.
pre-allocated
And
space.
this is a problem that
If the
needs
process
to be
grows too
considered.
large,
To be
it
able
will
to
run out
teach
of
it
memory
better,
and crash.
let me give you an example.
Furthermore, the
Imagine
maximum
this
number of
router is
concurrent
broken
processes,
somehow.
called the degree of
This means that
multi-programming,
Internet
is
of
limited
the whole
by the
world
number of
is
partitions
crashing
available.
down at the same time,
Once
right?
all memory partitions
Because
are
we
used,
only
the
use a
system
single
cannot start
router
any new
to
processes.
connect all LANs around the
This
world.
situation is exacerbated by the fact that small
and
processes
the whole
may not be
internet
using their
crashed
entire
down.
partitions,
It's that simple.
resulting in
Just
wasted
think
memory.
about the consequences of this problem in a
In this
second.
lecture, I will
This
introduce
will be
dynamic
terrible,
memory
right?
allocation at the system
And
level.
so far, we have
This
talked
method of
about
memory
two
allocation
vital
improves the
problems,
degree of
but
multi-programming
isn't
that the
over.
system can
Another
provide
major
by
problem
allocating
is
memory to
the
processes
cable
needed
length problem.
instead of ahead of time
Imagine
in fixed size
how long the
chunks.
cable must be if there was only one giant
Fixed memory
router,
partitioning is
middle of
fast
the
and
world.
efficient in terms of
especially
overhead, but it
LANs
wastes space
that are
and
the
limits the
furthest
number
from
of
the
concurrent
giant
processes
router
to the number of
will need
partitions
very long
that can be
cables.
ran.
This is obvious, right?
Dynamic
Therefore,
memory allocation
this
resolves
design
this issue by
is very
allocating memory
problematic
processes
design.
as it is
And the
needed.
solution for all
This
these
mechanism
problems
increases the
is
degree of
this
multi-programming
distributed
the kernel can
structure
support.
all over
This
the world.
improvement comes at a cost of
Catch
greater
that.
complexity.
But to make sure
In
you
addition,
fully
there are
understand
trade-offs
the main
present
logic
in
of
dynamic
this
memory
structure,
allocation that
I want
directly
you to
affect
do
the
an
performance of the system.
exercise. I want
These
you
issues
to
include
determine
efficiency,
why such a
methods for
structure
tracking free
eliminates
space,
the problems we
algorithms
talked
for
about
determining where to
before.
make the next
I'm
allocation,
sure that
and memory
you can handle
fragmentation.
this. Just do it, guys.
The primary issue with dynamic memory allocation is fragmentation. During execution, processes
I
allocate
asked
free
you
memory in
a
chunks
question
of
at
varying
the end of the
sizes.
previous lesson.
Over
And I know
time,
that
regions of free
you were
space
all
within memory become
analyzing the
uncontiguous.
situation. But
The
let's
sections
do
of
it
allocated
together
memory
just
in
in
between
case.
sections of
If
available
you know,
memory.
if we use a
This
single
fragmentation
router
could
in
lead
the
to
middle
serious
of the route,
performance issues,
we will have
since
problems
program execution
with
speed will
overloading
drop
of
dramatically
the router.
if every
On
data
the other
structure
hand,
must be implemented
we
as
will
a link
need
to its small
mid-load
pieces.
cables for LANs.
Furthermore, algorithms that
from
try
the
to
giant
perform
router.
on-the-fly memory
But as you can see
fragmentation
in
are
this
extremely
structure,
complex to
the
implement
cables
and would
don't have
also
to be that
severely
long.
impact
And
system
this is an
performance.
important advantage. Actually, of
Since
course,
it is
we
impractical
can
to
keep
avoid
locations
fixed
in this
fragmentation,
structure too.
Memory fragments are
But
significant
not as
concern when
much as in
space is
the other
dynamically
structure.
allocated.
After all, in this
Small
structure,
fragments of
there
memory are
can be
useless
many
to programs,
kilometers
particularly
between
C
two
and C++
rods.
programs,
This is reasonable.
which
However,
require structures
by
and
no
objects to be
means
allocated
laying
in contiguous
cables
memory
from
regions.
one end of the road to
These
the other.
structures are likely to be in various
And
sizes that
while
are
we
not
only
efficient to
make two
utilize for
routes,
memory management purposes.
one cable in
So
this
the
structure,
systems will allocate
we
a
will
few more
connect
bytes
millions
than
of
structures
lands,
actually
the
require
giant router,
in order to
in
improve
the other
efficiency of the
structure.
memory tracking.
So, we will need a lot of
Furthermore,
redundant
structures
cables,
and objects
to a
will be
single
allocated and freed
and
numerous
this
times during
creates
program
a huge
execution,
mass.
further
Imagine
fragmenting the RAM.
cables coming to the giant router
Over time,
from
fragmentation
millions
can
of
waste
lands
large portions
that
of the
locate
system
in the
memory,
furthest area.
limiting the degree
See,
of
that's
multi-programming by making
By
it
using
impossible
this
for new
structure,
processes to
we
start.
minimize the cable mass and we avoid
There are two types of
overloading
fragmentation,
of a router.
external and internal.
Everything is good.
External
What about
fragmentation
the load
occurs when
overload?
free space in memory
Since
is
there are
broken
many
into small
routers,
pieces.
Load balance
Over
process
time,
is very
blocks
efficient
of memory are
in the
allocated and
distributed
reallocated.
structure.
This type of
This
fragmentation
system
tends
works
to become
very
worse.
well. And in addition to
External
load balance,
fragmentation is so
it
bad that
solves
some allocation
single
of
point of failure problem
every
as well.
in
For
blocks of
example,
memory that
this
are
router,
allocated to a
this
process.
router,
The
this
system
router, and
wastes
this
another
router
half in
are
blocks
broken
and fragments.
somehow. In this case,
With these
the
algorithms,
internet
up to a third of
continues to
system
work
memory
properly,
becomes unusable.
right? Only its efficiency decreases a bit.
The other type
On the
of
other hand,
fragmentation is called
When there
internal
is only one
fragmentation.
router, and if this
Internal
router is
fragmentation
broken,
occurs
the
because
whole
memory is
internet
normally
crashes
allocated
down,
to
and
processes
this
in
was
some
very
fixed
bad.
block size.
So, I believe
Block size is normally a power of 2 in order to make
for
kernel
such a
memory
huge
tracking
structure
more efficient.
like the internet.
Processes tend
And
to
now,
request
I
pieces
want
of
to show
memory
you a
inside them
visual
that do not
that
fit
shows
neatly
the
into these
cables
blocks.
between different
Thus,
countries
it is
and
often the
different
case that
continents.
parts of a block
With
are
this
wasted as
visual,
a
you
result.
will understand much
For
better
small memory
what the
requests,
internet is.
large portions of the
These
block may
cables
be wasted.
are very important, especially for the communication
When a
of countries
process requests
that
heap
there
memory,
is
the
an ocean
kernel must
between
find
them.
a chunk of free
And
space
this
large
visual
enough to accommodate the
represents real
request.
life itself.
This chunk
Unlike the
cannot be smaller
simplified
than the
model we
requested
use.
size, since the
99%
process
of
expects
all
to use all the
international
space it is
communication
requested.
on the internet
Since
is
the memory
provided
is
by
divided into
these
blocks for efficiency,
468
the
cable
chunk of
lines
memory returned to
laid
the
under the
process
water.
is normally
This
larger
is very
than the
crucial, guys.
requested,
Some
unless
of
the
these
process
cables
happens to
are
request
only
a full number of
131
block size.
kilometers long, while
I'm now
others
going
are
to
around
introduce 4 classical
20,000
algorithms
kilometers
for
long
dynamic memory
and so on.
application.
And
Best
one
fit,
thing is,
worst fit,
breaking
first
one
fit,
of these
and next
cables
fit.
can cause the internet of a whole
The
continent.
first classic
Go
algorithm for
away
dynamic memory
in a
allocation
flash
is the best fit
In
algorithm.
fact, it was held
In
at
this
such an
algorithm,
event
the
in
kernel searches for the
2018,
smallest chunk of
and
free
I want to
space
show
that is
this
big enough to
on a
accommodate
different
the memory
image.
request.
Okay? I want you
Although best fit
focus on
minimizes
this red
internal
cable.
fragmentation
That
by
almost
avoiding
17,000 long
over-application,
cable
external
starts in
fragmentation
France
is a
and
major problem.
reaches South Africa.
An
And
attempt
this
to
cable
reduce the external
connects 22
fragmentation in the
countries
best fit
on the
algorithm
west coast
is
of
observed
Europe
in the
and
somewhat
Africa to
counterintuitive
Egypt
worst fit algorithm.
and to the internet.
Using
And
the worst
the
fit
internet
algorithm,
of 10
the
of
kernel
these
finds and
countries
allocates the
crashed
largest
down
available
when
chunk of free
efficient
space,
accidentally
provided
cut
it
the
is
cable.
large enough to
And I
accommodate
think
the request.
this was a definitely
In
tragic
theory,
event.
this allocation
In
strategy
addition to
is
this,
larger,
is you can
thus
imagine
potentially more
it's not the
usable
only
chunks
problem
of free
that
space
happens
available.
to cables.
In
Because
practice,
we are
however, this
talking
algorithm
about
still
1 million
fragments badly,
kilometer long cables
both internally and
spread
externally.
all over the world. So,
Aside from the
there must be
fragmentation,
something more.
both of these
As a
algorithms
matter
are
of fact,
impractical in
nearly
actual kernel
200 problems
implementations
are
because they must
encountered each
perform a
year,
search of
and
the entire
these
free
are
list to find the
substantially
smallest or
related to
largest chunk of
ships
memory.
or natural disasters. And there is
The
a
need
fun
to
reason
search the
that
free
I
list is
prefer to
eliminated
use
using the first fit or
substantial
next
word.
fit algorithm.
Let me explain.
In the first
In
fit algorithm, the
2007,
kernel simply
sea
finds and
pirates
allocates the
stole
first chunk of memory
11
that is large
kilometers
enough
of
to
a
satisfy
cable
the request.
connecting Thailand.
This
Vietnam,
approach does
Hong Kong
result
to each
in
other.
internal
And
fragmentation.
they solved this
It
long
also
cable
tends
as
to create
scrap
small
by
fragments of free
dividing
space
it.
that
And
accumulate
I
at the
think
start of the
this
free
event
list,
is more
reducing
surprising than
performance
the
over
incredible
time.
infrastructure of
The
the
next fit algorithm avoids the external
Now,
fragment
I head
accumulation
back to the
by
first
starting
slide
the search for
because
the
there's
next chunk of
something
memory
I
from the
want to
most
show
recent
here.
allocation.
These colorful
In
cables
practice,
generally
only the first
represent
fit algorithm is used in the
intercontinental
Linux kernel,
connections
and then
under
only for
waters.
embedded devices.
But for example,
This
if you
algorithm
look
is
at
called
Russia
SLAB
lab,
allocator, which
cables
stands for
are
simple
not
list of
visible
blocks.
on this image.
For non-embedded
Don't
systems that
be
have the
confused about
computational
it.
power
Of
for more
course, there are
complex
cables
algorithms,
and
the
routers
SLAB allocation
distributed
is used
all over
instead of
Russia
any of
too.
these simple algorithms.
They are just ignored in this image. I mean,
Memory
the main
allocation.
purpose of this image
I will
was to show
introduce
you
the power of
how
two
devices
methods
from
with the buddy
different
system and
continents
coalescence
are
for
interconnected
allocating
under
memory
the
to
water.
processes.
Okay?
Then I will
Also
introduce
note
SLAB
that
allocation,
all of
which is
these
used within
cables
the kernel to allocate kernel
are
bit
fiber
structures
optic
efficiently.
cables because The fastest
In the
data
previous
transmission
lecture, I
cable
introduced
type
the classic
is
algorithms
fiber
for
optic
memory
cables,
allocation.
and
Best fit, worst fit,
intercontinental data
first fit, and
transmission
next fit.
must occur
Now I
at
want
the
to introduce
highest
algorithms
speed,
that are
right?
actually used
And
within OS
another
kernels
reason
to perform
why
memory
they don't
allocation
use copper
efficiently.
cables is
These
that the
algorithms are
length
called
of the
power
copper
of two
cables
methods,
increases.
and they work by maintaining
Probability of
information about
errors,
allocated in
data
three blocks
transmission
in a binary
increases
tree
as
instead
well.
of a list.
On the other hand, even if
At
the
the top
fiber
level,
optic cables
memory is
are very
divided
long,
into large
they
blocks called
transmit the
superblocks.
data to its
As
destination
processes request
almost
memory,
without
these
error.
superblocks are
And
divided
this
into
is
smaller
another reason
subblocks,
that
in
why
which
fiber
the memory
optic
is
cables
allocated.
are used over
Subblocks
long
can be further
distances.
divided, creating a
Correct.
hierarchy of block
I think
sizes.
it is important for you to understand
Algorithms based
what
on this
the
method are
internet really
relatively
is.
fast and
It's
scale to
very
multiple
vital to
parallel
be able to
CPU cores.
visualize it in your
These
mind.
algorithms also
Because no
reduce
matter what
external
area of IT
fragmentation
you are dealing
by
with,
coalescing
you need
three
to
blocks,
grasp this
as I'll
basic
discuss in a
subject.
few moments.
Actually,
Some
there was
internal
something
fragmentation
else
does
I
still occur,
wanted to
however.
show in this lesson, but I don't want
In
to
this
expand
diagram, we
this
can see
lesson any
three
further.
superblocks,
We
two
will
of which
continue
are
where we
partially in
left off
use.
in the next lesson.
Each of the
That
first
will
two
be a very
superblocks has
important
been
lesson.
divided into three
See you guys
subblocks,
in a moment.
and the third subblock of the first superblock has been further divided. When a process requests memory,
In
the
this
kernel
lesson,
must
we
perform
are
a
going
search
to
of the
discuss
tree to
how
find
a
an
packet
appropriately
moves
sized
over
block
the internet.
to
In
handle
this
the
way,
request.
you will understand
In
how two
performing the
devices
search,
in
the kernel
different
might
countries
subdivide the
communicate
existing
with
block
each
into a
other.
smaller
We will
block
see this on
to
an
reduce
example.
the amount of
Let's
internal
say
fragmentation.
this computer in LAN
Since
1
this is a search
wants to
process,
communicate
a
with this
reasonably
computer
powerful
in LAN
CPU
2.
is required
Okay?
to make this
In other
operation
words,
efficient.
let's assume that this computer wants to send a special
Another
packet
improvement to memory
to this
management
computer.
is to utilize a
So,
buddy system
this
in the power
packet
of two
must
strategy.
go to this router
In this
to exit
allocation
from the
system,
LAN
two
1,
limits are chosen to
because
be
our
powers of
destination
two.
is the out of
The
LAN
upper
1.
limit
I mean,
U
it is a
and the
different
lower
network.
limit L.
Our destination is on LAN 2.
Superblocks are the
And we
blocks
can
of
send
size
our
U.
packet
And these
over
blocks
the
can be
internet
subdivided
to
into
LAN 2.
blocks as small
And
as
now,
L
we are
bytes.
going to do this exactly.
There are trade-offs
First,
in picking the
this
size to
computer
use for
sends the
L.
packet to the
A
switch.
smaller size
After the
produces
switch
less
receives
internal
the packet,
fragmentation,
the switch
since the
looks
block
at the
size more
destination
closely
address of
matches
the
the
packet
smallest
and
request sizes
understands
for
that
processes.
it has to send the packet to
However,
the
a
router.
smaller size for
And
L means
after
that
the
there are
router
more total
receives the
blocks to be
packet,
tracked,
the router
which
looks
increases
at
the
the
size
content
of the
of it
binary tree,
and learns
using
its
more RAM to
destination
store the
address.
tree and
Hence,
increasing
it
the search time.
understands that it must send the packet to the
On the
internet.
other hand, a
Because
larger
the
size
destination
for
of
L
the packet
reduces the
is
search
in a
time
different
and makes the
network
tree
than
smaller,
LAN 1.
but the
So,
amount of internal
the router
fragmentation
must send the packet to this router that
In
is
addition to
connected.
the block size
Because
limits, the
this
buddy
router
system
is
also
the key
uses a
router for
technique
LAN
called
1
coalescence.
to connect to the internet.
Whenever a process
if this
frees a
router
block, the kernel
needs to
checks
send
to
a
see if
packet
either
to the
neighboring
internet,
blocks is free
it must
also.
send the packet to this
If one
router
or
no
more
matter what.
neighbors or
There
buddy
is no
blocks
other
are
option,
free,
right?
the
And
block is
you can
coalesced
think of
into a larger
this link
block,
as
reducing
the connection
external
of LAN 1
fragmentation.
to the internet.
Coalescence algorithm
And
is efficient
if this
since
link
the
is cut
maximum number of
somehow,
coalescence
the devices
operations
in LAN
must
1
perform is
cannot
equal to
access the internet.
the base 2
It's
logarithm
that
of
simple.
U divided by L.
After this point,
By
things will
properties
get
of
a little
logarithms, this
complicated.
value is
So,
equivalent to the
please
base
listen
2
to me
log
very
of U
carefully.
minus the
After
base 2
packet
log of L.
reaches this router, the packet
Thus,
has
for
three options
example,
to go.
a
This
system
path,
with a maximum
this
block
path, or
size
this
U
path,
of
right? This is obvious.
2096
But the
bytes,
question
or
is,
2 to the
which
12,
path is better option
and a
to go
minimum block
for the
size of
packet?
512
And in
bytes,
order
or 2
to
to
answer
the
this
9,
question,
will require
first,
at
we
most
need to
3
discuss
coalescence
what the routing
operations
table
to
is.
recreate
Each
superblock,
router must have a special
returning a
table
single
inside
512
called
byte block
routing
whose neighboring
table.
512
And after
byte buddy
receiving
is
a
free,
packet,
will
a
cause
router
2 blocks to
looks
be
at its
coalesced
routing
into a
table
single
to learn which
1024
path
byte
it
block.
must send the packet.
If the neighboring
For this router,
1024 byte
it
block
should
is
be
free,
this path,
two
this path, or this
1024
path,
byte
right?
blocks will
This
be
is obvious.
coalesced
And
into a
if you are
2048
aware,
byte block.
firstly, the
Then,
router
if the
receives
buddy
the packet
2048
from one
byte
of its
block is
cores.
free,
I hope
the
that
third
you can imagine
coalescence will produce
all
a
these cables
4096
that
byte
come to
superblock.
the router are
The power
plugged
of
into
two
a port
methods are
on
useful
the
for
router.
allocating memory to
Wait,
processes,
and
where some
after the
internal
router
fragmentation
receives
is
the
acceptable.
packet, the router
However,
learns
within
the
the kernel,
destination
it is
of the
preferable
packet
to minimize
and
both
sends the
internal and
packet
external
to an
fragmentation
appropriate
to
port
avoid wasting
according to the
space.
information
This
of the router.
conservative approach is needed
And we
since the
call this
kernel is always
operation
mapped into
forwarding.
memory. An
As a
efficient
result,
solution for
every
allocating
router
kernel memory
needs
is to
to
use
look
a
at
slab
its
allocation
routing
model
table to
in
learn
which
which
kernel
packet
memory
runs
is
forward
arranged
to
into
packet.
fixed size
In other
slabs.
words, we can easily
Each
understand
slab is
that
divided into
routing
region
tables
size for
need to
specific
have
types of kernel
information that
objects,
which
including
path
file
a packet
descriptors,
will go.
semaphores,
Okay?
process
It is very
control
important
structures,
to know
and other
this
internal data
fundamental task
structures.
of the routing
Initial
table.
layout of these slabs is performed
Each
from file
router has a special processor
At runtime,
Information in the
several of
routing
each
table
of the different
is
slab
created
layouts are
by this special
pre-allocated
processor
caches.
using many different
Whenever the kernel
algorithms.
requires a new
These
data structure,
algorithms
space
determine
for
the
the data
path
structure
that
is
a
simply
packet
taken
must
from
go,
the slab
and
cache.
the results of
If the
these
slab cache
algorithms
starts to
are
run out of
added to the
certain
router.
slab layout,
Okay?
it automatically
As a result,
provisions extras.
This router will look at its
Graphically,
routing
slabs
table
can be
and learn
represented in a manner
which path
shown here.
the packet must be
In this
forwarded.
example, we have
One,
two pre-allocated
two,
copies
or
of the
three.
same slab layout,
Meanwhile,
in which
when
each
a
slab
router
can hold a
makes
single
this
instance
decision,
of each of
it
5
always
different kernel
ignores the path
objects.
that the packet came
Some
from.
wasted memory
Because
does
it
occur
makes
with
no
this
sense
arrangement, since there
forward
might
the
be a
packet
larger
back
number of one
the
type
way
of
it
bus
came from,
than of another
right?
type of bus.
And let's say, according
However,
to the
this
routing
approach
table
is
of this
generally more
router,
efficient
the
in terms
packet
of kernel
must be
space
forwarded
utilization.
over path 3.
Slab allocation does require more CPU power than
After
does a classical
this
method,
router
such as first
needs
fit.
to look at its routing
Thus,
table
in
to
some
decide
embedded
which
environments,
path
the
the
slab
packet must go.
allocator might be
Assume
preferable.
that the routing table says the packet must be forwarded
If
over
slab
path.
allocation is chosen over the slab allocator,
go
the
to
Linux
this
kernel
router,
has two
right?
choices of
And
slab
there we
allocator.
go.
The first
If you
choice
are
is the
aware,
original
the
slab
event is always
allocator,
the same,
which
and
was
it
the
will
default
continue to be
allocator
the
until
same
kernel version
in every router
2.6.23.
until the packet
This
reaches
allocator
that.
performed well
Anyway,
on shared memory
let's keep
systems
going
with
very
few
left
CPU cores,
This router
but wasted
must
considerable
look at
memory
its routing
space when
table
used
to
on
determine
extremely large
which
shared
path the
memory
packet will be
systems,
forwarded.
such as those
Let's
found
say
in graphics
the
rendering.
router choose path 1. So, the
To
packet
reduce the
will go
space
to this
waste
router,
on large-scale
right?
SMA systems,
Corners.
Christoph Lamater at Silicon
And
Graphics
at this
developed
moment,
a new
please
allocator
listen to me
called
very
SWAP,
carefully,
which
because
reduces the
there's a
size of
tricky
data
part
structures
here.
needed to
When
track
you look at the
allocated
paths for
memory
the current
objects.
position of the packet,
The initial
you
implementation
probably
of
think
the
of
SWAP
the most
allocator
reasonable
contained a
option
performance
as
bug
path 2,
that affected the
because
results
the
of certain
shortest path
memory
to being able to
benchmark
access
tools.
this router that is
Initially,
connected to
Christoph
this router
believed the bug was
seems
of
to be
low
path 2,
importance,
right?
since the conditions required
If we choose
triggering
path 1,
were
for
fairly
example,
uncommon in
we
practice.
have to go to
Huh?
this router
However,
first,
Linus
and
informed
from
Mom.
there
Christoph
we
that
can
the
go
problem
to
would
this
be
router.
fixed, or SLUB would be dropped
Or
entirely
if
from
we
the
choose
kernel.
path 3, we will go to this router
In the
first,
end,
and
it
from
was
here
determined that the
we
bug
can
was
go to
caused
this
by adding
router
partially
similarly.
used
But
slabs
if we
at the
choose
beginning of
path
the
2,
linked list instead of
we
the
can
end
go
of that
directly
list.
to this
The
router,
fix was a
and
change
this
to
is what
one
we
line of
want.
code,
But
and the
is
SLUB
this
allocator
really
to
the
the
case?
default Linux
Let's see
allocator,
together.
2.6.
First of all, never forget that routers always want to deliver the packet to its destination as fast as
In this
possible.
lecture, I will
So,
introduce paging
router
and related
chooses
topics,
path
including
3
logical
instead of
addressing,
path 2.
address
It makes it
translation, and
unreasonable
the
to
translation of the
begin.
side buffer.
I understand that because you decide with a very simple line.
Paging provides a mechanism for sharing memory among
However,
multiple user
routers
space
use
processes at
many
the same time.
algorithms when
This
creating a
mechanism
routing
improves
table.
upon simpler
these
algorithms
algorithms
such as static
have many
partitioning
variables.
and direct
I mean,
power of 2 methods.
Routers
By
have to take
allocating
into
fixed
account
size
many
pages of
situations
memory to
when
processes.
they are creating routing
The key to
tables.
effective
For
memory
example,
utilization with
let's
paging
call
is that
every
each
router
process is given
is a
its
point
own logical
in this
memory
structure.
space.
Okay?
In other
So,
words, each
when
process
routers
has its
create
own
a
view of
routing
memory
table,
with its own
they are
address
not only
space.
concerned
The
with the number of
addresses that
points
the process
when choosing
sees
the
are
shortest
called
route
logical
to the
addresses.
destination.
These
This is very,
logical
very
addresses are
And
divided
I
into
want to
fixed
give an
size
example to you
pages.
to understand
Each
the
processing
subject matter.
system receives
In
its
some
own
cases,
private set of
routers
pages with private
control the
memory
traffic of
addresses.
their links they are connected to.
When a process
And
accesses
if a
memory
packet is
using
too
one of its
busy in
logical
terms of
addresses,
packet
the
density,
CPU
routers
translates the
will not
logical
send the
address into a
packet
physical
over
address.
that path. And
Physical
for
addresses
instance,
refer to
there will
locations
be an
in system
excessive
memory.
density on the path 2 line, even if it seems the
For
best option.
performance reasons,
Okay?
translation is done in
And
terms of
since
memory
routing
frames,
routes
or fixed
this
size
kind
regions of
previously,
RAM.
when
The
creating
base
its
frame
routing
size is
table,
normally 4
it may decide
kilobytes,
that it
although
is more
this can
convenient
vary
to
by
send the
hardware
packet
device, and most
over
hardware can
path 3
support multiple
instead of
different frame
path 2.
sizes.
And the equal this
Operating
situation
systems normally use
congestion
logical page
control,
sizes that
okay?
correspond to
I think
supported
that
hardware frame
I could get
sizes.
to the point.
Again,
As a
4
result,
kilobyte pages
the
are a
router
typical
sends
base
the
size.
packet over path
On
2.
x86 and
And here we go.
x86 64
As you
systems,
can see,
the Linux
the
kernel
number
can
of
support
points
so-called
that the
huge
packet
pages,
went through
which can
is
be as large as 1 gigabyte
However,
when using
the
the
selection
newest
of
AMD
factory,
and Intel
the packet
CPUs.
can probably reach its destination fast.
The key
Dot
advantage
com.
to paging is that it
And
eliminates the
after
issue of
this
external
moment,
fragmentation.
Let the packet go to
Since
this
the
route,
CPU
and
is
there we go.
translating logical
And
page-based
this router
addresses into
knows
physical
that the
frame-based
packet
addresses
will go
anyway,
to the LAN 2
there is no
and
need
insert
for the
the
physical
packet
frames to
to
be
the router
contiguous.
in the hub.
As a result,
By
we
the
can
way,
store
we
a
can
data
think of
structure in
this
process
line
memory
as a
using
straight line
pages that are
like
logically
that.
contiguous.
And
However,
this
when
router
these
knows
logical
that
pages
the
are mapped to
packet
physical
came to
frames,
this computer.
the frames may
So,
be scattered
insert
throughout
the
RAM.
packet with related
Notice that the distinction between a page and a frame is a matter of terminology.
two devices.
A page refers to a block of logical memory, while a frame refers to a block of physical memory.
Thanks to the internet.
For now, pretend that there is a one-to-one correspondence
with the
between
device
logical
on the
pages
other
and
side
physical
of the world.
frames. We'll
Thanks
make
to the
things
internet.
more complicated later.
I'm talking about milliseconds, guys.
The key to making page translation efficient is that the CPU contains special hardware called the Memory Management Unit, or MMU,
Mankind
which
created.
performs the translation operations.
I
On
hope
this
I was
diagram,
able
the
to
process
explain
accesses
individually
memory using
what the
logical
internet
addresses, which are
represents.
divided into
However,
pages.
there is also
When
something
requests
else
are made
very
using
important
these addresses,
that I have to
the
say.
memory management
I want
unit
to
on
tell
the
you,
CPU
the
translates the
definition
logical
of the
address
internet.
into a corresponding
Internet
physical address.
Is the network
The resulting
of the
physical address will be to some
Memory.
point of a physical
The
memory frame.
internet is the network.
Note that
of the
individual
network.
memory addresses
I
within
believe
pages
that
or frames
that,
still remain
I would
contiguous,
like to make this
which is
definition
important
more
because
meaningful to you. First,
the MMU
think
translates
about your
page
own
numbers to
home.
frame numbers,
maybe
leaving the
have a lot
offset
of
to the
devices
memory
that
location
can
within the
connect to
page
the
unchanged.
for example, computers, mobile phones,
As shown in this
televisions,
diagram, we can divide a
consoles,
logical address from a
tablets,
process
and
into two
many, many
components.
Similarly,
Page number
most
P
people have many
and the
devices
offset,
with an
D.
internet connection in their home.
When the
Just
MMU
like
is asked to
right?
perform a
In the
translation,
same
it
way,
consults a
you
data
can think
structure
about
called
a
a page
company
table,
or an
which provides a
enterprise
mapping
that
between
has a
page
huge
number
number
and
of
frame
devices.
numbers.
And you know that
Using this
there are many
information,
companies
the
and
MMU constructs the
enterprises
physical
in all over
address
the
by
world.
using the
So,
corresponding
if you
frame number,
notice, there are
represented here by
many
the
small
letter F,
or
in place
medium-sized
of the
labs
page number.
spread all over
Once
the
again,
world.
the offset to the
And
particular
all
byte
these
within
labs
the page or
on the
frame is
visual
left unchanged.
represent these networks.
A particular
As a
byte
result,
in RAM
the
is
combination
actually
of
addressed using
all
frame
these
number and
networks
offset frame.
Stand for the
However,
internet
the
itself.
process,
This is very
this
important.
memory access
Combination of
appears to
all these
occur
networks
using a logical
stand for
memory address,
the internet
which is
itself.
conceptually divided
In
into
other
page
words,
number and
we are
offset.
talking about a huge
The offset
system
component
in
is not
which
changed by the
almost all
MMU,
electronic
but the page
devices
number
in
is
the
replaced
world
by the physical
used
frame
to
number.
communicate with each other.
In order
By
to
the way,
perform the translation
very
from page
important
numbers to
part
frame
here
numbers, the
to
MMU must
understand
consult
on
the
the
page
visual.
table.
We call
Page table is a data structure that is
It is in the
itself
middle
stored
of
in
the visual,
RAM in the
as
kernel
the
memory space.
and you will see
Storing
such
a
a
page table in
representation
RAM leads
in
to a
many
major
resources.
problem, since
You
every
can
MMU
usually see
translation
a
will
cloud
require a
logo
lookup.
in order to
Since the
represent
lookup
it.
requires a memory
But
access,
in fact,
each process
the
memory
internet
request would actually
is this
require
basic
two
structure
physical
you see
memory accesses.
formed by
In this
combination of
situation is
all these
especially
networks
troublesome because a
and
memory
this
access
structure
occurs
in
both
the middle.
upon accessing data
This is very
and upon
crucial.
reading
Guys.
the next
What
instruction
I'm
to the
trying to
execute.
say is, when you
Without some
always
additional hardware
such
to
a
resolve this
representation,
problem, system
you should
memory
think
performance
that
would be
there are
effectively
billions
cut in
of
two,
lands that are
greatly
connected to
reducing
it,
the overall
even if
performance
these
of the
lands
system.
don't appear individually. Okay?
The solution for eliminating the double memory access issue is to add a component to the CPU called the Translation Look-Aside Buffer, or TLB,
So,
which
I hope
stores some
you
page-to-frame
understand better.
mappings.
Reason
Some
bookish
TLBs also
definition of
provide
the
room for address space
internet
identifiers,
is the
which aid in
network
implementing memory
of
protection.
one.
A TLB is a piece of
And
associative
you
memory,
can think
meaning
of
that it
this
can perform
structure
rapid,
as the heart
parallel
of
searches,
the internet.
resulting in
For
constant
example,
time lookups
when
for
we
page
connect this
translation.
line to the heart of
This
the
memory is
internet,
exceptionally
this
fast,
cable,
meaning
this
that
line
it is also
will be
quite
included
expensive.
in the internet.
As a result,
It can
TLB
communicate other
sizes are typically
devices
limited
that
from
are
8
connected
to
to
4,096 entries.
You catch the idea. So far, we have learned
The
what
addition of the
internet
TLB
is
provides a
and how
potential
important
shortcut to
routers
performing
are.
address
But
translation.
what exactly does
Instead
connecting
of
to the
immediately
internet
searching the
look
page
like
table, the
from a
MMU
computer's
first searches the
perspective?
TLB.
And we are
If
going to
page to
discuss
frame
this
mapping
question
should be found in
in
the
the next
TLB,
lesson.
then it is used to
See you
perform
guys
the
soon.
translation from
Bye.
page number P to frame number F. This situation is called a TLB hit. A TLB miss
Now,
occurs
we are
whenever
going
the
to
page
discuss
number
the
is
meaning
not
of
present in the
connecting to the
TLB.
internet
In
from
this case, the
computer's
MMU must search the page
And I
table to
believe that
locate the
it is very
appropriate frame
important
number.
to
The
understand this
CPU
now.
and operating
As
system
soon as
employ
we
various
are in a home,
policies to
Instead of
determine
an
when to
office,
store a
and
page-to-frame
we have
mapping in the
only one
TLB.
computer.
A simple policy would be to use a first in, first out policy
What we only
that
need
replaces the
is a home
earliest
router,
entry in the TLB
isn't
with
it?
the newest
There is
entry
no
upon
need
the
for a
TLB
switch,
miss.
since we don't have
Other,
other
more
devices
complex and
to connect to
potentially
each
better
other in
policies
this
also
home.
exist.
Very good. By the way, if you want,
Page tables are data
a
structures
larger
that store
device
mappings
is
between
not
logical
a
pages
home
and process
router
memory
device.
and
Because
physical
if you are
frames and
alone,
RAM.
we want to
These structures are used and managed in different ways on different systems,
We don't
often
need
with
to use the
systems
switch
from the
feature
hardware.
of the home router, right?
At the end of this lecture,
It is
I will
only
discuss
one
extended
computer
page tables,
in the
which are
environment.
useful for allowing hard
I
disk
believe
to
currently
support multiple
you know which
simultaneous
device
operating
actually
systems at
does
once.
this should be logical to you. Therefore, I will assume
Recall
that
from the
you
previous
know what
lecture that the
basic
page table
internet
stores
devices are
mappings
doing
between page
from
numbers
now
and frame
on.
numbers.
And
Whenever a
so
TLB
far,
miss occurs,
we
the
have
page
learned
table
that
must be
the
searched to
connection
find the
situation
appropriate
of the
mapping.
internet is determined
CPUs
by
have differing
whether
levels of support for
related
managing and
computer
searching
can
the
send
page
a packet
tables
to the
automatically.
internet or not.
On most modern
And
systems,
now,
including
I will try to make
x86-64
this
and ARM
situation
CPUs,
more meaningful to you.
page tables are managed
You are
and
watching
searched
this
by the
video
CPU
on
automatically upon
udemy.com
TLB
website,
miss.
right?
This
I mean,
search increases
let's
the
say
memory
you are
access
turning
time,
on
but
your
no fault
computer
or
and
interrupt is
entering
generated.
udemy.com
As a result, the
on your
CPU does
favorite
not have
web
to
browser.
perform a context
For that,
switch.
you click on the
Among a
video
few
you are
other
watching
CPUs,
right now,
the MIPS
or
architecture
any video you
requires
want
the
to
operating
watch.
system
And
to
as
manage
soon
and
as you
search the
click
page
on one
table.
of these videos,
Whenever a TLB
your
miss
computer
occurs, the
creates
CPU
a
triggers a
packet
fault, which
and
is a type
sends
of
this
interrupt.
packet to
The
udemy.com
CPU must make a
over the
context switch away from whatever
the
task is
person
currently being
is sent
executed
to home
in
router,
order to execute
and
the
then
interrupt
the
handler
home
call.
router sends the packet to
Software-managed page
udemy.com
tables are
over
becoming
the
increasingly
and
uncommon
we
even
can
on
think of
embedded systems,
this green
as the
packet
popular ARM
as your
CPU
request
supports
message
hardware
to
management.
udemy.com.
The MIPS
A request
CPU is
message
typically
gives
used in
information
lower-end
to
consumer
udemy.com
devices, such
about
as
you
inexpensive
want to watch
e-readers and
the
least
latest video.
expensive
Okay,
tablets.
this is very crucial. And after udemy.com receives your request
One
message
approach to
about
reducing the
watching
page
a
table
specific
search time
video,
whenever a
it
TLB
naturally
miss occurs
realizes
is to
that
store the
you
page
want to
table
watch
as a tree
a video.
instead of a list.
Hence, Udemy
This
sends the
technique of
related
hierarchical
video to
page
you
tables
over
divides the
the
page
and
table
there
into
we go.
pages.
These red
Each
packets
logical
represent
address
the
and
pieces of
process
the
memory
video
is
that
divided into an outer
Udemy
page
sent
table,
to you.
a
In
set of
other words,
offsets
the
into various
video
levels of
you are
subtables.
watching right
A
now.
final
By
offset
the way,
to a specific
there's a very
item memory
important
to be
thing
accessed.
about this process.
This
Let me
technique can be
explain.
generalized to any number
While
of
you are
levels in the
watching any
hierarchy,
video on
but I will
Udemy,
present here a simple
Udemy
system that uses
sends
only
it to
two
you
levels.
piece by piece, and we call
As
this
illustrated in
process
this diagram,
streaming.
the
I
data
think you
structure
have
is
heard of
arranged so that
this
an outer
concept
page
before.
table provides a
And
mapping
with the help
between
of
outer
streaming
page numbers and
technology,
page table
we can watch
pages.
the videos
Once the proper
uninterruptedly
page
or
table page is
without any
located,
problem.
the translation
And
from
to be
page
able
number
to
to
show
frame number can
this
be
piece
completed
by
quickly.
piece sending
The
process
page
better,
of the inner
now
page table
I
is
have
relatively
opened a
small.
random video on udemy.com. You can see that
The address
the
translation
video is
mechanism
being
used
sent
with
to my
hierarchical
computer
page tables
from
is more
udemy.com
complex than
piece
that
by
used with a
piece.
simple linear page
Thanks to
table.
the ability
The
to send
logical address
videos
is
piece
divided
by
into
piece,
additional
we
components.
can watch the video
In this
without
example,
requirement
two
for all the
levels in the
video
page
to
table.
which are
The logical address is divided into an outer page table
want
entry
to watch
number,
a 1
T,
hour video.
which specifies the location
your
of the outer
internet
page
speed
table in
is
which
so
to find the
slow.
proper inner page
If you
table.
couldn't watch this
The next
video
component of
before
the
the whole
address,
video
P,
reaches your
is the
computer,
offset
it
into
will
the
be
inner
very
page
bad for
table at which
right?
the mapping can be found.
Fortunately,
In this
process
example, we have a
doesn't work
single
like that.
page to frame mapping in each
And
inner
in
page
addition,
table entry,
this
so we can
transmission
obtain the
time,
frame number from
varies
that entry.
depending on the
A
speed
real
of our
system will be
internet.
more complex
Faster
and likely
our
will
internet
require a
speed
short
is,
linear
the
search
sooner
at
the
some
video
level of
will
page
reach
table.
our computer. It's
Once
that
the frame
simple.
number is
I
determined,
hope in
RAM
this
is
way
accessed
you
in
have a
exactly
better
the same way as
understanding
in
of
simpler
what
designs,
these red
with
packets
the
are.
final address
Great.
joining a frame number and offset
As a result,
into
connecting to
the
the
physical
internet
address.
refers to you can send some packets to the
Storing the
internet,
page table in a
and
tree
you can
improves
receive
access
some
performance.
packets from the internet.
However, as the
And
total
here,
amount of system
router
RAM continues
or
to
home
increase
router
with
in
newer
this
and newer
situation
generations of
plays a
computers,
very
the
important
size of the page table
home
also
router
increases.
gives the packets it
Moreover,
receives
the address
from the
spaces on
computer to the
64-bit
internet
architectures
and gives
are
the
much
packets
larger
it
than the
receives
amount of memory
from the
the MMU
internet
actually
to the
supports.
computer. In
Current
summary,
64-bit systems have true
transmission
hardware
is the
address
basis
sizes
of
in the
connecting
range
to
of
the
34 to
internet
48
or
bits.
communicating
If we were
with
to
the
store a
computer
mapping
on
to
the
handle
other
every
side of the
logical
world.
page number in such a system,
Meanwhile,
the
when we
mapping would
enter
be large and inefficient,
udemy.com,
since
we
the address
communicate
space is
with very
sparse.
powerful
That
computers
is, not every
that actually
64-bit logical
belongs
address
to
can
udemy.com.
map to a physical
And we
location
call
in RAM.
these special
The physical
computers
addresses are at
server.
most 48 bits.
Servers do not
As a
differ
result, many of the
fundamentally
possible
from normal
64-bit addresses are
However,
unused.
since the servers
A solution to this
exchange
problem,
packets
which both
with
reduces
thousands
page
of
table
normal
storage size
computers at
and
the same
increases
time,
search speed,
servers
is to use a
must
hash
be much
table
more
or
powerful
dictionary
computers
structure
in
to
terms
store
of
the outer
hardware
page table.
compared to normal.
Since several several addresses may hash to the same value.
Too many people
Each
access
entry in the
Udemy.com
hash
at
table
the same
is an
time.
inner
I mean,
linear
too many
page
people
table,
access
which allows the hash
servers of
collisions to be
Udemy.com
resolved
at the
through
same
chaining.
time. And at this moment, let me tell you what I mean.
Translating a
when I
logical
say
address
servers
to a physical
of
address
Udemy.
with a hashed page
If you
table
remember,
begins by
we
hashing
talked
the
about
page
the
number key.
importance of the single
Hashing is
point of
accomplished
failure
using a hash
and
function,
load
which may be
balancing.
implemented in hardware for
This
high
is true
performance.
for servers of
The hash
the
value returned by the
There is not
function
a
gives the
single Udemy
location of
server
the hash
in the
table
world.
where the inner
Udemy
page table
has
may
a
be
lot of
found.
servers
A linear
distributed
search of
around
the inner
different
page
parts
table is
of the
performed to
world.
locate the
The
frame number.
location of one of these
Once
servers
the frame
is the
number
best
F
for you,
is obtained,
and
it is
you
joined with the
communicate
offset
with this
G
best
to
suited
give the
server.
hardware
It's
address.
that simple. As a result, when
Some
you want to
architectures,
enter
notably
Udemy.com,
PowerPC and
you are
Intel
actually
Itanium,
communicating
store their
with
page
one of the
tables
suitable
backwards.
Udemy servers
That is,
for
the
you.
system stores the
So,
data structure with
while
one
some
entry
of you
per frame,
communicate with the
and the
same
entry
server,
stores the
some
corresponding
of
page
you
number
will
along with
communicate
the
with a
process ID
different
of the
server.
process owner
But at
page.
the end of the day, you will
This
all
approach, called
get
an
the same
inverted page
content.
table, is efficient
Therefore,
in terms
thanks to
of page table
distributed
storage
servers,
size.
Udemy
However,
prevents
inverted page
single
tables
points
are
of failure
inefficient in
and
terms of performance,
provide load
and these
balance.
structures are not used
Let's
on
think
majority
about
of
it a
systems.
little, okay? By the way,
On newer
of course,
x86-64
there are many
systems with
details
virtualization
behind the
extensions,
transmission
hardware
of
support
packets,
exists
but
for
you can think
extended
of it
page
in
tables,
this way
or
as
EPT.
the simplest logic.
AMD and
And
Intel
that's all
each brand
I
this
need to
technique
say
with a
in
different
this
name.
lesson. See you
AMD
guys
uses
soon.
the term Rapid
Bye.
Virtualization Indexing, or RVI, on newer CPUs. They used to call this technique nested page tables, or
In this
NPT.
lesson, we will shortly talk
Intel
about
uses
the
the
wide area
extended page
network
tables
or
terminology.
regional WAN, which is a very
EPT
important
adds a
type of
level of
network
paging to the
for
system.
the internet.
At
In
the
a
outer
simple
level,
manner,
each
you can
virtual
think
machine
of WAN
or guest
as a
running on the
network
CPU
consisting of
sees
a
its own
combination
set
of
of memory
different
frames,
WANs. For example,
isolated from and
combination of
independent
these
of
two
the
LANs,
actual
we
hardware.
can create a
The
WAN.
CPU
Or
translates
combination of
page numbers
this
to
LAN,
frame numbers,
this
first
LAN,
by
and
translating
this
page
LAN,
number to
we
a
can
guest
create
frame number.
another WAN. Okay?
The guest frame
And
number
in
is
order
then
to
translated to a
understand
host frame
the
number,
logic of
which
WAN,
is the
we
physical
can
frame
talk
number.
about the company example.
EPT
Let's say
technology is
we have a
important for
growing
virtual machine
company and
performance,
we open
since it allows
some
each
offices
guest to
in
manage
different
its
parts
own
of
memory
the world.
efficiently.
And we want these
Moreover,
offices
guests
to
can
be in
access
the same
memory
network,
without having to
even
switch
if
the CPU
they are
into
far apart.
hypervisor mode,
And this is
which
where
can be an
the
expensive
wide area
operation.
network comes into play. By using WAN, we can
The
create
downside to
special
logical
network
address
for our
translation for
requirements.
extended page tables
Let's
is that
say
it becomes
this is one of
conceptually more
our
difficult
LAN,
to understand,
and this is our
as illustrated
another
by
LAN,
the
and
complexity
they are
of this
located
diagram.
in different parts of the world.
A process running in
we
a
want
guest
to
operating
create a
system
WAN
makes a
for
memory
our
request
company by
just as
using
it would
these
if
two
no
LANs.
virtualization
But
were
the
present.
question is, how
This
do we do
memory
that?
request is divided
Let's
into a
say,
page number
let's
and
say
an offset
our boss
as usual.
wants us to
The
establish a special
CPU then
network
performs
for these
translation of
LANs.
this page
I
number
mean,
P
he wants
to a frame number
computers
F,
in these two
also
different
as usual.
offices to work as if they're
Furthermore,
in the
as
same
far as the guest
environment.
operating system is
So,
concerned,
our
the
guide
translation
is
is
WAN.
complete.
If we
Guest
create a
OS
WAN,
sees the memory
these
region
LANs
provided by the
can
host
communicate
system
as if they're in the
if
same
that memory were
environment.
physical memory.
But there's an
In other words,
important
the guest
point
OS has
to
no
consider.
idea that it's running in a
Thanks to
virtual
the
machine.
internet,
To
we
the
can
guest
already
OS, the
enable
virtual
these
machine
LANs
is just
to
like a
communicate,
physical system.
right? As you know, the
However,
internet
in
stands
reality,
for the
the
network
guest's
of
physical
networks.
memory is
This
actually
means
an
that the
illusion
internet
provided by the
itself
host. To
represents
make this illusion
connecting
work, the
millions
host
of
must
LANs
translate the frame
together.
number F
Hence,
in
if
guest
these
memory
LANs
to an
are
actual
already
physical
connected
frame
to the
number
internet,
G.
computers
This
in LAN 1
translation is performed by the
computers in
CPU
LAN
without
2
any
can
context or
already
node switches
communicate over
using
the
the
internet.
EPT table.
This is obvious.
Once this
So,
translation is
the question
performed,
is,
the physical
these
memory address
offices
is
can
generated
already
by
communicate
combining
with
G
each other
and D,
over the
where D
internet.
is the original
Why we need
unchanged
another
offset
special
of the
network
page.
is a WAN.
It is important to note that this
Please
entire
be careful.
process is performed by the
Communication
CPU
over the
without
internet
switching to
directly.
the host OS or
Communication
hypervisor.
over a special WAN belongs to
In
a
this
company.
lecture, I will
It's a
discuss
whole
memory
different
protection,
thing.
including segmentation
I
and
want
permission
you
bits
to
on
think
page
about
table
that question
entries.
for a short time and try to answer it.
Remember that operating systems perform two functions: abstraction and arbitration. Mechanisms for accessing memory provide abstractions of the underlying
If
memory
you
hardware.
have noticed, the internet
However,
is a
operating
public
systems
network.
must also
I mean, the
arbitrate
internet
access to RAM
has no
by
owner.
ensuring that
It
one
belongs to
process
everyone.
cannot
Any
access
person
memory that does
can
not belong
connect
to
to
it.
the internet
Without
whenever
this
and
arbitration,
wherever
a
he
process
wants.
could change
For this
memory
reason,
belonging
it
to
is
another
obvious that
process,
this
or
public
worse,
and
it
huge
could
network
crash the system
can
by
have
changing memory that belongs to the
security-related
kernel.
problems in information
On systems
transfer
that utilize
between
simple
different
memory
locations.
management, such as
You know,
power of two methods,
Hackers are
memory
everywhere,
access
and they
protections
are
are
in this
provided by a
public
mechanism
and
called
huge
segmentation.
network like to. And to be
On the
able to
majority of
answer the
modern
question
systems
I
which
just
employ
asked
paging,
better, I
memory
want to give
protection
you
is
a
implemented
very
as
good
part of the
example.
paging system,
Let's say
and memory
that
access
this
permissions are
wants
stored
to
in the
send
page table.
an important file to related to the company to this computer.
On any system,
after the
process
file is
memory is
sent
divided
to
into
this
logical
computer,
pieces or
There will
segments
be
in
no error
file type.
problem.
These
Thus,
segments include
this
the text
transmission
segment,
process
a region for
took
global
place
variables,
within
a
this
stack
LAN.
region for
This
automatic
LAN
variables,
is a private
and a
network
heap for dynamically
this office.
allocated data structures.
An outsider
Access
cannot directly
permissions
access
apply to
this
each
LAN
segment.
without your
In
permission. This
particular,
is very
the
important.
text segment is set to
Hence,
be read-only.
file transmission operation in
Outside
this
a
LAN
single
is a
process,
secure
there must be a
operation
mechanism
in
to
general.
track which segments of memory
Everything is
belong to
good
which
so far.
processes.
But
When a
what would
process is
happen
executing,
if this
its
file
segments are
was
marked
sent
valid
to the
so that
other
it can
office
access the
over the
corresponding
internet?
memory locations.
Let's see.
Segments of memory
Now,
belonging to other
scenario
processes
is the
are
same
marked
again.
invalid.
We need to
Any
send a
attempt to
file
access those segments
related to the
results in
company.
a fault
But this
or
time,
interrupt
we must
called
send
a
this
segmentation
file
fault.
to the other office of the
Typically, a
company.
segmentation
As you
fault
can
causes
see,
the process
the
to
file
be terminated.
passes through the public network.
Segment memory permissions
Well,
are implemented on
problem
non-staging
here.
systems
Just
using
think
a
about it.
segment table.
This part of the
The segment
internet
table has
is an
permission
absolute
bits to be
public
applied to each region of memory.
If you
When
send a
memory is
file
accessed
over
using
the internet
segmentation,
like that,
the segment
there is
table
no
must be
guarantee that
consulted to
no
determine
one
whether or
from
not
the
the access
outside
is legal.
can see this file. Or worse, no one from
In
the
this
outside
example, a
can
process
change
requests
this file.
access to memory
As I
using a
said
logical
before,
address.
hackers are
If you do
everywhere.
not have paging with the system,
Possible
this
to
logical
use
address
it.
is not
Are
translated
generally
by a
not
page
known.
table mechanism.
Hence, it is
However,
important to
this
remember
logical
that
address is
there
divided
is a
into a segment
possibility
address
for a
and an
problem
offset into
when
the
you send
segment
this
in
file
a manner
about
similar
the
to
company
page translation.
over the internet directly.
The MMU
Especially
checks the
if
segment
it is a
table
very
to determine
important
if a
file
particular
about
memory
the
access is
company.
valid.
It is very
In
vital
this
to
example,
be
the segment
careful.
table stores up
And
to 4
a special
permissions
ban
and
for
up to
the
3
company
bits,
is
a
a
valid
solution to
invalid
such
bit, a
problems.
read-write
In
bit,
general,
and an execute
setting
bit.
up a van
In
is a
practice,
costly
most
and
systems
not
that
easy
support
task.
segmentation
But
without
fortunately,
paging normally
there are
use
various
2 bits,
methods of
valid,
setting up a
invalid,
van.
and
And
read-write.
now, we will only
If the
talk about the
process
most
tries to
popular
read from a
and
segment that is
cost-effective
marked
van
valid,
method. And this
memory
method
access is
is
permitted
banned
and occurs
by
normally.
using
The
VPN.
same thing happens if a
I'm
process
sure that
tries
you
to
have
write
heard
to a
of
memory
VPN
location that is
before.
marked both
It
valid
stands for
and writable.
Virtual Private Network. And
However,
people
if a
usually
process
use
tries
VPN
to write
to
to a
access
segment marked
restricted
read-only,
websites.
or if the process tries to
VPN
access
ensures
an
our
invalid
anonymity,
segment,
and it
the
encrypts
CPU
our
triggers a
data
segmentation
before
fault
sending the
and the
packet.
process is terminated.
Hence, this gives
For
us
some
high
invalid
security
accesses
in
on a
general.
Unix-like
And
system,
while
this
creating
segmentation
vans
fault may
by
be
using
reported as a
VPN
bus error.
technology, we take advantage of these features
With
of
paging
VPN.
systems,
But
which comprise
most
the majority of
important
modern
feature
systems,
you should know
including
about
mobile
VPN
devices,
is the tunneling.
memory protection
This
is accomplished
feature
by
of
adding
VPN
permission bits
provides
to the
privacy,
page table entries.
anonymity, and security
In
to us
general,
by
page table
creating
entries
a
will have a
special
valid
network
invalid bit and
over
a
a public
read-write bit.
network. This is really very
The valid
important.
invalid
I
bit
want
is
to
used
repeat
in the same
this
way
again.
as it is for
VPN
segmentation.
tunneling
Pages that a
provides
process is
privacy,
allowed to access
anonymity,
are
and
marked valid.
security to us
Other
by
pages and
creating
any
a special
non-existent
network
pages
connection
are marked
over a
invalid.
public network.
The
However,
process
frankly
attempts to
speaking,
access an
a physical
invalid
tunnel
page, a
isn't
CPU
created
fault is
here.
raised,
This is very
which
crucial.
functions like an
Tunneling
interrupt to trap the
technology
kernel.
makes the packet
The
act
Linux kernel
as
will
if
send
it
a
is going through
SIGSEGB
a
or
physical tunnel.
SIGBUS signal
But
to the
I
process,
want to repeat it
depending
again.
on the location
This
of
is not
memory
a
the
physical
process
tunnel.
tried to
This
access.
tunnel visual
In
just
practice, the
represents the
signal
high
is normally
security
not
connection
caught, and the
between
process
LAN 1
terminates.
and LAN 2.
For historical
think of it
reasons,
in
this
this
event is called a
This tunnel
segmentation
visual
fault, or
just stands
seg
for
fault
the
for
high
short.
security for the connection between these routers.
The
It's
read-write
that
bit, used to
By
mark
the
the
way,
text
of
segment of the
course,
process,
the packet
can be
will
used
pass
to
through
allow
many
pages of
routers
memory
on
to
the
be shared
internet
between
in order to
processes.
reach its destination,
Pages that are
just as
re-entrant
you have
or
learned
read-only
before.
can
However,
be accessed by
since
multiple
VPN uses
instances of
tunneling,
multiple
it
programs
will be almost
simultaneously.
impossible to
This
interfere with
capability
this
is
packet
useful on modern
from the
systems
outside.
since multiple instances of programs are typically run
I
at the same
hope that
time.
you got the
In
tunneling
the case of a
conceptually,
web browser,
but
for
I want
example,
to take a
it is
closer
only
look at
necessary
it.
to load
So
one copy of the
first,
browser
we
program
send
code
our
into
file
memory.
to the router.
Several
and
copies
then
of the browser can be run as several different
at this
processes,
moment,
sharing the
there will
program
be
code
some
and
changes
thus saving
on
memory.
the packet. But before doing
The open
these
source
changes,
Chromium browser
first of all,
and
you
its
should
Google
know
Chrome
that
derivative
VPN
allow
tunneling
each
is
tab
set
to
up
run in a separate
between these
process.
routers. This is very crucial.
Shared memory
And
pages
we
allow
call
the
this
code for the browser,
side-to-side
any
movement.
extensions, and any
This
plugins
method
to
is
be
very
loaded only
popular
once.
while
saving
creating
memory.
a WAN between offices. And thanks to the
This
tunnel,
diagram illustrates how
file
two
safe
processes
to
can
reach
share a
this
single
LAN,
page
you
in
know.
RAM.
But the question
Each
is,
process
this
sees a
tunnel
handful
is
of
not a
valid
physical
frames,
tunnel, as
one of
shown
which is
in the
marked
picture.
read-only.
What exactly
If
is
this
it?
memory frame
Let's see.
contains code or
I
other
will use that
information that can
analogy
be shared
to
between the
explain.
processes,
Let's
then
say
the two frame
we need to
numbers
send
will be
a letter
identical within
from
the
LAN
second
1
process.
to LAN 2. So,
Each process
should
may
keep the
use a
letter
different
you want
page number
to a
to
postman,
represent
right?
this memory location,
Postman
however.
can take
Since
this
each
letter
process has
to
its
its
own
destination,
independent
and
logical view
you are
of memory.
not putting this letter in an envelope.
Incidentally, this diagram is a conceptual diagram
if
only.
he wants.
It does not directly map to any
You can
particular
think of
data
the
structure in the
postman in this
operating system.
example as the
Instead,
public
the two
internet.
tables illustrate
On
how
the
each
other hand,
process might
If you
see
had put
page
this
data.
letter in an envelope first and gave it to
Newer
the postman
AMD and
in this
Intel
way,
CPUs
the
support
postman
an additional
wouldn't be
permission
able
bit
to
for
read
setting
it. This is
execute
obvious.
permissions.
Hence,
This bit,
the
called the
process
no
of
execute
putting the
or
letter in an
NX bit,
envelope
is actually an
represents the
inverted
tunneling
permission.
itself.
It is set to
So,
1
in the
whenever
real scenario,
execution of data
we
found
have
on
to
a memory
put
page is
this
forbidden.
yellow packet into another.
Originally, the NX
And
bit
there
was
we go.
implemented by
Assume
AMD
that
on
the
its
yellow
64-bit
packet
capable
isn't the red
processors, using
It's
the
just
marketing
like
name of
putting
Enhanced
the letter
Virus
in
Protection.
an envelope. That's the
Intel
whole
followed suit
idea
and added
about
this
tunneling.
mechanism as the
Wonderful.
execute disabled
And
or
at this
XE bit.
moment, I want
The
to ask
concept
you
behind the
a
bit
question.
was to provide a
My
mechanism
question
that
is
could
that,
be used to
is
prevent
this packet
execution of native
really
machine
safe right
instructions
now?
from memory space
Can't
used
the
for regular
postman
data.
open the envelope
Although the
find
primary
out the
beneficiary
information
of this
in it
feature was
if
a
he
certain
really wants
virus-prone system
Just
that is
think
not
about
a Unix variant,
You got
the
the
Linux
point,
kernel does
right?
support the
Even
NX
though we
bit as
have
a guard
increased
against
the
buffer
security
overflow
of the
and
packet
similar
by
exploits.
applying tunneling, there are
In
still
the example
some
presented in the
problems.
hypothetical
And this
page
is
table
where
here, only the
encryption
page with
comes
text
into
numbers
play.
04A4
Encrypt your letter
allows code
in a way
execution.
that only
In
people
the event of
working
an
in your
exploit
company
attempt,
can
a malicious
understand.
application
In this
could
case,
try to load
even
code
if
in another
the postman
page,
opens
perhaps
the envelope,
04A1.
you cannot obtain the
However,
information.
since the NX bit is
because
set on that
You will
page,
see
any attempt to
non-understandable
execute the
data.
code
will
loaded
not
by the
understand
exploit will
the
trigger
encrypted
CPU fault,
information.
and the process
So,
will be terminated.
What we have to do is very
This
simple,
mechanism
right?
increases
You
the
must
security of
encrypt
the system
the original
against certain
packet
types
before
of
putting it
attacks.
into another packet. So let me back one step on that.
In this lecture, I will
For
begin
this
discussing
scenario,
virtual
we
memory.
encrypt the yellow packet
Due to the
before
complexities of
putting it
virtual
in
memory
the red
subsystem, the second
then
part of this introduction will be
this
given as a
encrypted
second
packet
lecture.
into the red packet. And finally, this
We have
packet is
previously
sent
seen that
to
each
enter
process in the
over
system
to
can be
internet
given its
safe.
own
And there
logical
we go.
memory space.
It's that simple.
This
now.
arrangement allows
We
logical
encrypt the
pages to
original
be mapped to
packet
physical
and put it
frames
in
without
another
the need
packet.
for physical
Thus,
frames to be
we
contiguous,
maximize the security of
eliminating
the packet.
external fragmentation and
The term of
increasing the
tunneling
degree of
comes from
multi-programming
because
the system
packet
can
is
support.
safe as if it was
We
moving
can
in
further
your own
increase
private
the degree of
time.
multi-programming
I
in the
hope
system
I
by
made this
recognizing that
concept
processes do not
understandable.
actually use
And
all the
at
memory
this moment,
in their
you
logical address
need to get
spaces
the
at any
original
given time.
packet. And to be able to
Parts
do
of the
this,
program
you want
code,
to first
including error
eliminate
handlers
the
and
outside
frequently called
packet, right?
functions,
and
are
then
not
it
utilized
needs to
often.
decrypt the encrypted
Furthermore,
packet so
arrays
that
and
it
other
can
data
obtain the
structures
original
are often
packet.
oversized and
after
used
the
in
writer
sections
gets the
instead of
original
all at
packet,
once.
It looks inside the packet
If we can
and
swap
learns
unused
its
pages
destination
out of
and
memory
sends
and
the
onto a
packet
backing
to its
store,
destination.
such as a hard
And there
disk,
we go.
we can fit more
As a result,
processes into
With
memory
the
at
help of
once,
the van,
increasing our degree of
API, we
multi-programming.
can securely send company
Furthermore, we can give
information
each process its
from one
own
LAN to
large
another.
logical memory
Never
space,
forget.
which can
There
in
is no
fact
such
be
thing
larger
as
than the amount of
100%
physical
security.
RAM on the system.
This means there may be always a security vulnerability.
When we add a backing
for
store,
everything.
the general address
However,
translation
currently,
process
Van
remains the
was
same.
built by using
Processes
technology
access memory
are
using
quite
logical
satisfactory
addresses,
in
which are
terms of both
translated into
budget
physical
and
addresses
security.
by the MMU.
I believe
Page table is
everything
still
is good
utilized
so
to store
far,
the
but
page to
some of
frame
you
mappings.
curious can think about the
However, we
question.
do add some
You probably
complexity
think like,
in that a frame
I
could be
constantly
swapped out
use
to disk
this
in time
in
when
daily
it is
life.
needed.
I sent
The
mail
CPU
to my
must provide a
friends.
mechanism
I
to
use
detect the
e-commerce
situation
websites and
and
I
generate
do
a fault
all
that
of
the
these
operating
over the
system can
internet.
handle,
So,
bring the required
since the
page
internet
back
is a
into
public
physical memory.
network, are all these operations insecure? The
The
answer is
process
both
of
yes
moving
and no.
pages or
Let me
frames of
explain.
memory back and forth between
Assume that you
RAM
want
and the
to make
backing
an
store
operation
is
on
known either as
Amazon.com.
swapping or as
Now let's
paging.
say you had to enter some
Historically, the
information
term swapping
your
referred
credit
to the
card
movement of
while
entire
purchasing
logical
a product.
address spaces
Since this
or
information
entire
will be sent
processes
as a packet
between
over
RAM
the
and
internet
disk.
to one of the servers
Moving
of
single
Amazon.com,
pages or frames
absolutely
of
don't
data
want
between
anyone
RAM
from
and the
the
disk was
outside
called
to
paging.
see the information
In
about
modern
our credit
practice,
card.
both terms are used
solution to this,
interchangeably,
An
and the
end-to-end
Linux kernel
encryption
component
method
that
is
performs
used
page
between
movements
our
is called the
computer
swapper.
and the destination server. And
A single movement of a single page frame into or out of physical memory is called a page swap.
about our credit card.
Historically,
Except the
Linux
server
machines used a
Amazon.com.
dedicated hard disk
This
partition
is
to
the main
store the
logic
pages
behind the
that were swapped out to
encryption.
disk.
Only the endpoints
Modern versions of
decrypt
Linux are
packets
just as
and
efficient using
obtain
the swap
the original
file,
data,
which
okay?
is a regular file
However,
stored
this kind of
alongside other
encryption
data in the
was
file
not
system.
used in the past. And
It
this
should be
situation
noted that
made it
swapping is
easy
an
for
optional
hackers.
feature, and it
Imagine
is
that
possible
the
and even
information
quite
about your
common
credit card
to run
was read
systems
or
without
saved
any
by a
backing
hacker
store or swapping
pure text.
capability.
This is terrible.
Most
right?
embedded Linux
But
systems,
thanks
such
to
as
end-to-end
Android
encryption,
devices, do not use a
eliminate
backing store.
this problem.
If memory
And
cannot be
finally,
allocated to a
I'm going
process
to
in
ask
such
you
a
a
system,
question.
the process
Then
typically
I'm going to
crashes.
finish the lesson. Now, you know what
Now,
RAM is,
Page
right?
swaps
In
are
summary,
implemented
RAM
by the operating
represents
system.
the networks we create.
Some assistance
by
from
combining
hardware is
different
required to
maps.
determine
In
when a
this
page swap
my
needs to be
question is,
performed.
what is the largest
When
byte
translating
array
a page
network
number to
in
a
the
frame
world?
number, the MMU
The answer
checks to see if the
comes to your
corresponding
mind
frame
readily.
is resident or loaded in RAM.
Itself is the largest
If
byte
the frame
array
is
network
present, the
in
memory
the world.
access proceeds as
However,
normal.
I want to remind you again.
If the frame is not
Not
present
that.
in RAM,
The
however,
company's ban
the MMU generates a
with
page
VPN
fault, which is a
different
CPU
from
exception that is similar
While
in
one of
concept
these
to an
bans is
interrupt.
completely
A
special,
specific
the
page
company,
fault handling
the
routine
internet
is
is
registered with
owned
the system,
by everyone.
either as part of the interrupt
And,
vector table
yeah,
or using a
that's
separate
all
structure
I
for
would
fault
like to say
handlers.
about RAM.
A page
See,
fault
guys.
causes this routine, known as the swapper in Linux, to be invoked. It is then the responsibility
We
of
have
the
learned
swapper
a
to
lot of
locate the missing
information
page on the
about
backing
network
store
devices
and
until
load it into
now.
RAM,
And in this
possibly
lesson,
moving
we will
some
look at
other
a few
page
more
frame
cases
to the
by
backing
using
store
these
in the
devices.
process.
Let's say we have two offices belong to the
The
same
address
company.
translation
And suppose
process
that there are
gains a few
100
steps when
meters
paging is
between
utilized.
these offices.
A process makes a
However,
memory request
this
using a
is very
logical
short.
address in
In
its
this
private
case,
address
what I'm
space,
wondering
as usual.
is whether or not
The MMU
we
first
can
checks
mix
the
which one
translation
answers
look-aside
directly
buffer
to each
to
other
determine if
to
the
create
page-to-frame
LAN.
mapping is
And
present.
the answer is
In the case
we
of a
have
TLB
definitely
miss, the
because
MMU
if you
must
know
consult
that
the page
these
table to
switches
find the
to
mapping.
create LANs. Therefore,
Once the mapping
you
from
can
page
create
number
a
to frame
LAN
number is
by
known,
connecting these
the
switches
MMU
to
must
each other,
next verify
even
that
if
the
they are
page
not
is
in the
actually
same
loaded in
environment.
physical RAM.
But please note that
If the
the
corresponding
distance
frame
is
is
very short
available in RAM,
between these
the memory
offices.
access proceeds as
This
normal.
distance were not
However,
too short.
if the corresponding
It's
frame
possible
is not
to
in
make
memory,
these switches
the
by
MMU generates a
creating
page
LAN.
fault, which is essentially a type
Meanwhile,
of interrupt.
these types of LANs
If generated, the
called
page fault causes the
campus
operating
area
system
network
to switch
or briefly
context
CAN.
to the
These
page fault
types of
handling
networks
routine,
are
which
generally
retrieves
used
the
on
corresponding
university
memory
campuses.
contents from the
Okay?
backing store.
On the other hand,
Once this
you know
process
that
is
we can
complete,
also
the
connect
OS
these
changes
two
the
offices
CPU
by
context
using
back to
LAN
the original
with
process,
VPN.
and the
But
memory
please note
access
that
proceeds as normal.
WAN and LAN are different kinds of network types.
In order for the MMU to be able to detect situations in which a requested memory frame is not physically present in RAM, an extra bit must be added to the page table. This bit is set to 1 whenever the contents of a logical page are present in a memory frame.
Which one do you
If
think
the present
is
bit
more
is 0, the
LAN
page has been
with
swapped
VPN
out to the
or
backing
LAN
store.
created by connecting
For efficiency
switches to
reasons, the TLB
Please
entry
think about it
corresponding
for a
to a
short
row
time
in the page
and
table
try to answer
must
it.
also store the present bit. You might have noticed that the terminology between page and frame is starting to become a bit blurry here.
The answer
In
is
general,
simple,
we refer to
isn't it?
pages
The
of
LAN
memory being
It's
swapped out
always
to
more
disk,
secure
even
than
though
a
the
LAN,
swap operation
because
is actually
communication within
moving
the LAN
physical
packet
memory
never
frame
passes over the
contents.
internet. The
This
packet
fuzzy
always
terminology is a
on
result
our
of
own
historical
On
evolution
the other hand,
of the
even
virtual
if the
memory
packet is
subsystem.
protected in the WAN, the packet
Now, I'd like to take a
over the
moment to
internet.
discuss the nature
as
of
you know,
backing stores
there is
as
never such a
technology
thing
is
as
changing in this area.
100% security
Historically,
even
the
if the packet
backing
is
store was a
protected
mechanical
with
hard
tunneling
disk drive,
and
and
encryption.
a number of design
So,
decisions in the
summarize,
virtual memory
both of these
subsystem
methods
still use
are
for
secure,
consumption.
but LAN is more
However,
secure.
many
This
systems
is
now,
obvious.
especially
However,
embedded systems,
There is a
have
condition
only
that a
solid-state
WAN is
storage.
almost as secure
Since
as a
each
LAN.
block on a
We
solid-state
call private
drive can be
for this
erased
type
and
of
written only a
By the
finite
way,
number of
we haven't
times,
talked about
there is
this
some
LAN type
question as to
before.
whether it is
I
a good
mean,
idea
this
to
is
use an
different
SSD
from
as a backing
magnet
store
VPN
for virtual memory.
because the line between
Many
offices
embedded devices do
dedicated
not use
for the
paging
company.
for this
You
reason.
request this line from
Another
ISP
issue with the backing
and give a
store is
special
that it
money
is
for
subject to
this line.
attack via
Thus,
forensic disk
ISP
analysis
gives you a
methods
private
In the
life
event the
that
device is
only
lost
your
or stolen.
company can use.
Sensitive
the WAN
information,
created in
such as
this way
cached passwords and
private
other
WAN.
credentials,
Okay?
might have
Please
been swapped
remember
out
that
to the backing
We were
store,
using public
and these
internet
pieces of
network
information
with
could be
VPN.
recovered.
And that's why
One solution to
also
this
called
problem,
VPN,
which is available as
is
an
public
easy-to-enable
WAN.
option
very
in macOS 10,
in addition,
is to
even
encrypt the
private WAN
contents of
sounds
virtual
great
memory.
at first glance.
The downside to this
quite
approach
costly.
is the addition
For
of
this reason,
CPU
It
overhead
makes sense for an
on
average
top of the
company
generally slow
to
nature
prefer
of the
public
backing store
instead
hardware.
of private WAN. You know, public WAN
Another
provides
approach
us
to
security
avoiding
that
the issues
we
of write
definitely
limits
cannot
and
underestimate,
post-mortem forensic
right?
recovery of
One.
sensitive memory data
Now,
is to
I
use the
want you
Linux
to pay
compressed
attention
caching
to one point.
or
Some of you
Compcache
may have already
mechanism of
noticed
the
this,
backing store.
but it will be good to mention
With this
in any
approach, the
case.
section of RAM
We
is
use
reserved
switch
ahead of
devices
time to
to
create a
create a
compressed RAM disk
while we use
or
routers
CRAM
to
disk.
create a WAN.
When a page
Very
is swapped out
I
to the
want to repeat
CRAM
this
disk,
again. We
it is
use
compressed
switches
on the fly to
create
fit
a
into
LAN
a smaller
while
amount
we
of
use
memory.
routers to create
Whenever
a
a
WAN.
page needs to be
This
swapped
means
in from
we
the backing
cannot
store,
create a WAN
the page
by
is
using
read from
switch
the
devices,
CRAM disk and
because a
decompressed.
WAN fundamentally represents
Although the
connection of
compression and
different
decompression steps
With the
do
help of
result in
LANs,
CPU
different
overhead,
LANs can
the
act
Compcache
as
system
if
is
they're in
still
the same
generally
environment.
faster than using a
And you
disk
know
or
that
SSD
if you
as a
want to
backing
connect
store.
different LANs, we definitely
Furthermore,
need a
Compcache is
router
as
for
secure
this
as
task.
RAM
You
against
got the
forensic
point.
analysis, particularly against
I want to
recovering
talk a little
sensitive
bit
information
about
from a
routers.
system
Until
that has been
now,
powered
I
off for a
have
period
always
of time.
explained the router as an internet-related device.
In this
However,
lecture, I will
it
continue
is
the
a
discussion of
main
virtual
task of
memory
the
by
router
discussing
is to
paging
connect
performance
different
and
networks.
introducing
That's
demand
it.
paging,
You should realize
copy
that
on write,
these networks
memory
may
mapped
be in
files,
different parts
and
of
shared
the world,
libraries.
or maybe in the same office. It really
Swapping
doesn't matter.
pages to and from a
In this
backing
slide,
store
you
is a
can see
relatively
that
slow
two
operation
different LANs
compared
in
to
the
a
same
direct
office
access to
are
RAM,
connected to each
due to
other
the fact that
thanks
most
to the
backing
router's
store
device.
hardware is
Suppose
several
that one
orders of
these
magnitude
networks
slower than
is
RAM.
related to the marketing unit
Whenever a
of the
page fault
company,
occurs,
and the other
the memory
is related
access
to
that
the
triggers the
software.
page fault will
And
require
as you
more
know,
time
if we
than a
want
non-faulting
different
memory
networks to
access.
communicate with each other,
As
we
long
should
as the
use
number
a
of
router.
pages swapped out to
The
the backing
animation,
store is
we can
relatively
see that
small compared to the
LAN
total
1
number
and
of pages in memory in the
communicate
system,
through the router.
the performance cost of page swaps is amortized over all memory accesses. As a result, the average memory access time is increased by only a small amount relative to a system that does not swap out
I want you
pages.
to focus on
However,
cables
if the
of
fraction
the
of
router.
memory accesses
Floor of
resulting in page
each
faults
cable
becomes too
is
high,
connected to a different
the system
network.
begins swapping
One
or
of the
thrashing
cables is
its
connected
memory
to
on
LAN
most
1.
or all
One
memory
of the
accesses.
cables is connected
This
to LAN
situation
2.
typically
And one of
occurs
the
when memory
cables
becomes
is
oversubscribed
connected to the
due to a program bug,
This is the case
and the
for the
result
router.
is a system
The
that is
router
painfully slow to
connects
respond
different
to user
networks,
input.
For this reason,
In some
each
cases,
cable
on some
connected to a
systems,
port on the
the
router
OS may need to be
represents a different
rebooted to
network.
recover from the swapping
By the way,
situation.
you may have wondered why different networks
With
are
any paging
needed
system, it
within
is
the same
necessary to
office.
decide on a
As a
virtual
matter of
memory
fact,
fetch
It's
policy,
a common
which
situation
determines
in
how
real life.
data are loaded into
You may
memory
want
pages for
different
the first
units in the
time,
office
typically
to
when a
be in
program is
different
started.
This might
A
be
lazy
absurd
implementation
for
of
an
page
office
fetching
with 4
is to use
computers.
demand paging,
However,
which loads a
imagine
page
an
from the
office
backing store
with 50
into RAM
computers in it.
only when it is
Dividing
actually
these
required.
computers into units
This approach
increases
improves the overall
hierarchy
responsiveness
and
of
order.
the system
Never
and
forget.
increases the degree of
As
multi-programming
you can see,
at the expense
basic
of reducing
principles
the initial
are the same
performance of
everywhere.
newly started
By using
processes.
these basic
The
principles,
main
we can
alternative to
enable
demand
devices
paging is
in
prefetching,
different parts of the
which
world to
loads some
communicate.
pages into
And
memory
we
before
can
they are
enable
actually needed.
devices in the same office
Prefetching may
to
waste some memory by
Both of
loading
them
data that will not be
represents the
used.
same task.
However,
I
it
think
does improve the
you
startup
understand
performance
this
of many
concept very
software
well.
applications.
That's
For
all
this reason,
I want to say
prefetching is a
in this
fairly
lesson.
common feature of
See you guys
desktop
soon.
operating systems. When memory is limited, or electrical power is
In one of
severely
our
limited,
previous lessons,
a
I
pure
told
demand
you
paging
we
approach to
purchased
fetching
this
may be
cable
appropriate.
that came to our home
Pure demand
from
paging
ISP.
does not
But I
prefetch
haven't
any
mentioned
pages,
what
including
exactly
the text
ISP is.
segments of newly
And
started
in this
programs.
lesson, we are going to
When a new
discuss
program
what is the
starts,
ISP
a page fault
why
occurs
it
at
is
the
so
first
important.
instruction,
The
and the first
Internet
page of
Service
program
Provider,
code is
or
loaded into
briefly
memory.
ISP, is
Pure
responsible
demand
for
paging
the
has the greatest
transmission of
potential
packets
to increase
from
the
one
degree of
location to
multi-programming,
another.
particularly in
remember,
situations
we have
where
learned
physical
that
RAM is
there are
extremely
a lot
limited.
of routers in the
In
heart
addition, the
of
lack
things.
of prefetching can
I'm
save
talking
CPU
about
and
this
memory
structure.
operations,
And
thus
you can
providing
think
a
of the
small power
ISP
savings
as the
when
mechanism
operating
that
from battery.
controls all these
As
routers
such,
in
pure
this
demand
structure.
paging could be
For
useful on
example,
smaller
there are
embedded
actually
systems,
many routers
especially
in this
monitoring
global.
devices and other systems
Similarly,
without direct
there are
human
many
interaction.
routers in this regional ISP. But to
While the
simplify
fetching
the
policy
concept,
has a high
I can
impact
visually
on
show
newly started
routers
programs,
within the
a
ISP.
copy on write approach
However,
improves
I want you
performance
to
whenever a
imagine
process makes a
the
copy of
routers
itself.
distributed around the
On
world
Unix-like
are controlled
systems, new
by these
processes are
ISPs.
created when a
Very
running process clones itself
As of each
to report
ISP
system call.
controls specific route.
Cloning all memory at fork
Packets
time
are
could be a
sent from
slow
one
operation.
location to
The
another location.
process might
Over
be using a large number of
We
pages.
previously talked about
Copy on
how
write
packets
addresses this
from one
performance
point
issue
to
by
another
having the clone
via route.
initially share the
Understanding
original
how
process's memory
is the
pages.
first condition to
These shared
understand
pages
ISP.
are marked
What
read-only,
I am trying to say
causing the
is
MMU to
certain
fall if
ISPs
either
are
process tries to
responsible
write
for
them.
certain routers.
The operating system handles this type of call,
Every ISP
copying the
in
page
this picture
and turning
is
off the read-only
responsible
bits
for
to
certain routers.
copy in the original page.
But I am removing them from the visual for
This
this
diagram illustrates the copy on write
In
process.
addition,
In the top half
ISP
of the
model
diagram,
you see
the
here
original
is a
process
simplified
forks a
model.
child
But
process,
even if the model
which
is
initially
simple,
shares the
it's
original
enough to
parent's
understand
pages.
the most
The
important
child
parts
proceeds to
of
modify
ISP.
page 3 in the bottom half of
Let's
the
start with
diagram.
basic definition
When this
of the
modification is attempted, the
ISP.
MMU raises a
Different
call to
companies
extract
that
the
serve
operating
us so
system.
that we can connect
The
to the
operating system makes a
And
copy of the
course,
corresponding
they
memory
charge a
frame,
certain fee
gives
for
the
the
copy to
server.
the child
We
process,
cannot connect
and
to the
removes the
internet
read-only
without
setting
an
on both the
ISP.
original and
Think of
cloned
ISP
page.
as the
The
structure
child's
that allows
page is
you
then
to
updated
connect
with
to
the
the
modified value from
And
the memory write,
ISP
and
is
normal
not a single
process
structure.
execution resumes.
There are hundreds of thousands of ISPs in the world.
In
and
addition
all
to
these
increasing the
ISPs
degree
come
of
together
multi-programming
form
by
the
enabling
structure you
pages
see
of memory to
in
be
the
swapped
visual.
out to a
There
backing
is
store,
few ISP in
virtual
the
memory
visual, I know
subsystem
that.
can also
But
be
I
used
can
to
say
improve
that
I/O
there are
performance
hundreds of
for
thousands of
processes on the
ISPs
system.
in real life.
When
The
programs
most common
request
ISP
I/O
type
for
in the
persistent
world
storage
is local
devices,
ISP.
these
And now,
requests
I
generally
want to
take a
start with
significant amount of time
The
to
first
fulfill
step of
due to
connecting
the
to
relatively
the
slow
internet
speed
is
of
to
a persistent
communicate
storage
with the
device.
local ISP.
Since
And
many
local
processes
ISPs are
perform
generally
frequent reads and
responsible
writes
for
of
small
small
area
pieces of data,
communications. For
the
example,
performance overheads caused
communications
by
of
waiting
two
for
different
device
labs
I/O to
in the
complete
same
become
neighborhood,
substantial.
or communication of
The
labs
virtual memory
located in
subsystem can be made
neighborhoods
to reduce
close
this
to each
overhead
other.
by memory
Let's
mapping
say
files.
we live in the USA.
Page-sized
These
pieces
two
of a
homes
file are
are
loaded
located
into
in
memory,
the same
where they can be
neighborhood.
read and written
If this
efficiently.
computer
These
wants to
pages are
communicate with
periodically
this
written back to
computer,
the persistent
connection
storage
is
device.
provided directly over this local ISP. This is up
As is the case
can
with
see
paging
this
in general,
on the
there is
animation.
no requirement that memory mapped
The packet
files be mapped
passes
into
through different
contiguous
routers
regions of
at
physical
the
memory.
local ISP. and
Logical
reaches
addressing is
its
used to
destination.
present an ordered, contiguous, logical view
But
of the
in
file
general,
or process.
Since the local ISP
However,
is
the file may
responsible
be
for the
mapped out of
communication
order
of
in
small
non-contiguous
areas,
memory
the
frames.
packet can also
Although
pass
the
through
file will be
only
put
one
back in
router
order when good
before
storage
reaching its
exists,
destination.
the file still might be
Think of this local
non-contiguous if the
ISP
file
is the
system is fragmented.
ISP that only connects LANs within a
To
neighborhood.
reduce the total amount of
Of
memory
course, the local
required by a
ISP
program,
can connect
and to make
different
software
neighborhoods,
development
but in
easier,
this scenario,
certain
let's say
programming
it doesn't.
routines are implemented in
Therefore,
shared
one router
libraries,
can be
which
enough
can
to
be
connect
used by
them.
multiple
You got
programs
the
on the
point.
system. When these libraries
And
are
in this
used by a
visual,
program,
we can
they
see
must be
an
made
example
available
of
to
a
the
small
program when it
ISP
runs.
office. And we
In
call
a
these
simple
offices
case, which defeats
points
the
of
memory-saving
presence,
potential
or
of shared
briefly,
libraries,
hub.
the compiler
In fact,
may statically link
routers
or copy
distributed over
the
the
library
internet are
into the program
included in
executable
these
at compile
paths.
time.
And in this
A
path,
more efficient
in other words,
approach
in
is
this
for the loader
office,
to link the
routers
program to the
are
shared
on the left
library
side.
at runtime.
In addition, you
On
have
disk,
probably noticed that
precompiled shared
there are
libraries
other
are stored in
devices
binary
than
form
routers.
as shared objects
because
or .so
sometimes
files
we
on
must do
Unix.
different configurations
These libraries are
different
called dynamic
devices.
link libraries or
Laptops
DLLs
have
on Windows.
routers, switches,
Runtime dynamic
servers, and
linking
so on.
of these shared
But the device we
libraries
use to connect
relies on
different networks to
read-only
each
shared
other
pages
is the
that
router.
can be
You know,
used by
for
multiple
this reason,
programs
we will
at
only
the same
focus on
time.
routers. And in our previous
Shared
lecture,
libraries are made
routers
available
on
to
the internet
processes
region
by mapping
were
them
actually
into the middle of the
represented
logical
hubs
address
spread
spaces
over
of
the
each
world.
process.
And in order
Between
to
the stack
explain
and the
this
heap,
better, I want
these
to focus
shared
on a
objects
different
limit the
image.
maximum
But
size to
in
which
this
the stack
image,
or heap
I
can
want to
grow
think of
before running out of
different
space.
houses and offices
The
connected to
situation
local
in which
ISP
shared library
and local
mapping
ISP
becomes a
tree.
problem
I mean,
is when
we
virtual
both talked
machines
about
are
these
implemented
hubs.
on
You got
32-bit
the point.
hosts.
And
The hypervisor process on these hosts has a maximum logical address space of 4 gigabytes.
over local
When
speed,
the hypervisor tries to allocate a large contiguous block of memory to provide RAM to the guest system,
for this
the allocation could run into the shared
This should
libraries,
be clear.
resulting in failure.
By the way, If you
I
are
have seen
aware,
this type of failure occur on a 32-bit
has
host
4 parts.
when trying to
You might
allocate a
think that
contiguous
thanks to
block
these
of
4
just over
parts,
1.2
local
gigabytes
SP2
on a
connects
Linux
different
system with
pages.
4 gigabytes of
And in
physical
this
RAM.
way, LANs
It
in
is for
different
this
neighborhoods
reason that a
can
64-bit
communicate
operating
over
system is
local
desirable,
SP2 effectively.
even for physical
And from
systems
here,
with only 2
we
to
can
4
draw the
gigabytes of
following
RAM.
conclusion. Some local
For
SPs
sure,
can
I will
have more
discuss
than one
page
part.
replacement as it
However,
is used in
some
the
local
virtual
SPs
memory
can
subsystem.
only have one part.
I will discuss
This
global
depends
and
on the
local
size
page
of
replacement,
local SPs.
page table
For example,
entries that support
If a
page
local
replacement,
SP connects 4
and a
different
number of
neighborhoods,
classical page
it may
replacement
have 4 different
algorithms.
parts. But if a local SP connects
Whenever
only
there
one
is a demand
neighborhood,
for memory
it
that is
has
greater
only
than the
one
actual
part.
amount of
You
physical
catch
RAM
that.
installed on the
And
system,
if you want to do
the
more
operating
detailed
system must
studies on
determine
this
which
topic,
pages will be
you will
kept
see
in
many
memory
resources
and which
on
pages
the
will be swapped
internet
out to
with
disk.
route records.
When
You should
memory
be
frame
aware that
contents
these
are
items
swapped out to disk,
actually represent
the operating
router
system needs to
within the
find a
part.
page of memory
There are
that is
many
not
parts
currently in
distributed
use.
all over the world, and
Furthermore, in an
routers
ideal
are in
case,
these
the operating
parts.
system should
It's
also
that
pick a
simple.
page
At
that will
this
not be
moment,
used for some
I
time,
want you to
so as to
imagine that
reduce the
there are
total number of page
hundreds of
swaps.
thousands of local ISPs in the world.
In order for
These
the page
local
swapper
ISPs
to operate,
connect to
some
regional
additional
ISPs
data must be
that are
kept
larger
about
than
each page,
This means
including
that
whether or not the
different
page has
local
been
ISPs
referenced and
communicate
whether or not the page
over
has been
regional
altered
ISPs.
since it was
For
last
example,
swapped
local
into RAM.
SP2 communicates with local SP3 over the regional
Decisions
SP1.
regarding page
As a
swaps
matter of
can be made
fact,
globally
we can
or
think of
locally.
local ISPs
With
connect
global replacement,
neighborhoods,
any
and
page in the
regional
system is a
ISPs
potential
connect
candidate to be
cities
swapped out
in
in
a
favor of
country.
another
It's
page.
that simple. I
While
want to repeat
simpler
this
to
again.
implement,
You can
global
think of
page
local
replacement
ISPs
does allow
connect
processes to
neighborhoods
steal
or
memory
small
frames from each
areas,
other.
and regional ISPs
On the other
connect
hand,
cities
local
in a
replacement
country.
policies allocate a limited
Meanwhile,
number of frames
there
to
is
each
one regional
process.
ISP in this
When a
simplified
process
model
exceeds
used,
its frame
but in
allocation,
real life,
only
country
frames belonging
can
to
have
that
many regional
process are
ISPs,
selected
and
for
all
replacement.
local ISPs and regional ISPs combine
Implementing
in
a
order
local
to
page
create
replacement
network
algorithm
of
is
a
more
country.
complex than it
In
seems on
summary,
the
the
surface,
first step
largely due to validated anomalies.
is local ISP.
Allocating
And
more
this line
frames to a process
represents the
does
line
not
we
necessarily
purchased
reduce
from
the
the
number
local
of page
right?
faults that occur as a
Everyone
result
or
of that
office
process.
must purchase such a
In
line
fact, with
from the
some
relevant
replacement
ISP
algorithms,
to connect to the
increasing the number of
And
available
if you
frames
examine
actually
your home router
increases the
carefully,
number of page
you can
faults
see
that
the
occur.
cable coming from your
At the
ISP.
opposite extreme,
Wonderful.
allocation too few
Now,
memory frames to
let's
a
suppose that
process also
this
increases
computer
the
and
number
this
of page
computer
faults.
want to communicate
Without
with each
enough
other.
physical
By the
memory,
way,
processes
these two
will
homes
spend more
are
time
located
page
in the
faulting
USA,
or swapping
but they are in
than they will
different
spend
cities.
executing.
As a result, they
The
are
goal of
connected
a
to
local
different
replacement
localized
algorithm is to
This is
find
obvious.
an optimal
So,
working
in this
set for each
situation,
process.
how does this localized
This
work?
working set is the minimum number of
Let's see.
frames that a process
fact,
actually
This is
requires
rare.
in order to
Regional
execute
SP1
some
comes
desired
into
level of efficiency.
In general, the regional ISP is engaged
Regardless of whether global or local replacement policies are chosen, the operating system needs a few pieces of information to implement page swapping
local
correctly.
ISPs communicate over the
First,
regional
the
ISP.
operating system needs to know whether or not a page that is currently in use has been referenced by a process. Pages that are loaded and used might be more ideal candidates to be
Why there is
swapped
no
out
direct
from back
from local ISP to
The
local
second
ISP?
piece of information
Not
that needs to be
expected.
stored in the page table is
Just
the
think
30
about
bit.
it.
终将对上
This
Local
bit
ISP
is set to
to
1 whenever a
The
process
hierarchy
writes
is
to a
wrong.
page,
I mean,
which lets the operating system know that the copy of the memory frame contents on the
that
back
can
end
be
storage
many
needs to be updated
even in the
whenever the
same
page is
system.
swapped
And
out.
if we connect them all
Keep in
together,
mind that on systems with hardware managed page tables,
and we don't
such as
want
the
to
x86 and
complexity
x86
of
platforms,
it is
the
all
MMU
quite
updates
complex.
these bits automatically.
And that's why we use essential
Whenever a page fault
hierarchical
occurs,
ISP
the operating
structure
system
in
must
which you see
locate the
individuals.
desired page
The
on the
minimum
back end
number of
storage.
connections
Then it must find a free frame in RAM
ensure
to
that
which the page
all
can be loaded.
ISPs communicate with each
If
other.
no memory frames
It's
are
that
free,
simple.
the operating system must select
So
a victim
far,
frame
we
to
have
be
talked
swapped
about
out from
local
back end
ISP
storage.
and regional ISP.
哪里？
The algorithm that is run to determine which frame will be the victim is
always
called
in
the
the
page
USA.
replacement
But
algorithm.
what if computers in different
Page
countries
replacement
want to
algorithms
communicate
ideally
with
should
each other?
minimize the total
That is
number of
where
page
the
faults in
global
the
ISP
system
comes
in
into
order to
play.
maximize
You may
system
think that
performance.
the global ISP
Let's
我
take a look
在
at
东
some
莞呢。
classic
different
page
countries
replacement
in general.
algorithms.
As you know, there is an ocean
The
between
first
the
classical
USA
page
Changping
and
Zhen.
replacement
China.
algorithm
So,
consider
if a
is
device
the
can
random
dismiss
啊，
outcome.
你就写南山嘛，南山蛇口。
it must
This
be a
algorithm
global
simply
ISP
picks a
that
victim from
provides this
random.
connection. We
In
can
practice,
Yeah.
this random selection often picks a page that will be needed
and
in the
regional
future. leading to another page fault in a short time
There
period.
are multiple global
As such,
定位
it is
到
not effective
少年宫就那定位到哪里
Another
哪里嘛？
ineffective algorithm is to select the oldest page, or the page that has been in memory for the longest
This
period of time.
computer
那它定位错了，那
Unfortunately, this page could be
in this
frequently
case, the
accessed,
packet will
so if
first
it is
go
swapped
to the
out,
localized
another
feature
page
here,
fault could be
and
triggered
then
in a short
go to
period
the
of time.
regionalized
你
to
就
reach
写
back to memory.
南山
Somewhat
南山
counterintuitively, selecting the
蛇
page
口
that is accessed the least
什么
frequently
街
is
道
also
啊？
an effect.
or globalized
A
feature.
page
太
that
子
is
路啊，你
used
就写
frequently might still
This
be used
selection is
regularly,
determined by
which
the
would lead
routers.
to another page fault to bring this frame back into
蛇口太子路2号
frequently used algorithm picks whichever frame is being used the most and selects that frame to be swapped out
in
to the bagging
迎
system.
宾大厦
This is a completely stupid idea.
迎
since
宾
this
大厦
page is likely to be accessed again shortly after it is
迎
swapped
接
out.
的迎
Who knows?
A good algorithm for choosing victim frames is the least recently used
二
LRU algorithm.
204吧
This algorithm selects the
globalized
victim
feature
frame that has not been accessed
And there we
for the
Yeah.
longest period of time.
And in this stage,
Unfortunately,
Yeah.
with current hardware, there is no good way to track
or
the
to it
last
to the
memory
regionalized
access time.
feature, or
Tracking every accessing software would be a terrible idea.
就是太子没什么街
Require an interrupt on every memory access.
can follow different
Thus,
paths.
it is impractical to implement
some of
LRU
these
directly.
For example,
Most implemented
from
page
globalized
replacement algorithms are
localized
approximations of LRU,
regionalized
however.
feature, localized V7, and destination.
Theoretically,
Or
the optimal
from
algorithm,
localized feature,
or OPT, is the best page replacement algorithm to
localized
use.
V7, and
With
destination.
this algorithm, the operating system
localized
thinks
feature
the frame
to
will not
globalized
be accessed for the longest period of time as the victim,
Localized V7,
delaying
and
a future page fault related to the
All of
corresponding page
are
for as long as possible.
you should also have
Mathematical
this
proof
situation
is showing that the OPT is the best
destination of the
possible
packet
page
plus
replacement
this
algorithm.
the packet
Unfortunately,
This
OPT is
destination
also
access
impossible
over
to
localized
implement
V6
since it must be able to
over
predict
regional
memory
level.
accesses ahead of time.
Some localized V6
As such, we are left with LRU approximation algorithms, such as the not used recently or NUR algorithm.
Localized V6
NUR tracks frame accesses using a combination of the reference kit, dirty bit, and/or an age counter. This algorithm produces reasonable performance in actual implementation.
Actually, there are two ways for this kind of
In this lecture, which is presented in two parts, I will begin discussing process.
its location.
I will introduce the process model, discuss the type of information associated with the process,
Already have
give an overview of process state, and introduce the concept of process order.
Doesn't have
As is usually the case, my presentation is focused on Unix-like
must be
systems.
paid for this connection by the localized V company.
Let's begin by defining what a process is.
You catch the idea.
A process is an instance of a computer program in execution.
Let's say
When we ask a computer system to run a program,
of localized
the code for that program is loaded from disk into memory and executed as a process.
you go to the localized V7.
On
And
some platforms, processes might be called jobs or
localized
tasks.
V7 is connected directly
On a
to the
modern
destination
system,
lab,
a process consists of one or more threads of execution.
where it will send
In other words, a process can execute one instruction at a
the
time,
home route to receive.
or it can execute several instructions at the same time on the CPU.
As a result,
Each process on the system receives its own private allocation of resources.
communicate
Each
over this.
process also has access to its own data, and the operating system maintains statistics about each process in order to make effective scheduling.
We are going to cover two more scenarios related to the
In
IoT
memory, the
concept.
process is divided into
Data
segments.
model.
Program code and other read-only data are placed into the text segment. Global variables in a program have their own data segment that allows both reading
This is
and
our
writing.
home, and we want to communicate
Automatic
to an
variables
established
or
website
local variables
called
and functions
ABCX.com.
are allocated at compile time
All
and
the
placed on the stack.
websites have limited
Data
financial
structures
power.
explicitly
For this
allocated at
reason,
runtime
they
are
have
placed on
only
the
one
stack.
server on the
Since
USB.
memory is used by a process, the stack and the heap report each other.
ABCX.com
The process makes use of shared libraries. These libraries are mapped into process memory between the stack
you can see the whole process on the animation.
In order to track processes correctly and allow multiple processes to share the same system, the operating system must track some information that is
And
associated
after
with
the
each
server of
process.
the ABC-X.com
This information includes the memory the process is using, as well as the current location of the process code,
creates a response message.
known as the process
Response
program
message
count.
contains
The operating system must also track other resources in use by the process, including which files are currently open and any network connection the process is using.
Meanwhile, if you don't know what an HTML
In addition to the information generated by the process
is the
itself,
skeleton of a
the
web
operating
page
system
in a
must
simple
store
manner.
scheduling information
And
with
after
statistics about
generating
each
the response
process.
message, the
This
server
information
must
can
send
be
it to
used to
us.
identify
However,
or
the
process
pattern
ID
informed by the
to
response
use to
message
distinguish
is
processes from each other.
from the pattern
In
referred
order to
by the
arbitrate
process.
access to system
Please
resources,
pay attention to
the
this.
operating
Of
system
the
must
animation.
also store
It
information
is
about the
knowledge
owner
of
of the
the
process.
exact path of the
Some information
animation
must be
beforehand.
reinforced correctly.
Since workers can make
To facilitate
different
scheduling
decisions,
decisions, the operating system selects various statistics
always
about
determined
process
on
execution,
the way.
such as the amount of CPU time consumed and the amount of memory
And
used.
as soon as we receive the response message,
During the lifetime of the
website
process,
appears
the process
in our
moves
web
through
browser.
several
In
states.
summary,
When
when
the
you
process
want
is
to
first
enter a
created,
website,
it is initially in
first,
the new
send
state.
a request
Once
message
creation
to
is
the
complete
web
and the process is ready
and
to
the
run,
web server
it
receives
transitions
your
to the
request
ready
message.
state where it
Send
waits
you
to be
the
assigned to the
response
CPU
message,
core.
which contains all
When the
information
scheduler selects the
about the
ready
web
process
page
to
you
run,
want to
that
access.
process is moved to the ready
Once this
state and
message
is given
comes to
CPU
you,
resources.
your web browser
During
runs
execution,
all
the process
information
might
from
request
this
external
response message
resources,
and displays
such
the
as
listed
data.
web page in your web
These
browser.
resources take time to provide.
As it
The
takes
process is moved out of the running state and into the waiting state, so that the CPU core can be given to another process.
However, since this process takes
Finally,
place
when
in
a
the
process is
background,
finished,
you
the
don't
place
realize
is
that
terminated,
there are complex
so that the
operations
operating system
in the
can perform
background.
cleanup tasks before destroying
And
the
now,
process into
let's
system.
try to enter google.com instead of
In this
abcx.com
diagram,
and see
the
what
processes may
you know,
transition between
Google is
states.
quite different from
At creation time,
abcx.com.
the process is
This is
placed
the time
into the new state where the operating
Unlike
system allocates additional memory and other resources.
It's many servers
Once creation is
all around the
complete,
world.
the process
And
is submitted to the
this is
system
the
to be placed in the ready state.
Google provides a much
Whenever a
more
CPU
efficient
core is
access
available
service
to
to
execute
its
a process,
customers.
it is
And
dispatched
let's
to the
say
running state
one of these
where it is
servers is not far from our house.
execution of a
Therefore,
process can be
when we want
interrupted
to
for a
enter
variety of reasons.
google.com or when we
If
want
hardware
to enter
interrupted
service
works, the
from
operating system
Google,
might have to
we
move
will
the process
probably
off the
make
CPU
this server
in order to service the interrupt. Returning the process to the ready state
will be much faster.
or the process might make an IO request, in which case the process is in the waiting state while the system waits on relatively slow IO device to provide the requested data.
In the fastest,
Once IO is complete, the process is moved back to the ready state so that it can be scheduled to run again whenever the CPU core
I
becomes
believe
free.
you catch the idea.
Upon exiting, the process is moved to the terminated state
Our
completely.
request message will go to this server close to us.
The mechanism for process creation is platform
Related
dependent.
server with the help of
By
my
introducing process creation,
You know
units
that
like
what
platforms
will
such as
happen
Linux or Mac
after
OS
this
X.
Google
These platforms all processes descend from a single parent process that is created by the kernel at boot
time for
time.
Google to communicate with
On
us.
Linux, this first process is called init, which is the common unit name for the first
Once
created
it
process.
is distributed in general.
Apple decided to call this process
Google
launch
is a very
D
good
on
solution
Windows
for
10.
this kind of issue.
By convention, the initial process always has a process ID of 1.
Let's see.
The initial process must also remain alive the entire time the system is up and running.
Direct connection
Otherwise,
have
the whole
ISP
computer crashes
to
will
provide
occur.
faster access to each server.
The init or
As
launch
you
D
can see
process
on
is
the
started
animation,
by the kernel
Google
boot time.
connects directly to
Every
the
other
lockdown.
process on the system is a child
When
to
we
the
want to
special
get a
process.
service from Google, we will be able to
Child
communicate
processes on
directly
Unix are
with
created by
servers
forking
without
parent
using
processes.
ISP
The
infrastructure.
parent process
In
is
this
a
way,
system
Google
called
can communicate with
which makes a
customers
copy of the
much
parent
more
process.
effectively and
This
quickly.
copy, which is initially
This small
unknown,
Everything
is
is
called the
good.
child
But
process.
what about security?
It is
Just
up
the
to the
number of
parent
packets
process to determine
that
what
packets
if
passes
any
through
resources
reasons
it will
to
share
check
with the
the
child
parent.
process.
Security
By
increases
default,
far.
the parent process
And the
shares
parent
any
process
file
to
descriptors,
Google
network
via
units,
localized.
and other
In
resources
other words,
apart from the
the
CPU
packet
and
does not use public
child.
ISP infrastructures.
However,
Many
parent
people
code flows or
remember that
reassign
security
resources
is very
in the child
important 如
They
果
want
这
a
个
child
验证是
completely
那一方
independent
俄
of
罗斯
parents.
在诉讼中央的
This
地位
direct
将本
connection
不
decreases
Once a
并
child
且也
processes
向以美
forward,
对
the child
美
becomes
是
an
告
independent
诉俄
instance
苏
of
联
the program,
是好
which
棋
will be
下一
scheduled
万
to
顺
run in
利
parallel with
Last
parent
but
program
not
的图
least,
纸物
I
However,
want to give
将
you
在
an
这个
example.
意义
can
非
be
凡的
This
上
is
空
now
炸弹
child
在
YouTube
空
is
中
owned
展示
by
各
Google.
个地
before
图
the
的
parent
So,
图形
now you want to watch a
是人
video
类历
on
史
your
上唯一
processes
一
your
把
alternative
child
Google
process
distributed
in
servers
爆炸
around
太
the
阳的
world.
光
On some
And you are
systems,
all
the termination
aware
距
of
离
the
爆
parent
炸地
process
前
will
可以
terminate
100
all child
都能
Now
看
you
到
want
海
to
岸
watch
的
a
照片
video on
On
YouTube.
other
特
systems,
大
You
号
can
的
look
大
at
彩
it
色的
without
光
having
导
to
致
interrupt
四
the
处
clock
的
forever.
眼睛
The
的
main
视
reason
行
for
者
this
因
is
此不像
the
风者
distributed
直接
server
使
structure
地面
and
升
the
腾
queuing
的核心
infrastructure
直径超
of
过
Google.
9000米，模
On
拟
the
一
other
个
hand,
接近
you
4
may
米
using a child
sometimes
高
see
原
process
数
reasons
has
字
the
that
ability
这
to
个
load
高
different
比基
why
本
would
的
you
土狼马
easy
会
us
接
on
近
using it?
爆炸
Because
范围内的
loading is
系统
Udemy
开始
simply
设备
structure
近视力
is
图
not
环
as
境
strong as
水
Google's
，places the
in
entire
general.
program
Of
code
course,
in the
Udemy
process.
also
Program
uses the
code
distributed
爆炸
server
产生的气
structure,
浪被
but
推
this
出
number
接近
Programs on
probably
Unix like
not as
systems
many
are
as
started by
Google.
forcing
Of
existing
this,
programs
in addition,
and executing
Udemy
new
Udemy
programs
doesn't
on
use
child
peering,
process.
and you know that peering is a very efficient
When
technology.
multiple processes are executing on the same system, they have the ability to
And
execute independently or share
But
information
I can
between
say that
systems.
Udemy
An
is
independent
a
process
job
is
of
completely
rock.
separate from other
Because
processes in the system.
millions of
Its
people at the
execution
same
is not
time is
affected
a
by
really
other
challenging
processes.
engineering
It
problem.
cannot affect other processes
summary,
as long as the
Udemy
operating
is a
system
very
is
efficient
designed and
structure
implemented.
造成1个小
by
时的无
giant
线电
companies
通讯，
like Google,
Processes can
Amazon,
share
and
information
Microsoft.
between themselves and thereby affect each other.
And finally,
When this
I want
occurs,
to
the
give
state
you
of
some
process
general
may be
information about the ISP.
Cooperating
As
processes
you know,
may be used for a
global
variety
ISPs
of
are
reasons,
responsible
including
for the
information
international
sharing,
communication.
implementing
I can say
high-performance
that
parallel
also
computation,
definitely not as many as
increasing the
regional
modularity of
ISPs.
program
There are a
implementation,
few global
or
ISPs
simply for
as well.
convenience when
And
implementing
I
certain
guess that
designs.
the technical reasons for not
In part
having
2 of this
only a
section, I will
few
provide
global
additional
ISPs
detail
in the
about
world.
process
We have
forking
talked
and
about
executing
similar
new
things
programs.
before. But in addition to these reasons, like load balancing and
In this lecture,
dispatching,
I will
there are
continue the
also
discussion of
some
processes
financial
by
reasons for
introducing
this.
fork,
I setting
exact,
up a
and
global
weight
ISP
system
company
calls.
is a very
I will
costly
provide
business.
examples
It
of using
makes
the system calls
it
in both
makes
C
all
and
a lot of
Python.
money. You know what I'm saying, right? If you have a lot
Processes
of
are
money,
created on
establishing
Unix-like
a global
systems,
ISP
such as
company
Linux,
is a
by
good
using
choice.
the fork
It will
system
probably
call.
make you smile.
This call is available as a C
By the
function
way,
by including the
also
unstd.h
called
header
platform,
file.
the network
In
global
Python,
ISP
access
setup
to
with
fork is
internet.
provided by an
Familiarity with
OS
internet
module.
backbone term can be useful for you in the future.
In this C example,
There
I
are
fork
some
child process
calls
simply prints a
internet
message.
exchange points
My code
not
begins
for
by
internet
importing the
backbone,
stdio.h
but
and
and for global
unstd.h header
ISPs
files
to communicate with
print
each
out
other
and fork
more
functions
efficiently.
respectively.
And we briefly call these
Inside my main function, I declare a variable named heads of integer
Java
type.
program.
I then print a
And the
message
last thing
stating
I
that I
want to
have
mention
not yet
is that
forked the
you
parent
don't have to
process.
connect to a local ISP
I
in
call
order
the
to
fork
connect to the
function
internet.
without arguments,
You
and I
can
assign
write
its
to
return
a
value
regional
to the
ISP
variable.
or global ISP.
Upon
These
completion of the
ISPs
fork
have
function,
a service
I will have
for
two
your
copies of
location.
my program
This
running
means
at the
that
same
you
time.
can learn which
In
ISP
the
is
first
most
copy,
valuable
where I call
and
fork,
make your choice
the value of the
according
hid
to
variable
the
will be set to the process ID of the
your
child
decision
process.
to choose the
In my
ISP
child
service you
process,
want.
the value of the hid variable will be set to 0.
This is our home and we connect to the internet
My child
via local
process
ISP.
prints a message stating that
However,
it is the
if
child.
we request,
My parent process prints a message stating that it is the
via
parent.
regional ISP one.
Both
This is
messages
possible.
will be printed
What I am
since
trying
the
to say
value of
is
his
if you
variable will
want
be
to get
0
your
in
ISP
the
service
child.
from a certain company,
However,
if this
the
company
order in which the two
doesn't serve
messages
your
are
location,
printed is
you
not
can
guaranteed
contact the
and
company
may vary
and talk
between
about what you
programs.
want. If you give the required money to the
The
ISP
equivalent
company,
Python
most
code is a
regional
bit
ISP
shorter,
and
but
global
looks
ISP
rather similar,
can provide
owing to the fact that
service
Python is
you want.
exposing the underlying C
But for
library to
normal
the system.
users, this is very
To use the
unnecessary.
fork function, expression I need to report feelings nausea.
One choice be
I
served.
then
If
set
they
the lit
live
variable by telling OS
benefit
report
from it.
in a manner similar to the corresponding
you want
C
to set
code.
up a local SD
Upon receiving this call, the entire Python interpreter process will be flown.
we talked about
Hidden
the
variable
ISP
inside my script in the parent interpreter process will contain the process ID of the child Python interpreter process.
about the
In
ISP
the child
package.
interpreter, the bit variable in my
That's
Python
all
script
I
will have
have
the
to
value
say
0.
in this call.
Since the value of PID is 0 in the child process, the child message will be printed. In the parent process, where the
This
value
course will help
is
someone
not
with
0,
no
the
technical
parent message will be printed. Both messages will appear in the output of the script, but the order of the messages is not guaranteed and may change. While we sometimes fork processes in order to create parallel programs, a more common use of forking is to start another program. We can replace a currently running process with another program by using the exec system call, which is made available through a variety of functions in C and Python. One important thing to remember about the exec system call is that it completely replaces the currently running program with the new program. A common error is to try to put program code after a call to exec in an attempt to perform some other operation after the external program is finished. However, any such code placed after the call to exec will never execute, since that code gets replaced with the rest of the original program. Now, in practice, the exec system call is implemented as a collection of functions, not as a single function. These functions differ in whether or not they take arguments as a fixed set of parameters or as an array. They also vary by allowing the operating system to search the system path to find the new program, versus requiring the absolute path to the new program to be provided. Furthermore, some of the exec functions allow environment variables to be set for the new program. Regardless of the version of exec that is chosen, a standard convention on Unix-like systems is that the first argument to a newly loaded program is the name of the program itself, exactly as the user entered it. This convention allows a single program to be known in the system by a variety of names, possibly allowing it to implement different behaviors depending upon the name by which it was invoked. As I mentioned, there are quite a few variations in exec functions. In the C programming language, versions with a lowercase l in the name take a fixed number of arguments, where the final argument is always a null pointer of character type. Alternatively, versions with lowercase p in the name take a vector or array of arguments. If a lowercase p appears in the name, the operating system will search the system path to find the new program. Versions with a lowercase e allow environment variables to be modified. The corresponding Python versions of exec, available in the OS module, follow the same conventions with respect to the lettering. However, it is not necessary to pass a null pointer at the end of the L versions. Now, let's take a look at a simple C application that forks a child that execs the /bin/echo program installed on the system. Nothing has changed about the fork operation. The PID value returned to the child is always 0, while the value returned to the parent is always non-zero. However, in the child, we are now using execl to load the /bin/echo program. Notice that /bin/echo is both the name of the program and the first argument to the program. The message to be printed, hello, follows. Finally, we must terminate the parameter list with a null pointer, which needs to be cast to a character pointer type. When the child calls execl, its copy of the program code is completely replaced by the code for /bin/echo. Thus, the child never prints the final message in the program. The message is thus printed only once by the parent. The Python version of this code is shorter but otherwise similar. There is no need, nor is there any practical way, to pass a null pointer to os.execl at the end of the parameter list. As is the case with the C version of the code, only the parent prints the message at the bottom. The copy of the Python interpreter and script that was created by fork is completely replaced by the call to os.execl with the code for the /bin/echo program. Thus, the child is no longer executing the Python interpreter, and the final line of code is never run in the child. We have seen that we can execute another program using exec. However, what if we would like to take some other action after the other program executes? In that case, we can use a version of the wait system call in the parent to wait for the child to terminate. Before moving to example code for wait, take a moment to note that, in some cases, the parent process may terminate before the child process. On a Linux system, termination of the parent before the child creates an orphan child process. Some programs are intentionally designed to create orphan processes. These programs are engineered to run in the background, performing various system services, and these are known as daemons or service processes. By convention, the word daemon uses its archaic spelling here, with an AE in place of the E in the modern spelling. However, the pronunciation is the same. Daemon is incorrect, even though many people mispronounce it. Now, the C code illustrating the act of waiting on a child process to terminate barely fits on one slide. In order to get access to the wait_pid function on Linux, I need to include the sys/wait.h header file. In this example, I fork a child process that sleeps for 5 seconds before exiting. In my parent code, I announce that the parent is waiting, then I call wait_pid to wait for the child to terminate. In this simple example, I need to pass 3 arguments to wait_pid: the process ID of the child, which fork returned to the parent above, followed by a null pointer, followed by the number 0. The wait_pid function blocks, or stops and waits, until the child process terminates. Once termination occurs, the parent prints another message. The Python version of this example is considerably shorter, but once again, it uses essentially the same calls. In addition to the OS module, I need to import the time module to get access to the sleep function. The major difference in this code from the corresponding C code is that I do not pass a null pointer as the second argument to os.waitpid. Instead, I skip that argument and simply pass a 0 instead. Discuss process management. I will discuss process context, context switches, and process scheduling. Each process running on a system has a certain amount of information associated with it. A minimal set of state information that allows a process to be stopped and later restarted is called process context. Process context includes the current contents of CPU registers, the current program counter value for the process, and the contents of RAM the process is using. Switching between processes on a system is often called a context switch, although process switch is a more precise term. The operating system can perform a context switch from a process into a section of the kernel and then back to the same process without actually performing a process switch. Context switches require at least one mode switch to perform, since the CPU must enter supervisor mode to enter the kernel. Relatively speaking, context switches are a fairly expensive operation, and frequent context switching will reduce system performance. Whenever the operating system needs to switch from one process to another, it must first make a context switch into the kernel. The kernel then saves the state of the previously running process and restores the state of the process to which it is switching. A second context switch is then required to start the newly restored process. On Unix systems, processes are created via the fork system call. Following creation, the CPU scheduler determines when and where the process will be run. Once the CPU core is selected, the dispatcher starts the process. Whenever a process makes an I/O request, a system call into the kernel is made, which removes the process from execution while waiting for the I/O to complete. The process yields any CPU cores it is currently using, so that another process can use those resources while the first process waits on the relatively slow I/O device. Operations that cause the process to yield the CPU cores and wait for some external event to occur are called blocking operations. Reading data from a file is an example of such an operation. The process calls the read function, and the read function does not return until it has read some data. The process may have been moved off the CPU and then restored and returned to the CPU while waiting for the read function to return. Some processes are CPU bound, which means they perform large computations with few I/O requests or other input processes. Running processes in favor of what appear to be unresponsive to user input. This information includes the content stores process control. Here is the process control block into the process program counter, open file descriptors, and other data. When performing a process switch, it is critical that the operating system saves the process's process switch. This diagram is stored. Here are the operating system switches from the process with IE1 to the process with IE2. Switch to the section of the kernel that handles process switching. That component 1. The process switching code then restores the CPU register contents and program, and multiple linked lists overlap. All PCBs are at all process control blocks corresponding to processes. In this diagram, we can see PCBs with list links depicted by the green arrow. Jobs are in a device queue waiting on I/O. The link operates as through kernel code. Now I'd like to shift focus for a moment to mention scheduling, since it is closely related to the linked list management. First, users submit jobs refers to the swapping of inactive processes onto disk or memory subsystem. CPU scheduling works. This type of scheduling will be the subject of future lectures, which receives a process control block from the short-term scheduler and by performing a mode switch into user mode and jumping to the instruction address specified by the newly restored program counter. 还有呢，一刀，这一刀啊，很可能会砍掉那些未来真能帮到你的好朋友啊。那不是砍一刀，就是不够，你是靠谱。你说，好不容易有几个明白人走，你还要求人家帮你砍一刀，人家不拉黑你就错了，他不帮你砍，这也不算是你的铁哥们儿，对吧？你也应该拉黑他，人家拼多多明摆着就是忽悠你，谁让你跑去贩毒时候还要不快啊？你也不行，拼多多能活得很健康，在座的各位都有责任，所以你还会再去砍一刀吗？拼多多活到现在，在座的各位都有责任。拼多多的砍一刀到底能不能砍到6位的主播超级小杰不信邪，砍了2个手指，依旧没能成功砍下手。然而，事件拼多多人公布，但在直播间几万名观众的见证下，客服直接挂断了主播的电话，引发了新一轮的对拼多多的人真是不行上一次我立刻上海刘宇豪律师报告，花了3千点赞110万，评论9.4万，评论区啊乱成这样。这次啊，超级小杰直接砍了将近3个小时，直播间虽然不少粉丝还是挺乐观，无份直播间的人，光主播的粉丝群里面参加人数至少是4个人，光这里就是几千人，直播间还有几万人害怕看了一个手机，结果大家发现终究是抢夺了。当时直播间还开启了预演模式，有粉丝啊还对拼多多抱有期望，选择了可以砍，结果还是格局小了。最后的结果呢？杰哥被赠送了一个1分钱购买手机的无门槛消费券，显然不是砍出来的，应该是那边这么大的理解啊，终于上报到了。不是谁都能看得到。
这款很好看的。
你说有没有人成功？我相信肯定有幸运，人家只树立了几个人就能成功体现，不是简单的。但是这个题就会0.000001可以确定，但他们却把这个成功人数给宣传出了99.9999999，这才是对的。这次啊，超级小杰的操作只是将这个事实用一种近乎暴力的方式直接摊平给大家看。如果还有人指责看，认为自己有这个病，那最好来想一想，自己为什么要把在当天晚上500万彩票的问题。人呐，一辈子发大财的机会不多啊，用一次不少。你呢，要选择中500万，还是在大家看傻子的目光下？这一刀啊，很可能你说好不容易有几个明白人做，你还要人家帮你砍一刀，人家不拉黑你就不错了。当然了，他不帮你砍，这也不算是你的铁哥们儿，对吧？你也应该拉黑他。人家拼多多明摆着就是忽悠手段，谁让你跑去贩毒时候还要不快呀？你也不看拼多多的背后是谁？拼多多能活到现在，在座的各位都有责任，所以你还会再去砍一刀吗？
现力一响，黄金万两。
你这怎么死的？啊？水中骨啊？水在家的现在，你放在现在看看。
自己吃啊。这一个饼我说卖5块钱过分吗？我说这一个饼卖5块钱过分吗？ 一下，这个自己吃好吃就行了，知道吧？能把人吃没？发肚子了，你们看没熟怎么办？没熟能吃吗？再见，求铁打哈。没熟能吃吗？老妹的哎呢？老妹的，来点烧的。来，说的。台個邊打導演老闆นั่นเองนี่ก็煮过之后反而是，真的。要不然跑美了，要不？不，对吧？不。跟我学做包子收费的哈，不是你什么牛马都能来的。298零，太满足了。我去拿瓶可乐。昨天帮学会啊。差不多。你可以下班那个小风车预约一个，然后等下我会联系你。